Yes, good morning, guys, to all of you. I welcome you all on this wonderful platform that is BYJU'S exam prep. Yes, Ajay, Sayak, uh, Atla, Lakshmi, Sandy, Farindra, good morning to all of you. So, guys, please tell me quickly, am I properly audible and visible to all of you? Mohan, good morning. So, guys, do like and share the session so that other students can also join. So, today is the big subject, theory of machines, we are going to cover. So guys, when we are talking about the theory of machines, it is a very important subject. I would also like to add some things about this. Before 2016, this was a subject which was the smallest one, because it was having very small topics, like it was having the syllabus like what? Displacement, velocity and acceleration analysis of simple mechanism, gear trains, flywheel, and subject was over. But after 2016, the syllabus was added too much, and now it is becoming the biggest subject. And I would like to say, after production, it is the second biggest subject. It is the second biggest subject, and also like weightage when we are talking about. Yes, Ashray, good morning. Teddy, Ajay, yes, Vineet. Ha, happy Uttarayan to you as well. So I would like to tell you that this is the second biggest subject. And weightage wise, if you are talking about the weightage wise, then weightage wise also its weightage is around 9 to 10 marks, including the vibrations part. Okay, out of that you can say 3 to 4 marks are for vibrations, and rest are for theory of machines. So guys, are we ready? Shall we start the session? So do like and share the session so that other students can also join. So today's subject will be theory of machines. And when we are talking about where you will get the PDF of this session, in production I have given you notes because it was a theoretical subject. This is a numerical subject. So here this PDF will be more useful for you. So I will share you the PDF with annotation. So don't worry. Okay. So guys, Mechanical by Dheeraj Sardana is my Telegram channel which you can join, and there you will get the PDF of this session after the session. Yes, Abhi, good morning. No issues, Abhi. So as you know, from 9th of January continuously we are having the marathons, and from long durations you are waiting for the maths and aptitude schedule. So this will be the maths and aptitude schedule for you guys, and it would be from 22nd of January to 1st of February. Okay. So you would be having first differential equation, then calculus, then matrices, then numerical methods, then complex number. After that, on 1st of February you will be having probability. Yes, Ravan, good morning. So why I am telling you all this schedule, because in mathematics we are going to have topic wise, not the entire maths in one day, because in last 10 days you also have to go with the technicals. That's why we have kept this schedule. Okay, one day maths, one day aptitude. So we will take 3-4 hours every day, one topic will be over, and that will also give you the clear picture with concept plus practice. Here SOM is over, FM is over. Okay, this is for civil, I feel. Okay. For mechanical, thermo is over. Today is going to be TOM, and tomorrow is going to be machine design. Then Monday you would be having industrial. So guys, if you want one-to-one counseling with our counselors, then you can fill the form. The link of the Google form is given in the description of this session. So you can fill that, and if you have, अगर आप आलसी है तो यहाँ से स्कैन कर लीजिए. ठीक है, दोनों ऑप्शंस आपको दिए गए हैं. Is it clear? Ronaldo, yes. Thanks for that. So guys, now you can get up to 90% of the scholarship by appearing tomorrow into this test for GATE 25 program, and there is a workshop on 17 January taken by Rakesh sir at 7:30 p.m. 7 golden rules to ace GATE 2025 in first attempt. Aniket, Aniket, tomorrow's session is there, but tomorrow's session timing will be 6 p.m. Tomorrow machine design we will be starting at 6 p.m. Okay. Tomorrow's timing will be 6 p.m. And I would like to tell you that when we are talking about this, full length mock tests are going on for GATE 2024. So they are for free, and the next test is going to be live from 13th January, means today, till 20th January. Okay, and last test will be live from 27th January to 3rd February. So only 2 mega mock challenge are left. They are full length tests. You can appear for that. Now we are starting the session. Yes, Naveen, आश्रय कास्टिंग प्रैक्टिस सेशन आज होगा. नहीं, आज नहीं करते हैं आश्रय, मंडे से करते हैं, क्योंकि फ्रॉम मंडे ऑनवर्ड्स आई विल नॉट बी हैविंग मैराथन क्लास बिकॉज टुडे इज मैराथन, टुमारो इज मैराथन. So Monday, Tuesday, Wednesday, these 3 days I am reserving for casting welding forming, then for TOM, then for machine design. 3 days, 3 practice sessions. Okay? Yes, Rampreet, Aniket, we are starting now without wasting the time. So guys, now the subject is going to be started. We are starting from the very first topic, that is nothing but simple mechanism. Okay? This would be the very first chapter for theory of machines, simple mechanism. And as TOM is a big subject, okay, so if we are going to have a good speed, and if possible we will try to complete vibrations also today, and if we find that vibration cannot be completed, in that case we would be having the vibration with some other topic, like tomorrow machine design is a small subject, then mechanics is a small subject, then industrial is a small subject. So I will add there if it is possible. Okay, if today is okay, then we will try to complete it today only, but TOM will be completed today. So when we are talking about the simple mechanism, my dear, the word simple is generally used for the things when the things are coming for the very first time, then we are using the word simple. Okay, so like the very first harmonic motion was given the name of simple harmonic motion. The very first type of gears were given the name of simple spur gear. The very first type of gear train was given the name of simple gear train. हाँ बिल्कुल 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 डिटेल में करेंगे with it. So when we are talking about simple mechanism, simple means the very first type of mechanism. And to go for mechanism, first of all we need to discuss about kinematic link or element. So when we are talking about kinematic link or element, then I would like to say it is the smallest part of a mechanism. Like we have a mechanism, so for a mechanism it is the smallest part, and when we are defining the kinematic link or element, it is the smallest part of a mechanism or a machine which would be having two things. Anything can be said to be a kinematic link. For that there are two things required. It should have relative motion with others. It should have relative motion with others. It should have relative motion with others. And second thing we are saying that kinematic link or element may be rigid, may not be rigid, but it should be a resistant body. But it should be a resistant body. Okay, it should be a resistant body. These two are the requirement for anything to be a kinematic link. Then many people are thinking, sir, is it a fixed or moving? So I would like to say it can be fixed, can be moving. Then when I say can be fixed, can be moving, people are saying, sir, you said relative motion, how a fixed thing can be having relative motion? So dear, that is the beauty. Relative motion is not absolute motion. It is similar to like a person is going ahead with some speed v. So this is with respect to earth, है ना? If I am standing on earth without any velocity, according to me, if this is moving with 10 meters per second, I will say yes, it is moving with 10 meters per second. But when this person will be looking at me, he would be observing that I am going with 10 meters per second in the backward direction, although I am at rest. He will feel earth is moving in the backward direction with 10 meters per second. So the point is, relative means this. What is relative? Relative is if somebody is in some motion, then its velocity will be given in opposite manner to the other body. इस velocity को उल्टा करो और दूसरे को दे दो. This is said to be relative motion. So whenever we are talking about a lathe machine, lathe bed is always at rest. On the lathe bed, chuck is moving. On the lathe bed, tool slides, tools are moving. But my dear, lathe bed is at rest. Yes, lathe bed is at rest. So my dear, when you are going to see anything from the lathe bed, yes, you will see chuck is moving. But lathe bed will look like rest. But when you will see the lathe bed from the chuck, you will see that lathe bed is also moving. So that is the relative motion. So that is why I said a fixed link can also be a kinematic link, because it should be in relative motion. You must have seen in the entire theory of machines, if a fixed link is present at more than one place, let us say this is one link, this is another link, this is another. So here also it is fixed. Here also it is fixed. So if you are going to have a fixed link present at more than one place, we call this as one, this as one, this as one. Why? Because this is fixed, this is fixed, this is fixed. So these three will not be having relative motion with respect to each other. So a link, if don't have relative motion, we will not be saying it to be a link. But yes, one link can have relative motion with respect to some moving link. So that is why every fixed link is given the name of 1. So that is why every fixed link is considered as a single link. Is it clear? Rampreet, Ashray, Vineet, everybody is clear? So my dear, a link should have a relative motion and it should be a resistant body. Resistant body means what? Like if I am going to have a mechanism like this, if I am going to have a mechanism like this, if I am going to apply some motion to this, some force to this, and this link is capable of transmitting the same motion here, then we definitely call that this is a link. Okay, but if this link is not able to transmit the motion, then we will not be calling it as link. So the second case can be this, second case can be this, second case can be this. When you are going to apply the motion or force to this link may get deviate. You are once again applying the motion or force, it is once again deviate, it is once again deviate, and never transmitting the motion. Then I will be saying this is not a link. This is not a link. Okay, and my dear, whenever you have the same case again, this time you are going to have this. You are giving motion, it is deviating, and after some time it is transmitting the motion. Then we will call it as a link. So for link, it may be a rigid, maybe a rigid or non-rigid body, but it should be a resistant body. Yes, Krishna, good morning. Aniket, yes. So guys, if in this case you will say it is rigid as well as resistant. Resistant means transferring the motion. Here it is neither rigid nor resistant. Here it is not rigid but resistant because it is deforming by some amount. Now my dear, rigid word you have listened to many times. Whenever we are talking about rigid, rigid means for which deformation is 0. Okay, for which deformation is 0. Like let us say if I have a spring like this, and with this spring we have a mass like this. Okay, if I am saying that I am going to apply some force, or let us say there is no mass. Let us say there is no mass, but I am applying a force over to this spring like this. K is the stiffness of this. Then you can write F is equals to K into X. How you will be defining the stiffness of this? Stiffness will be defined as F by X. And if someone is saying that this spring is a rigid body, so for rigid body, you know, displacements are not there, deformations are not there. So this X is a deformation. So this will become 0. And if this will become 0, K is F by 0, it will become infinity. So you can see stiffness is going to be infinity for a rigid body. This can be a 1 mark question in engineering services. That for rigid body, stiffness is going to be infinite. So guys, please tell me, am I properly audible, visible, आवाज आ रही है मेरी, समझ में आ रही है चीजें? And do like and share the session guys, because we are coming up every day with one marathon session for you guys. Every day one marathon session for you guys. Okay, so be ready guys. Okay, the journey will go on till the subject will be over. Yes Shreyas, yes Atla, Harsha, very good Anupam, बहुत बढ़िया. So guys, now we are moving further. The same thing is written in the notes, whatever I am saying, and this PDF will give you everything whatever is required today. Okay, so this was about kinematic link. And yes, when I teach this thing in class, I take 1.5 hours because there I give some wonderful stories. But here, as the 80-hour subject we are going to complete in 8-9 hours, we cannot go for the stories. Here this is a kind of revision. So stories I will not go for. I have given one more example, like if let us say 2 cylindrical discs. These 2 cylindrical discs are joined with a rubber band. Then sometime in the interviews it is asked that whether this rubber band is a link or not. Then my dear, many times I have given the answer for that. The link should be a resistant body. If you are rotating this cylindrical disc and in a reply this cylindrical disc also start rotating, then definitely rubber band will be acting like a link. So for this rubber band to be a link, only for this motion is required. Yes sir, is there any written notes of Tom? Dear, that will also be available on the Telegram channel. But this is a numerical subject. For this you need not to open that. But yes, after the class you can have that. That is there in the Telegram channel. Okay. Harikesh, we will try to go up to when it will be over. Okay. But yes, we will try to complete it before that because it is not that bigger subject like strength of material and production are. But yes, it is the second biggest subject. So we will try, if nothing is possible, then vibration we will be including with engineering mechanics or industrial engineering. Okay, so don't worry about that. So this is my headache, you just enjoy the class. Okay, so let's move further. So my dear, if the cylindrical disc are very small in size, like you were having the audio cassettes, in the audio cassette you were having small cylindrical disc which was traveling with the help of a small thin reel. So if that is the case, then definitely rubber band, if the inertia is less for this, if they are the small disc, if inertia is less for these discs, then definitely rubber band can act like a link. But if these big rollers, if these discs are the road rollers, then my dear, you know, rubber band will break and will not be able to transmit the power. So for road roller, I will say it is not a link. So sometime that whether something will act like a link or not, it will also depend upon the nature of, or you can say inertia of the links. Okay, so guys, with this we have defined the kinematic link or element. Now kinematic link or element are of three types. One is rigid link, other is flexible link, other is fluid link. So my dear, if your link is such that whenever you are applying the forces onto that, its deformation is negligible. I will not say deformation is exactly zero, because in this universe there is no body which is exactly rigid. So when there is no body which is exactly rigid, so I would definitely say, when I am defining the rigid link, that deformation should be negligible. Negligible means near to zero. So whenever we have negligible deformations, then my dear, such links are said to be the rigid link. The example of rigid link is, yes, cylinder of IC engine, yes, lathe bed is a rigid link. Okay, every link whatever you have seen in the solid form are generally rigid only. Like you have the crank, like you have the connecting rod, okay, like you have the slider. All these are the examples of rigid link. Then my dear, very good Shreyas. Then my dear, we are having the flexible links. My dear, if deformations are there in permissible range, then we are going to say that this is a flexible link. And my dear, for example, if we are going to have a belt drive, so you may be knowing that whenever we are going to start this pulley, initially one side is tight, other is slack. So when you are going to start it rotating, initially this slack side will become tight. So after some deformation only this will start rotating. So here this belt is an example of flexible link. This belt is a flexible link, chain is a flexible link, rope is a flexible link. So when you have belt drive, chain drive, rope drive, there you have the examples of what? Flexible link. Then we have fluid link. So my dear, there are some applications where fluid is also able to transfer the motion, and that application fluid is acting like a link, because something who is transferring the motion, we call it as a link. So when we are talking about fluid link, there are many applications. You have seen this application in the 6th class for the first time. You have studied कि here we are going to have a car, and here we are going to apply very small force, and with that we were able to lift the car. How it is possible? Because you were making it like this. You were making it like this. Here area was bigger, here area was small. So you know, force is pressure into area. So if you are applying some pressure P here, so here area is less, the same pressure will be coming here, but as area is more, it will be able to lift the car. So here this fluid was able to transfer the motion. So that is why this fluid will be acting like a link. So any such application which you say, yes, very good Darshan. So any such application, if you say, like you say hydraulic, what hydraulic? Hydraulic press, hydraulic ram, hydraulic jack, okay, hydraulic brake, okay, all these applications, hydraulic intensifier, all these applications are using the fluid as a link. So guys, you need to be with me from the first to last. I will be covering each and everything with a good explanation. even if you have not studied Tom before, you will learn much of the things, and majority question you will able to do. And today, as it is a numerical subject, I have kept so much numericals also. So with the theory, we will go for numericals as well. So don't worry about that. Okay. So my dear, this was the application. Now we are talking about the relative motion, because for a link there were two things necessary. One is relative motion, other is resistance. Okay. So now let us see what are the relative motions we are having. So when we are talking about the types of relative motion, first of all we need to understand the word constrained. This word is used every time. So my dear, constrained means restricted. Constrained means restricted. First of all, we need to see why we need this restricted or constrained motion. So let us imagine that we are having a workpiece in the metal cutting, in the theory, in the production. So this is there onto the chuck, and you want to perform a turning operation, and this is your tool. So my dear, I feel you very well know that if this will be going in this direction, if the tool will be going in this direction, then only this turning operation will happen, and this is said to be plane turning. If this will move in this direction, there is nothing happening. Moving in this direction, nothing happening. Okay, so the point is that whenever we are talking about the production, then any of the metal cutting operation will be happening only if we have the motion of the tool with respect to workpiece in a particular direction. So if we have n directions, you need to restrict all other motion but allow only one motion which will be doing the cutting. And my dear, you may be thinking, sir, what is the link of Tom and production? So I would like to tell you that we are studying Tom so that we can provide mechanisms for the motions of the cutting tools. So it is having a very good application in production. I will not say only production, but yes, you can say we are studying Tom for that one reason is production. Because Tom is something which is going to provide you the desired motion. And motion means mechanical engineering. No motion, no mechanical engineering. Okay. So we can say theory of machines is going to provide us motion for every application, whether it is automobile, whether it is production, whether it is power plant, wherever you have the motion. Motion means theory of machines. So my dear, when we are talking about constraint, it means restricted motion. Like when you started the preparation for IIT JEE in 11th class, your parents restricted all other motions. They said कि now onward neither you will go for playing cricket nor you will be going for watching TV, and even they have given you non-attending schools, means school bhi nahi jana hai. So all other motions were restricted so that you are concentrated towards studies. So that is the meaning of constrained or restricted, because the motion will be constrained. Constrained means desired motion. So this desire of IIT could be complete if you are going to restrict all other motion but study only. Okay, so that is what is required. So when we are talking about this, there are three types of constrained motion. One is completely constrained, other is successfully constrained, third one is incompletely constrained. So one by one we will see. Yes, very good, Krishna. One by one we will see. First of all, we are talking about completely constrained motion. So my dear, completely constrained motion means if system configuration do not allow any other motion to happen. Like we are going to have this as a square shaft. The cross section of this shaft is a square, and this is present in a square hole only. So this square shaft is present in a square hole. So if I am showing this as a square hole and this is a square shaft. Now my dear, you tell me, can a square shaft rotate in the square hole? Can a square shaft can rotate in a square hole? Can a square shaft rotate in a square hole? क्या एक स्क्वायर शाफ्ट स्क्वायर होल में रोटेट कर सकता है? टेल मी गाइस. यस, टेल मी, क्या रोटेट कर सकता है? कैन इट रोटेट? कैन इट रोटेट? कैन इट रोटेट? Yes. No, it cannot rotate. Very good, Abhishek. Yes, Vishal, good morning. No issues. Very good. I can understand because सर्दियाँ चल रही है, सुबह सुबह नींद नहीं खुलती है. No issues. So my dear, as you know This square shaft can only translate, it cannot rotate. So that is why here system configuration is not allowing any other motion. So when system's configuration is not allowing any other motion, then my dear, we need not to work anything else for that. Automatically motion will be going in one direction. Like there is a student who is already oriented towards study. He like the study like we like the cricket. Like I love cricket, he loves studies. So no one has to say him to study. Okay, so that is why its motion is automatically going to be constrained, and we call such motion as completely constrained. Okay, so a square shaft in a square hole is a completely constrained motion. Second is if you have a circular shaft in circular hole. Circular shaft in a circular hole can rotate also and can reciprocate also. But if we apply the collars, these are the collars we are applying on the shaft. These are the collars we are applying on the shaft. If this is the shaft, you are going to weld a plate over this side, weld a plate over that side. Now it cannot translate. Now it can only have one motion, and when you are going to weld these collar over the shaft like this, then this collar will become the part of shaft. So that is why we will say here also the configuration of system. Here also we will say the configuration of system that is not allowing any other motion. So that is why only rotation will be possible and reciprocation will not be possible after collars are applied. So this is also the example of completely constrained motion. Moving to the next, guys, is successfully constrained motion. For that, the better example I would like to say is the foot step bearing. When we are talking about the foot step bearing, that you will study tomorrow also when I will be teaching you the machine design. So when we are talking about the foot step bearing, here you can see this is the bearing. This is the shaft. This shaft can reciprocate and rotate. Both the motions can happen because bearing is also having the circular cross section only. So in a circular cross section, it can rotate also, it can reciprocate also. But my dear, what we are going to do, we are applying a force like this. So when you are applying a force like this time reciprocation cannot happen. This time this shaft can only rotate. But this motion is constrained not because of system configuration. This motion is constrained because of this external force. And that is why we call it as successfully constrained motion. That is why we call it as successfully constrained motion. Please tell me everybody understood this or not. Please tell me everybody understood or not. Very good, very good, very good. So guys, this is about the successfully constrained motion. Now my dear, for one more example for successfully constrained motion is the syringe which you were having in the childhood. When doctor was using injection, he was having a cylindrical tube like this. On this cylindrical tube there was a pin, and with this we were having a sphere, and you know in this there was a cylindrical shaft also, and doctor can give it two types of motion. One is this, other is this. So doctor was not rotating it, doctor was just giving this motion so that he can inject the medicine into your body. So here also when doctor was using this was a successfully constrained motion because it was also happening because of that external force. Is it clear for everyone? So it was also a successfully constrained motion. Now my dear, if you are having the collar only on the one side, and let us say this collar is on the one side and this is the shaft, this time you can go for this translation also, you can go for this rotation also, because circular hole in the circular shaft in the circular hole can have this motion also, can have this motion also. So that is why this is incompletely constrained or unconstrained motion. So my dear, you tell me, in production we require constrained motion or unconstrained motion? So we require constrained motion or unconstrained motion? So please tell me guys, we need constrained motion or unconstrained motion? We need constrained motion or unconstrained motion? We need constrained motion or unconstrained motion? Tell me guys, tell me guys, tell me guys. Yes, everybody. we require constrained motion. So that is why unconstrained motion is never a desired motion. Is it clear for everyone? So it is always we need the constrained motion to happen. Okay. So guys, now we are moving further. Just let me share the session because my phone was off, so I could not share in some of the groups. Okay. Fine guys. So now we are starting. Okay. Don't worry. Okay, so my dear, this is unconstrained motion. So some students have a doubt, sir, whether we need completely constrained motion. So I would like to say we need a constrained motion. Now whether this constraint is coming from the system configuration or this is coming because of external force, it doesn't matter for us. Like if you reached to PSU, a very good job you will be doing, or you reach to IIT after IIT JEE exam, then my dear, whether you went there by yourself, that you were not having any other things to do, or your parents have tortured you, you have to study. So whether you go with the external or you go with the internal, after that it doesn't matter. So that is why we want constraint. It may be completely, it may be successfully, it doesn't matter for us. It hardly matters for us. So my dear, now we are going to talk about the kinematic pair. The study of link is over. Okay. Here also first chapter is slightly lengthy. All other chapters will not take that much time because we are not going for derivations. Okay. Now my dear, we are talking about kinematic pair. So you know that pair word is used whenever two peoples are joined with each other. So when two links are connected like this, or with any motion, like this is a slider, this is a link. So any connection between two links is said to be a pair. But the word is not pair, the word is a kinematic pair. So a pair is said to be kinematic if the relative motion is a constrained motion. If relative motion is becoming a constrained motion, it may be completely, it may be successfully, then my dear, we call a pair to be a kinematic pair. Now you tell me, if I am saying that any connection between two links is said to be a pair or a joint, but that pair is kinematic pair only when the relative motion is a constrained motion. So you tell me, can I say every kinematic pair is a pair, but every pair may or may not be a kinematic? Like, can I say if this is a set of pairs, this is a set of pairs, then from that some may be kinematic pair. Is it clear? So every kinematic pair is a pair, but every pair may or may not be kinematic. Is it clear or not? Please tell me. Yes, Abhishek, Harikesh, Vinay, Atla, Shreyas, Deepshika, Anupam, Darshan. Very good, very good, very good. Krishna, Ashray. Wonderful guys. Wonderful. Anupam, bahut badhiya. So guys, every kinematic pair is a pair, but every pair may or may not be kinematic. That's great. So guys, now we are talking about the classification of kinematic pair. So when we are talking about, yes Rutvik, so when we are talking about the classification of kinematic pair, the very first classification can be according to the type of relative motions. So my dear, whenever we are going to have the very first pair according to that, that is said to be the turning pair. It is also known as revolute pair. It is also known as pin joint. It is also known as rotary joint. All these are the name used for turning pair. And it is shown like this, like one link connected with this like this. Or you can have the second turning pair like this. So when the relative motion between two links is the rotation motion, like you have a circular shaft in a circular hole. So when you have the relative motion between two links as a pure rotation or turning motion, we call it as turning pair. Like here you can see about this point it can rotate, about this point it can rotate, here this can rotate. So relative motion, shaft can rotate, okay, and bearing is fixed here, let us say. So my dear, whenever you have this type of pairs, they are said to be turning pair, where the relative motion between the links is a pure rotation. So that is said to be a turning pair. Everybody is understood turning pair. If you want to see in our body, this pair is turning between this link and this link. This is a turning pair. Is it clear? Is it clear? Yes, dear. Whenever you have one link is rotating with respect to other, but it is not translating, it is said to be a turning pair only. Okay. So then we are talking about the sliding pair. Sliding pair is also known as prismatic pair. So now, my dear, if you are having a cylinder like this and you are having a piston, you know piston is generally circular. So piston can rotate also, can reciprocate also. But if you are going to provide a connecting rod, now this cannot rotate. Now this piston can have only this type of motion. So in the cylinder piston arrangement, between the cylinder and piston is sliding pair. Even if you don't use connecting rod, between cylinder and piston it is sliding pair only. Okay, so you can also show like this. This is a slider, this is a fixed link. So between them the motion is going to be a sliding motion. So if relative motion is a pure translation or sliding, we call it a sliding pair. So understand this. Here relative motion is pure rotation because classification is based on relative motion. So I am telling you there are only two types of absolute motion. One is pure rotation, other is pure translation. Other is pure translation. And my dear, any other motion can be made only with the help of these two motions. So that is why we need to understand the characteristics of these two motion. Is it clear? So when we are talking about these two motion, like if this body you are saying it is in the pure translation, then you can say the characteristics is the speed of every point will be same. Pure translation have the linear speed same for every point. If you are saying this body is moving with a velocity of 5 meters per second, then I can say every point on this body will be moving with the 5 meters per second. This is the identification of pure translation motion. Is it clear for everyone? Then my dear, whether this body can be of this shape also. If you are going to have the skidding is going to happen of your wheel of the car, then also my dear you will feel in the skidding it is not rotating, but it is going to get slide. So that is why every point is having the same velocity. So when this type of motion happens, we are going to say it is going to be nothing but the pure translation. So pure translation motion is having every point have same linear or translation velocity. Okay, now my dear, we have also written pure rotation. In pure rotation, let us say there is a body where we are going to have one point fixed. Now about this point, if this body is rotating with omega angular speed, then you know that whatever point you take on this, angular velocity will remain omega only. But you know linear velocity is r omega. So that is why here the velocity will be 0 and here velocity will be r1 omega, r2 omega, r3 omega, r4 omega. Likewise linear profile you will get. है ना? Why? Because it is r omega. So velocity is variable here, but omega is same for every point. So here omega is going to be constant for every point. So in the rotation omega will be same, in the translation velocity will be same. Moving further to the next point, guys. Next is rolling pair. So my dear, whenever the relative motion, very good Krishna, very good Harikesh, whenever the relative motion is pure rolling, then we call such pair as rolling pair. Now you may be thinking, sir, what is rolling? You said just two types of motions are there. I said two types of absolute motions are there. All other motions are derived from those two. Like when we are talking about pure rolling, it is derived from pure translation plus pure rotation. So when we are going to join both the motion, we are going to have pure rolling. What is the condition for pure rolling? Like I am saying this body is rotating with omega with a condition that point of contact will be having zero velocity. So if this point of contact is A and I am saying velocity of A is 0, this is the condition for pure rolling. Means this body will go with omega, but this point of contact will be at rest. This point of contact will not be having any linear velocity. But you know from the pure rotation that when I am going to give rotation with omega to this body, then the speed or velocity profile is coming like this. Okay, if this is 5, this is minus 5. So you know this is the velocity profile for rotation. Then my dear, I said if you want to make it rolling, you need to add a velocity of 5 meter per second to all the points, which can be added in the pure translation, and this is pure rotation. Now if you add both of them, can you see that this is 5, this is 5, overall will become 10. This is 0, this is 5, overall will become 5. And this is minus 5, this is plus 5, overall will become 0. And this will be the velocity profile for pure rolling. So that's why we say pure rolling as a combination of pure translation plus pure rotation. Sir, cam and flower is open pair. Dear, open pair, closed pair, cam and flower can be both. That I will teach you in the cam and flower, don't worry. It can be open also, it can be closed. We will see that. Actually, when we say open or closed, actually whenever we are talking about open and closed, we will see there are two configurations of cam and flower. In one configuration, cam will be inside the flower, and in other we are going to have the spring present. So there we will be having it forcefully closed pair. Okay, so we will see that, don't worry. For the timing, don't get confused, and others will also be confused, because we are not talking about that pair here. We are talking about rolling pair. So everybody understood the rolling pair and how it is the translation plus rotation. Because my dear, you can see translation plus rotation, here minus 5, here plus 5. That is becoming 0. So here this is the velocity profile for pure rolling motion. And this is the condition for pure rolling. So my dear, whenever you have this, we call such pair as rolling pair. So guys, every day we are going with one marathon. Today is the number of Tom. And tomorrow we have machine design at 6 p.m. Okay, mind it. So my dear, now we are moving to the next pair. Are we ready? Next pair is the screw pair. In the previous case, some student can have a doubt. Sir, you told that anything is a kinematic pair when the relative motion is a constrained. Constrained means a single motion. But here we have two motion. One is translation, other is rotation. Then if that is the case, how you can call it as a kinematic pair? It should be a pair only. I will say no, it is a kinematic pair only. Why? Because yes, you can see there are two motions, but these two motions are not independent motion. If this velocity was minus 5, this have to be plus 5. If this is plus 4, plus 3, plus 6, plus 7 for any other value, you will not get pure rolling. So you are getting pure rolling only if the velocity of translation is equals to the maximum velocity of rotation. And that is why both the motions are depending on each other. And when two things are depending on each other, we will be calling it as a one independent motion. So there are total two motion, but both are depending on each other. So we will call it as a single independent motion. Good morning, Sandeep. Tomorrow machine design will be at 6 p.m. Tomorrow it is not going to be at 10 a.m. Tomorrow timing will be 6 p.m. Okay? Is it clear? So एक रात में भी रख के देखते हैं कैसा रहता है, ठीक है? Is it clear? And the practice session of Tom, MD and production will go on Monday, Tuesday, Wednesday. Be ready for that, because Monday, Tuesday, Wednesday your marathons are going to be smaller. So we can easily have practice session in between. Okay? Moving to the next. Screw pair. So my dear, everybody would be aware of nut bolt connection. And you know that this is the bolt. On this bolt we are having the nut like that. And here also many students have confusion. So this type of pair is said to be a screw pair. And you know that whenever you are going to rotate the nut over the bolt, it is going in this direction and that direction. You are giving rotation, but it is going to have rotation also, rotation plus reciprocation also. And you also know that one rotation will make you reach to one pitch distance if it is a single start thread. So my dear, here also two motions. Nut is rotating and one is reciprocating. Faninder, machine design is a small subject. It is not big like Tom. Okay? Forget the syllabus of machine design is smaller. So if we will start at 6, maybe we will be closing at 1, 12 or 1, okay. Only for tomorrow this we are doing. All others will be at 10 a.m. Okay, don't worry about that. सिर्फ कल का ऐसा कर रहे हैं, ठीक है. And that also we are doing it to avoid the clashes, okay. Is it clear for everyone? One rotation will give you one pitch. So here also rotation and reciprocation, they are linked with each other. Clear for everyone? Okay, Fanindra, don't worry about that. We will discuss later. Right now, let us concentrate on theory of machines. Okay, we will talk about that later. Is it clear for everyone? Is it clear about this? Everybody is clear about the screw pair? So my dear, in the screw pair also independently only one motion, because rotation and reciprocation are related with each other. Moving further guys with the next pair, that is spherical pair. So if you want to see the spherical pair, in your body God have given you so much pair. This pair is a screw, this pair is a spherical pair. You can see it is rotating about this axis. You can also rotate it about this axis. And you can also rotate it about this axis. So this is said to be three-dimensional rotation. This is said to be three-dimensional rotation. So my dear, 3D rotation is going to happen in this pair, that is said to be spherical pair. For this there are many other examples like ball and socket joint. Ball and socket joint. Like you must have seen joy and joystick. Joy and joystick. Okay, do you remember there was a time, I remember when I was in college, there was a mobile coming for BlackBerry. BlackBerry mobiles were coming, and in that mobile, in the center there was a ball. And I remember that the same phone then copied by Micromax. Micromax also was a company at our time. It also boomed a lot. Also they have given sponsorship to the many cricket series as well, okay, to BCCI. So my dear, that's what I want to say. That is also an example of this spherical pair. So spherical pair means 3D rotation. Okay, do you see your bike mirror, your bike mirror, your car mirror, the side mirrors I am talking about? So those side mirrors can also have three-dimensional rotation. Yes, balls, mouse. Some heavy mouses were coming in which a heavy ball was there. All these are the examples of my dear spherical pair. So I have given you examples of every pair. Yes, Sumit, good morning dear. So we have discussed example of everything other than this rolling pair. For rolling pair, the example is ball bearing. Whenever we have the ball bearing, you know there is an inner race, there is an outer race. And in between inner and outer race, we are having some balls. So here if you will see the motion of inner and outer race, the relative motion between inner and outer race is nothing but the pure rotation. And my dear, the motion of balls with the inner and outer race is the pure rolling. So that's why deep groove ball bearing is the example of both the types of pairs. Yes, our elbows are having the spherical pairs. Okay, that is what ball and socket joint is. So moving further guys, we have seen one classification. Here you can see between this and this, we have turning pair. But this is having pure rolling motion between these two. So there are two types of pair which are coming into picture. Now the second is based on the type of contact. We have lower pairs, we have higher pairs, we have wrapping pairs. So my dear, whenever we have the type of contact between two links as a surface contact, whenever we have the type of contact between two links as a surface contact, we call it as lower pair. And whenever the contact is a point or line contact, we call it as higher pair. First, let us see what is lower and higher pair. Like we have a follower like this. So guys, any place you find any doubt, you can ask me. This is a cam. This is a follower. So my dear, you can see between these cam and follower, what kind of contact is there? This is a point contact. This is a point contact. Okay. And my dear, even if you will see this in 3 dimension, then this cam will look like this. Sorry, this follower will look like this. So then it will be having the line contact. And if you are going to talk about rolling pair was also having a point contact. So rolling pair, cam and follower, they are the example of higher pairs. And when we are talking about the lower pairs have surface contact. Like you are going to join two things with the turning pair, like these two. You can see between these two there is a area contact. Like let us say you want to make a turning pair between these two bodies. You would be having this pin between these two bodies. So you can see there is a surface contact. Surface contact means what? Surface contact means what? This is lower pair. So surface contact, area contact means lower pair. So my dear, we are going to have lower pair as turning pair, sliding pair, spherical pair, है ना, screw pair. All four pairs are the example of lower pairs. Only rolling pair is the example of higher pair. Cylinder piston is lower pair, yes. Atla, whenever we are talking about ball bearing, if you are talking about inner and outer race, this is said to be inner race. Actually, this we are going to study tomorrow in machine design. This is outer race. So out of this inner and outer race, one race is fixed, other is moving. Out of these two races, one is fixed, other is rotating. So if you are going to have this race as fixed and inner is rotating, then between inner race and outer race, relative motion is turning, pure rotation. At the same time, when we are talking about the balls are present like this. So the relative motion of these balls with the inner and outer race is going to be the pure rolling. Is it clear, Atla? Is it clear? So now we are moving to this example. Revolute pair is a lower pair. This is a lower pair. This is a lower pair because in nut bolt also we have complete surfaces are in contact. Okay. So you can see this planar pair is also a lower pair. Spherical pair is also a lower pair. You can see in spherical pair also how much part is in the contact. This is the surface contact only. So my dear, surface contact lower pair and point and line contact higher pair. So the example for higher pair is rolling pair and cam and follower. Follower can be of this spherical ball type. Okay, so these all are the example of higher pair and lower pair. Now what is the third pair? Wrapping pair. If one body is wrapped over another, we call it as wrapping pair. Like we have pulley, on the pulley there is a rope. Like we have belt. So all these examples are the examples of wrapping pair. So for wrapping pair, the example is belt drive, rope drive, chain drive. But sometimes they are asking that belt drive is a type of pair and they don't give wrapping pair in the option. They are asking you lower pair, higher pair, both of them, none of them. Then in that case, I would like to tell you, if you are going to have this pulley versus rope, it looks like a surface contact. Generally, students are saying it is a lower pair. But my dear, in reality, it is going to consider as a higher pair. The reason is, this pulley is not having the clean surface, but have some surface roughnesses. Similarly, rope is also having the surface roughnesses. Because of that, the contact between rope and pulley is not the surface, but at multiple points. So that is why we consider it as a higher pair. You may be thinking, sir, in that way, cylinder piston when we talk about, in cylinder point also the same thing can happen. So the answer is no. Because in cylinder we are going with the micro finishing processes like honing. We will study in metal cutting. So because of that, cylinder surface is very, very clean. So because of that cleanliness of the cylinder surface, the same problem is not there. So when we have cylinder piston, it is only lower pair. But my dear, when you have wrapping pairs, belt drive, chain drive, rope drive, then if you don't have the example of, if you don't have the option of wrapping pair, you will go with higher pair. I feel everybody understood. Now my dear, I am going to give you the relation between higher pair and lower pair. Relation between higher pair and lower pair. So let us say, my dear, here we are having a cylinder piston arrangement. We have a piston like this with that connecting rod, with that crank and crankshaft. If you see this, here you know when slider will be reciprocating like that, crank will be rotating like that. So here we are having rotation, here we are having reciprocation. This is the relative motion. And similarly, if we take a cam and follower, this is a cam, this is a follower. Better we consider a different type of follower, that is knife edge. We are having this as follower. Because till now we have not studied this chapter now. So here also you know cam will be rotating, follower will be reciprocating. So relative motion between them is of same type only. So if you are having these two mechanism in the eyes of theory of machines, theory of machine की नजरों में both are same, because theory of machines means the relative motion, and until and unless they are giving me the same relative motion in my eyes, they are same for me. Okay, they are like two children to the parents, both are giving the same things, they are same. But my dear, if you will see between rotation, reciprocation, no doubt relative motion is same. But if you see the configuration, this is link number 1, this is link number 2, this is link number 3, this is link number 4, this is link number 1. So total number of links are 4. Here if you see, this is link number 1, this is link number 2, this is link number 3, every fixed link is link number 1, so number of links are 3. Then my dear, if you see, this is a turning pair, this is a turning pair, this is a turning pair, and between 1 and 4 is a sliding pair. So we have 3 turning pair, 1 sliding pair, but all 4 are lower pairs. But here when we are talking about, this is a higher pair, point contact. This is a turning, means this is a turning pair. This is a sliding pair. So you can say here 1 turning pair, 1 sliding pair, 2 lower pairs, plus 1 higher pair. So if you are going to compare both the mechanisms, number of links are 4, number of links are 3, but here 1 higher pair is there. So can we say whatever work is done by 4 lower pair, the same is done by 2 lower pairs plus 1 higher pair. It means I can say 1 higher pair is going to be equivalent to 2 lower pair. That's why, my dear, we are not saying equal, we are saying equivalent. So whatever the work here is done by 2 lower pairs, here the same is done by 1 higher pair. So we are saying that 1 higher pair is equivalent to 2 lower pairs. Is it clear or not? Please tell me. So that is why we are saying 1 higher pair is equivalent to 2 lower pairs. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Yes, yes, yes. Please tell me that. Everybody is okay with this? Everybody is okay with this? Fine, fine, fine. Wonderful, guys. So now we are moving further. We have already seen these 3 types of pairs. Okay, for cam and follower, actually we have self-closed and we have forced closed. So when we are talking about open pair, now I am going to talk about that. Generally, if you would be having the open pair, pair will not be able to maintain the contact. So that is why we always try to make it close. Now that close can be made by external force and can be made by internal. Like external force, here if cam will be rotating, it will be giving force to the follower and contact between cam and follower can go. We never want this to happen. We want always the contact to be maintained. So because of that reason, we are always providing a spring here, which is always under compression, and try to maintain the contact between them. Is it clear? So that is why it is either forced closed or self closed. So when we are talking about self closed, here cam is inside the follower. So contact between cam and follower will always be maintained. Okay. So now we are moving further. You can see this. This is the example. This is with the external spring is present up. Here it is internal. Everybody is clear? So with this we have completed the classifications of pairs. Now we are going to move ahead with the joints, and then we will see kinematic chain, and then numerical part will be starting. So whatever part I teach in 3 hours in the class, that is we have covered in 1 hour. Rest part will going on in good speed because derivations we need not to do. So when we are talking about the joints now, so my dear, there is one joint said to be binary joint. When two links are connected with each other at one place, that joint is said to be binary joint. This is a binary joint. This is a binary joint. This is a binary joint. Okay, so all these are the example of binary joint. Then my dear, you can see next is ternary joint. When three links are connected at one place, we call it as ternary joint. This is an example of ternary joint. The second is a cylinder, piston and connecting rod. Here also three links are connected together. So we call it as ternary joint. I would like to say that sometimes they are asking one ternary joint is equivalent to how many binary joint. So if I say one binary joint is between 1 and 2, other binary joint is between 2 and 3, then if I have made the binary joint between 1 and 2 and 2 and 3, the binary joint between 1 and 3 is automatically formed. I need not to form that. So that is why always remember one ternary joint is equivalent to two binary joint. Because in the formulas we have the term of binary joint only. Very good, Shreyas. Bahut badhiya. Moving to the quaternary joint. When four links are connected at one place, we call such joints as quaternary joint. So this is a quaternary joint. And one quaternary joint with the same logic is equivalent to three binary joint. Is it clear, guys, for everyone? Everybody got it? The types of joints? Yes. Now we are moving to the kinematic chain. Before kinematic chain, we need to understand the chain. So you have studied many times, you have seen many times in your childhood, the cycle is having a chain, you are having chain in your this, like my hand is also having a chain. Can you see this? Yes. So what is this chain? Actually, if first, like this, I am making something, all these are the links. All these are the links. So this was the first link, this was the last link. When first and last link are connected together, we call it as a chain. Like you have studied the cycle. If initial and final point are same, we call it as thermodynamic cycle. Yes or no? So in cycle, there were minimum two processes. For chain, you should have three. Without three number of links, because one is first, other is last, third one is joining them. So guys, here this is a chain, but my dear, when we call this chain as kinematic chain, if the relative motion between all the pairs is a constrained motion. So it is the constrained motion which make a pair kinematic, which make a chain kinematic. So you may be thinking, sir, what is the benefit of this kinematic word? Why we are so much concentrated on that? So my dear, I would like to say the reason behind that is because we are going to make mechanism with the kinematic chain only, and the name of your chapter is simple mechanism. So now we are going to enter in the world of mechanisms. So my dear, when we are talking about a kinematic chain is becoming a mechanism when we are going to fix one link. You may be thinking, sir, why we want to fix one link? Because inputs and inputs are given and outputs are taken with respect to that fixed link. I would give you a wonderful example. When you enter into the engineering drawing lab for the first time, you are having drafter, you are having folder. So whenever you want to use that drafter, first of all, you fix that drafter with the table. So if you want to use any machine, any mechanism, you need to have one link to be fixed. Because inputs are given with respect to fix, output are taken with respect to fix. So fix is mandatory. So whenever you are going to fix one link from a kinematic chain, it becomes a mechanism. And whenever you are going to use a group of mechanisms, whenever you are going to use a group of mechanisms to get the work output, then my dear we call it as a machine. So machine can be a mechanism or a group of mechanism. So my dear, that is why for mechanism the first step is kinematic chain. That's why we are so much worried about that. So I would give you some examples here, and conditions for kinematic chain are, the very first condition is L is equals to 2p minus 4. Second condition is J is equals to 3 by 2L minus 2. These two are the conditions. If they are satisfied, any of them, both of them will be satisfied. So you can check any one. Here L is the number of links, P is the number of pairs. It is very difficult to identify the kinematic pairs. So we would be saying J is the number of joints, L is the number of links. So here identification is easier, so we use this equation. For example, if I am going to show you the very first kinematic chain will be with the 3 links. Yes, very good Abhi, very good Krishna. So when we are talking about a mechanism with 3 links, let us say this link is fixed. So if we are saying this is link number 1, this is link number 2, this is link number 3. Okay, here how many links are there? Links are 3. If we are talking about the joints, this is 1 joint, 2 joint, 3 joint, and all the joints are binary joints. So J are also 3. So your left hand side is 3. What is right hand side? Right hand side will be 3 by 2L minus 2. So 3 into 3 is 9 by 2 minus 2 is 2.5. So you can see left hand side is not equals to right hand side. My dear, when left hand side and right hand side are not equal, when left hand side and right hand side are not equal, we will not be calling it as a, we will not be calling it as a, we will not be calling it as a kinematic chain. So if left hand side is not equals to right hand side, we will not be calling it as a kinematic chain. We will not be calling it as a kinematic chain, and then we will see which one is bigger. You can see left hand side is going to be bigger than right hand side. Then we call it as a frame or structure. We call it as a frame or structure. Is it clear? Very good Atla, very good Abhi, bahut badhiya. Are you getting it, guys? Just keep on commenting also at the same time. I am teaching you each and everything in a good detail that will be making you clear for the exam. Don't worry. Every topic, like yesterday when we have done casting, welding, metal for sheet metal operation, we have done everything with numericals. Here also questions will be there. Similarly, my dear, whenever we would be having a 4-link mechanism, 1, 2, 3, 4, then my dear, you can see the number of links are 4. Joint, 1 joint, 2 joint, 3 joint, 4 joint, all are binary joints. So J is also 4. So my left hand side is 4. What is right hand side? 3 by 2 into 4 minus 2. It is also coming out to be 4. You can see left hand side is equals to right hand side. Whenever this happens, we will be calling it as, yes, it is a kinematic chain. We were very happy. This was the very first chain which was useful to us. 3-bar chain was useless for us because it was a frame or structure. But it was of use for civil engineering peoples, because civil engineering peoples are using, okay Krishna, left hand side is this, number of joints, it is 3. Right hand side is 3 by 2L minus 2. Put the value 3 by 2L minus 2, you will get 2.5 because links are 3. Both are not equal, so it is not a kinematic chain. Left hand side is more than right hand side, so it is a frame or structure. The same I repeated here. Here there are 4 links. Joints are 1, 2, 3, 4. So left hand side is joints. The formula left hand side. The formula right hand side. Is it clear? LHS, RHS is left hand side, right hand side. So my dear, whenever we are talking about this, we were not so much sad about this. Maybe they are not useful for us, but they were useful for civil engineering peoples. So maybe not for us, for our brothers it was useful, we were happy. This was useful for us, we were more happy. And this was a condition of utmost happiness because we got our first kinematic chain. So that is why it is said to be simple kinematic chain, simple 4-bar kinematic chain. And when you will fix a link, it is said to be simple 4-bar mechanism. Why simple? Because it was the first mechanism we got. Then my dear, if you would be having 5 links, 1, 2, 3, 4, 5. Links are 5. 1, 2, 3, 4, 5. 5 are the joints. This is our left hand side. Then right hand side is 3 by 2, L minus 2. It will be 5.5. Once again we are having left hand side not equals to right hand side. And when this happens, we call it as not a kinematic chain. Not a kinematic chain. But this time we have right hand side to be more than left hand side. And here we call it as unconstrained chain. Everybody remember unconstrained chain? That relative motion is not constrained. So these chains are of no use. They are useless chain. They will neither be used by us, neither be used by anyone else. But my dear, I am telling you, this is the past of these chains. Nowadays, these chains are even more useful than the kinematic chain. And I will give you an example. Like when I give you, there is a epicyclic gear train, there is a compound gear train. You know, epicyclic gear train is better. So epicyclic gear train is an unconstrained chain. So we will see that the concept of degree of freedom will make unconstrained chain more useful than the constrained chains. Okay, so for the timing you may be feeling they are useless and you don't even like to spit on that, but there will be a time after degree of freedom when you will be keeping those chains on the head. Is it clear for everyone? Krishna, Atla, Abhi, Ashray, Shreyas, everybody is okay getting it? Please tell me. Is it clear for everyone? Yes, everybody. Okay, guys. Yes. Moving further, guys. Now we are entering into the concept of degrees of freedom. So my dear, whenever we are talking about the degrees of freedom, this is not you are studying for the first time. Yesterday in thermodynamics also you have studied from the Vipin sir the same thing, degrees of freedom. But I would like to tell you, degree of freedom is a physics which can be used anywhere. Like when you have studied that in thermodynamics, it was the number of independent variables required to, number of independent intensive variables required to define the state of a system. But in thermodynamics, we are interested in the state of system. Here we are interested in the motion. So we would say here the number of independent motions. Number of independent motions. Number of independent motions. That is said to be the degree of freedom. Like if I have a body in 3D space, then my dear, a body in 3D space can have what type of possible motion? It can translate in X direction, it can translate in Y direction, it can translate in Z direction. So we are having 3 translation motions. It can rotate about X direction, it can rotate about Y direction, it can rotate about Z direction. So we have 3 rotations. When these 3 rotations we are adding, degree of freedom is becoming 6. But mind it, this is the degree of freedom for an independent link which is not having any pair with anyone. This is the very first topic from where questions will start coming in the GATE exam. Whatever we have studied till now in last 1 hour and 20 minutes, that was just the fundamentals. From this topic the questions will start coming, and from here theory of machines is completely going to be a numerical subjects. Okay, so from now we will see the formulas, the results, the questions, okay, everything. And I will teach you in such a way, even if you don't have studied anything till now, after attending this session, you can very easily do the questions from theory of machines. Okay. So when we are talking the maximum degree of freedom, it is coming out to be 6. But some sunky people, crazy people, they are saying degree of freedom is 12, not 6. How 12? They are saying if I am moving in this direction, this is positive x. If I am moving in this direction, this is negative x. Similarly, if I am going up, it is positive y, going down is the negative y. If I am coming towards you, is the positive z, going back is the negative z. You know, right hand thumb rule is followed. If this is x, this is y. Keep your finger towards x, rotate them towards y, thumb will give you z. So this will give you z. Is it clear? So it always follows right hand thumb rule. So my dear, whenever we are talking about this, yes, 12 can be considered like that, because then these 3 translation will become 6 translation. 3 rotations will become 6 rotation. Why this? Because one will be positive x, positive y, positive z. Other will be negative x, negative y and negative z. And rotation also, clockwise about x, y and z, and anti-clockwise about x, y and z. So likewise we would be having 12. Okay, no issue Ajay. So my dear, whenever we are talking about this clockwise or anti-clockwise, you may be thinking, sir, in theory of machine, does it matter? No, it does not matter. So that is why in theory of machine, we generally consider 6 degree of freedom only. But when we are talking about the jigs and fixture in production, you know, when you are having a shaft like this and you want to go for the plane turning operation, then my dear, if this is your tool, when your tool will be moving in this direction, cutting will happen. But when your tool will be moving in this direction, cutting will not happen. So here positive x and negative x will have different meaning. Because for negative x cutting will happen, for positive x cutting will not happen. So in production it will become the important, but right now it is not important. For Tom, we are interested in motions. We are not interested in whether the motions are coming in positive x, minus x, clockwise, anti-clockwise, because we are interested only in motion. So that is why we would be considering degree of freedom to be 6 only. But this is the degree of freedom for an independent body, like you are living alone in a house. There is no owner of that house. You are living alone. You can come at any time. You can go at any time. You can come with anyone. You can go with anyone. No restrictions are there. We are calling degree of freedom to be 6. But when you are living with someone, even if your father, your mother, your parents, your brother, your sister, your wife, your family, if anyone is there, then my dear, the degree of freedom you cannot enjoy like 6. Then degree of freedom will be compromised. So whenever we are going for some relation, then my dear, degree of freedom will become 6 minus r, because every relation is going to give some restrictions. Like whenever you are living with your wife, then you cannot be with anyone else. That is the restriction there. If you are there with your parents, okay, screen is blurred, just wait. Just wait. Just wait guys, just wait, I'm talking to some of the team member. Okay, just wait for a second.
You have called is speaking to someone else. You can wait or call it.
Hello, 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 hello. Hello. Now volume is coming, guys. Voice is clear now. Please tell me, voice is clear? Very good. So let us continue, guys. So we were talking about that whenever pairing is going to happen, pairing is imposing the restriction. Pairing impose restriction. So my dear, when pairing is imposing the restriction, R is nothing but the number of restricted motion. R is nothing but the number of restricting motion. Number of restricting motion. So my dear, I will give you some examples now for number of restricted motions and degrees of freedom. Like, let us say I am going to make a example of turning pair. So just feel that we are having the turning pair between these two lengths. Okay. So I would like to tell you, whenever we say the number of restricted motion, any such motion is a restriction which is breaking the bond between them. So I am talking about this link, they are connected with the turning pair like this. My dear, if I am going to take it, translate in the x direction, the connection will be broken. So the motion of x direction translation is not permitted. It is a restricted motion. If I will take this in y direction, then also the connection will break. It is not permitted. When I will take this in the z direction, then also it will break. है ना? So x, y, z, all translation are not permitted. But my dear, now if I will start it rotating about x-axis, it will rotate about x-axis like this. Then also the connection will be broken. If it is going to rotate about y-axis, that is permitted. That is permitted. Yes, this can happen. But if I am going for rotation about z-axis, this is z-axis now. About this, the rotation will happen like this. Once again, the connection will be broken. So can you see, whenever we are talking about turning pair, about x, y and z, translation, 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 they all are permitted. Sorry, not permitted. When we are talking about rotation, 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 these two are not permitted, only this is permitted. So if you see this example, you can very easily say degree of freedom is 6 minus r, r is 5, r means restricted, degree of freedom will be 1. So degree of freedom for turning pair is going to be 1. Yes, is it clear for everyone? Is it clear for everyone? So moving to the next. So guys, here if you see the sliding pair, not sliding pair, the screw pair. When we have screw pair, here you can see this bolt and nut. If this is the bolt, this is the nut. So you know that whenever we are going to see this nut is coming in this direction, and it is also rotating about this direction. So if I have a bolt and nut, this is going to rotate in this way. Okay, Shubham, are you talking about the previous case or this case? Are you talking about previous case or this case? Are you talking about previous case or this case? Tell me, are you talking about previous case or this case? Previous case or this case? Previous case. So dear, whenever we are talking about the turning pair, just imagine you are having turning pair between these two bodies. If you are going to take this link in x direction, connection will break. You take in y direction, connection will break. You take in z direction, connection will break. So if connection is breaking, it means these motions should not happen. That's why these motions are restricted motion. If you are going to rotate about x-axis, x-axis is this now. So about x-axis rotation will be like this. Once again connection will break. If you are going to rotate it about z-axis, then also connection will rotate. But if you are going to have rotation about y-axis is this, then there is no problem because both can rotate about y-axis. And turning pair is just like husband-wife connection. This is only permitted if you are always rotating along with each other. So this motion is permitted. So that is why degree of freedom came out to be 1. Then we are talking about the second case, that is the That is the nut bolt connection. Let us say this is X, this is Y, and this is Z. If you are keeping the bolt and nut in this, like this is the bolt and you are having the nut over it, you can see here nut can rotate about x-axis and can translate up in the x-axis. You cannot take nut out in the y direction. You cannot take nut out in the z direction. You cannot rotate nut about y-axis. You cannot rotate nut about z-axis. So only two motions are permissible. One is translation about x and rotation about x. Rotation about x, translation about x. Neither you can take this nut here nor here. Neither you can rotate it about x-axis, about y-axis. Y-axis about this rotation is not possible. है ना? It can rotate only about x-axis. So I would like to say here restrictions are 4. So degree of freedom will be 6 minus 4, that is 2. Clear for everybody? Clear for everybody? Yes, in the doors, whenever you are having the doors, you are using a kundi. That kundi is going to be like this. Have you seen that? That also can rotate and translate. So for that also degree of freedom is 2. So that is said to be a kind of cylindrical pair as well. We call it as a kind of cylindrical pair as well. Is it clear? Like if you have a cylinder, a piston. Piston can reciprocate, piston can rotate. Only two motions are possible, degree of freedom will be 2. Clear for everyone? Clear for everyone? Yes. Then my dear, we are going to have some other example which I will be showing you. Let us say we have a spherical pair. You can rotate about any of the 3 axes. But you cannot translate your hand. If you would be taking this away, then translation is not possible. Otherwise, आपका हाथ आपके हाथ में आ जाएगा. So that is why I would like to say whenever we are talking about the spherical pair, then my dear, for that there are restrictions 3. In all x, y, z, translation is restricted. So degree of freedom will be 6 minus 3. It is coming out to be 3. Very good, very good, very good, Faninder, very good. One more example I would be giving you here. If you are going to have a table, on this table we have a cylinder. This is cylinder on table. Cylinder on table. Cylinder on table. Like my dear, let us say we are going to have this as a table. I am showing you a notebook as a table. This is a table, this is a cylinder. Here you can translate in this direction, you can translate in this direction. But if you will translate in this direction, the contact will be broken. So y direction translation is not permissible. You can rotate it about x, you can rotate it about y, but you cannot rotate it about z. So my dear, here two restrictions are there. Here two restrictions are there. So degree of freedom will be 4. Then my dear, you can have this table and there is a sphere on the table. I can show you a sphere on the table, just give me a second, because I am having a ball with me. So I can show you practically, it will be giving you more feel. So let us say this time I have this sphere and this is the table. I can translate in x, translate it y, but cannot translate in z. But I can rotate it about x, I can rotate it about y, I can rotate it about z. So only one motion is not possible. Only one motion is not possible. So restriction is 1. Degree of freedom is 6 minus 1 is 5. And if we have an independent body without any connection, then restriction is 0. Degree of freedom is 6. So you can say degree of freedom can never be 6 with a relative. If any pair will be there, degree of freedom will reduce only. Is it clear for everyone? Is it clear for everyone? Dear, for square on table will also be the similar way. Square can translate like that. Okay, it is like that. But that square cannot have this type of rotation. So accordingly you can check it. Is it clear? ऐसे तो infinite examples आप check कर सकते हो. Is it clear or not? Everybody understood? Okay, Atla, you are telling me or you are asking something? Yes. Are you asking me or you are answering something? So please tell that. I didn't get. Okay. Fine, fine, fine. So guys, this is about the degree of freedom. But the point is, in our syllabus, majorly we need to go for, okay, you are asking, like you are going to have this square on the table. If you are having this square on the table, then this square can translate here, but cannot translate here. One translation is restricted. Now when it comes to rotating, you cannot rotate like that. You can rotate only like that. So 2 degree of freedom is correct. 3 degree of freedom is correct. 1 translation, 2 translation and 1 rotation. 3 degree of freedom. Okay? Fine. So now we are moving further. So guys, but the problem is, in our syllabus we are majorly concentrated not about the 3 dimension. We are majorly concentrated for the 2 dimensions. So if you would be considering in the way of 2D, not in the 3D, then the things will be slightly changing. If you are having the 2D, then my dear, in 2 dimension the maximum degree of freedom cannot be 6. Here you can have translation in X direction, translation in Y direction, and there is no Z direction. But you can rotate about the Z direction, or you can rotate in XY plane. So translation in X, translation in Y, and rotation in XY plane. These 3 motions are possible. So degree of freedom will be 3. Okay, and here if any pairing is going to be imposed, then degree of freedom will be 3 minus R. So if you are going to consider turning pair in 2D, so turning pair in 2D can also have rotation like this. Okay, so rotation of this is permitted. So then the degree of freedom will become 3 minus 2, answer will be 1. So like we have seen in 3 dimension, we can see in 2 dimension also. Is it clear for everyone? So majorly our concentration will be 2D, not 3D. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Now my dear, I am coming on to the equations. As I said, we will not go for the derivations. If you will see my paid course class, there even Kurzbach equation I was deriving. Okay, here we are not deriving, here we will be discussing directly. So this was about because here I am not here to give you only the feel of the subject. We need to feel the subject, along with that we need to go fast as per the exam point of view. So when exam is important, okay, so then we will be going like this. I am telling you for 2D bodies directly. So when we are talking about 2 dimension, I am telling you degree of freedom if you want to find out. Till now we were having either a independent body or a pair. Okay, now let us talk about a mechanism. How to find out the degree of freedom for a mechanism. Okay, so you tell me, if I have total L number of links, and in 2 dimension, one link can have 3 degree of freedom. So you tell me, if one link can have 3 degree of freedom, how many degree of freedom L link will be having? If L links are not connected with each other, if they are not making the pairs, then my dear, I can say 3 into L will be the total degree of freedom possible with the L number of links in 2 dimension. But my dear, whenever I am saying that we are going for degree of freedom for a mechanism, then my dear, whenever I am talking about a mechanism, then for mechanism, I would like to say one link is fixed. So that is why this L will become L minus 1. That is why this L will become L minus 1. Now my dear, you can have some pairs. P1 is the number of pairs. With degree of freedom equals to 1. So if degree of freedom is 1, restriction will be 2. So if one pair is having the 2 restriction, then P1 pair will be having 2 into P1 restriction. Because there are such P1 pair, you can say there are P1 number of turning pair present. So So every turning pair is having 1 degree of freedom, 2 restriction. So as degree of freedom I already considered for every link. I need to subtract the restrictions. So I will say minus 2p1. Okay, then my dear, if I am going to say P2 are those number of pairs with degree of freedom as 2 and number of restriction as 1. So there can be a case where 2 degree of freedoms are there and 1 restriction, like you have seen the screw pair. In the screw pair, this is there, 2 degree of freedom are there. Okay, rotation about xy plane, translation about one axis. Translation about other axis is not there. So you can say these are the number of screw pair. So one screw pair have one restriction. P2 have P2 restriction. So it is minus P2. So my dear, this is the degree of freedom we are going to say. Is it clear for everyone? Now Kurzbach came and Kurzbach changed this P1 and P2. Because you know, always considering the pair is going to be a difficult task. So he said, I can replace this P1 by the number of binary joint. Why? Because a turning pair can be considered as a binary joint because there are two links connected. So he said P1 can be replaced by binary joint. You may be saying that he is just taking one example. No, he have done this by having the same conversion for lakhs of mechanism. For lakhs of mechanism, he converted this P1 with the binary joint and he found the answer is coming correct. Then he said, yes, we can replace P1 by number of joint. For understanding purpose, I am showing you only the example of one pair, but it was valid everywhere. Similarly, he said P2 is the number of pair with degree of freedom 2. You know, turning pair is a lower pair which is having degree of freedom of 1. You know, one higher pair is equivalent to 2 lower pair. So he said when lower pair, which is a turning pair, is having a degree of freedom of 1 and higher pair is equivalent to 2 lower pair, so he considered it means one higher pair will be having degree of freedom of 2. So he said that P2 will be replaced by the number of higher pairs. And the equation became degree of freedom is 3 into L minus 1 minus 2J minus H. Now my dear, this is going to be a very easy and understandable and beautiful equation which was found to be valid for 99% of cases. Yes, for 1% of cases this equation does not hold good. And those 1% of cases are also coming in exam, which I will be telling you in the upcoming slides. Till this point, everybody understood or not? If anybody have any doubt, please ask. Now my dear, what is the meaning of this equation that I am telling you in the next slide? If you are going to get degree of freedom to be 0, then my dear, this is the condition for frame and structure. This is the condition for frame and structure. If you are going to get degree of freedom as 1, we call it as kinematic chain or mechanism. Then if we are going to get degree of freedom more than 1, we call it as unconstrained chain. If degree of freedom is coming out to be less than equals to minus 1, we call it as superstructure. Okay, is it clear for everyone? So these are the names we are going to give. Everybody understood? So from this already Gate have asked one time that when we are using the word superstructure. So when degree of freedom is 0, we call it as frame and structure. If you want to apply this equation on a 3-bar chain, you can apply. Number of links are 3. So number of links are 3. Number of binary joints 1, 2, 3. Number of binary joint 3. So degree of freedom is 3 into L minus 1 minus 2 into joint. It is going to be 6 minus 6, 0. So 0 means frame or structure. Do you remember we have done the same thing before also with some another formula like J is equals to 3 by 2L minus 2. So can we say that if we want to find out any mechanism, whether it is a kinematic chain or it is a frame or structure or it is a unconstrained chain, we have two methods. We have two methods. One method is this and second method is this. Can we say there are two methods? One method is J is equals to 3 by 2 L minus 2. Second method is F is equals to 3 into L minus 1 minus 2J minus H. Is it clear for everyone? Please tell me. Yes, Shreyas. Anybody have any doubt, please ask. Anybody have any doubt, please ask. Anybody have any doubt, please ask. Okay, very good guys, very good guys. So my dear, I would like to tell you these are not two, actually they are one only. Like let us say we are going to have total number of higher pair 0, because in our syllabus only the study of lower pairs is there. Only one higher pair we need to study, that is cam and follower. There is no other higher pair in the syllabus. So if we are going to say higher pair is 0, then my dear, just look at this equation. If H is 0, you would be having degree of freedom to be 1 for a mechanism. Yes, 1 for a mechanism. So put 1 is equals to 3L minus 1 minus 2J, because higher pair is 0. You can write it as 2J is equals to 3L minus 4. And when you will divide it by 2, you will get J is equals to 3 by 2L minus 2. So these two are not the two equations, they are one only. But in the books they are considered to be two, that's why I told you. But otherwise you can say both are same only, there is not much difference. If here also left hand side is not equals to right hand side, and left hand side is more than right hand side, then we are calling it as frame or structure. But we call it as frame or structure only if the gap between left hand side and right hand side is 0.5. If the gap is becoming more than 0.5, we call it as superstructure again. So superstructure is nothing but structure with more strength. It is a structure with more strength. Please tell me, everybody understood this consideration or not? Then we are moving further. Please tell me that. We are having some questions to do on the degree of freedom, and we will see the exceptional cases as well. Is it clear for everyone? Any doubt if anybody is having, you can ask me. The things are written in front of you in a very, very nice manner. Even in the crash course, we are explaining each and everything in a nice manner. Yes, very good, Sayak. Very good, Ashray. Very good, Shreyas. So like, okay. Now my dear, we are coming with the exception to the Kurzbach equation. Actually, when we were talking about the Kurzbach equation, there were some cases came into picture where we found, some cases came into picture where we found the Kurzbach equation was not found to be valid. There are 99% cases where it is valid, but there were 1% cases where it is not valid. So first let us see some of the examples of 99%. Then we will come back to this 1% where it is not valid. We will come to that, don't worry. Like this is a case. Let us see how to solve it. We need to find out the degree of freedom. Here this is link number 1. You can try along with me. This is link number 2. This is link number 3. Then this slider is link number 4, and this fixed one is link number 1. Then this is link number 5. This is link number 6. My dear, hatched part is always considered as a single link. This hatched part is like this single link. This is a single link like this. Okay? So they are not 3 link, they are single link. This is 6. This is 7. This is 8. Then this is once again 1 and 1. So can you tell me how many links are there? We have seen total number of links are 8. When we are talking about the joints, here students are going to make the mistake. Here this between 1 and 2 is a binary joint. Between 2 and 3 is a binary joint. Between 1 and 8 is a binary joint. Between 8 and 6 is a binary joint. Between 7 and 6 is a binary joint. 1 and 7 is a binary joint. 5 and 6 is a binary joint. But can you tell me what kind of joint this is? Here students are making the mistake. What kind of joint this is? If you see this, here link number 3, link number 4, link number 1 and link number 5. 4 links are connected together. So we will call it as a quaternary joint. Here the students are going to make mistakes. So that's why I have given this. And now my dear, when we want to find out the binary joint, 1 binary, 2 binary, 3 binary, 4 binary, 5 binary, 6 binary, 7 binary. and one quaternary is 3 binary. So total number of joints will be 10. So when you will be finding out the degree of freedom, the formula is 3 into L minus 1 minus 2j minus h. You would be having 3 into 8 minus 1 minus 2 into 10. There is no higher pair, the answer will be coming out to be 1. It means it is a mechanism. Is it clear for everyone? Please tell me that. Clear for everyone? Please tell me that. So do like and share the session, guys. The way we are moving ahead, you can see not only theory but numericals are going on with the theory of machines. We will find out the degree of freedom for this case. We are finding out the degree of freedom for this case. You know, this is link number 1, link number 1, link number 1, link number 1. You can solve by your own also. Very good, Vishal. Link number 2, link number 3, link number 4, 5, 6, 7. You can see here number of links are 7. You can also see this is a higher pair. So there is a higher pair as well. Now we need to see the number of binary joint. This is a binary joint, binary joint, binary joint, binary joint, binary joint, binary, binary and binary. So how many binary joint? 1, 2, 3, 4, 5, 6, 7, 8. So if you see number of binary joints are 8. So when we are going for degree of freedom, it is 3 into L minus 1 minus 2j minus h. Then my dear, you would be having the number of links to be 7. 7 minus 1 minus 2 into 8. Higher pair is 1. You can say it is 6 minus 3 is 18 minus 16 minus 1. Degree of freedom is 1. Clear for everyone? Very good Faninder, very good Ajay, very good Aritro, Sandy, Shreyas, Vinay. Wonderful guys. Yes, yes. तो भैया अरित्रो, यहाँ मैंने कब कहा कि मैं जो करा रहा हूँ यहाँ मैंने विजन में नहीं कराया है। मैराथन का मतलब रिवीजन होता है, मैराथन का मतलब नई चीज थोड़ी होता है। मैंने कब कहा कि मैंने नहीं कराया है? कराया है, बिल्कुल कराया है, इससे ज्यादा कराया है। यहाँ पर तो रिवीजन चल रही है। ओके, whatever we have discussed in 2 hours, that there we discussed in 4 classes. Okay, so now we are moving further. Okay guys, so now whenever we are talking about the next type of question, this is the next case. Link number 1, as this entire is going to be one link only because this is a hatched part. This is link number 2, 3, 4, 5. Okay, so now you can see the number of links are 5. The number of joints, this is binary, 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 binary. Every joint is binary. 1, 2, 3, 4, 5, 6. There is no higher pair. So degree of freedom is 3 into 5 minus 1 minus 2 into 6. Are we getting 0? A would be the right answer. Okay, so practice in theory of machines is must. That's why we are going with some questions as well. Okay. Now this question you would be doing, this is the GATE 2016 questions. Yes guys. Solve this one. सायक, मैंने अभी तक आपको कुछ रिडंडेंट जैसी कोई चीज पढ़ाई है? नहीं पढ़ाई, ठीक है। रिडंडेंट भी पढ़ेंगे क्या होता है, डोंट वरी। Okay. What would be answer for this? This is a previous year GATE question. Okay, so I feel majority of you are saying the answer to be 1 only, which is a right answer. No problem in that. Very good, Shreya. So this is going to be the calculation for such case. If this is link number 1, this is link number 2, this is link number 3, link number 4, link number 5, link number 6. So you can see the number of links are 6. This is the binary joint, 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 this is the binary joint. So 1, 2, 3, 4, 5, 6, 7. Higher pairs are 0. So degree of freedom is 3 into 6 minus 1 minus 2 into 7. Higher pair is 0. So you can say it is 15 minus 14. Answer will be 1. Everybody understood, guys? Everybody understood? Please tell me that. Very good. So guys, now this question also you will be doing. This question also you will be doing. Find out the degree of freedom for this case. Solve it, solve it, solve it. Any doubt, you can ask me also. I will do this question in front of you, don't worry. Harsha, where you are getting 3? For which question? For this question or previous one? Last question nobody is getting C. Last question nobody is getting C. How you are getting that? I have shown, I have done in front of you. I have done in front of you. तुम्हारे सामने किया है. This is link number 1, link number 2, link number 3, 4, 5, 6. 6 links are there. Joints. This is a binary between 1 and 2. Binary between 2 and 4, binary between 2 and 3, binary between 3 and 5, binary between 4 and 5, binary between 5 and 6, binary between 1 and 6. Total 7 joints. There is no higher pair. Put in the formula. Answer is coming 1. I don't know from where you get 3. Okay, now let us solve further ones. Okay, we will see once again that if you are saying. What is the degree of freedom of the mechanism shown below? Actually, in that question, this entire is link 1. As this was hatched, this entire is link 1. You have considered this as a separate link. That's why you are getting wrong answer there. Okay, now come back to the point. So guys, this is link number 1, link number 2, link number 3, link number 4, link number 5, link number 1, link number 6, link number 1. Okay, so guys, is it clear? So the number of link is 6 here. If you see the joint, between 1 and 2 is binary, between 2 and 3 is binary, between 1 and 5 is binary, here it is 1, 2, 3 ternary, here it is 1, 2, 3 ternary. So there are 2 ternary joints. Any doubt here you can ask Harsha, anybody else? Any doubt? Keep on asking on the same question. Joints whenever we are talking about. So 1 binary, 2 binary. This is a ternary means 2 binary. So 1, 2, 2 plus 2, 4, 5 and 2, 7. It is 7 binary. Degree of freedom is 3 into 6 minus 1, minus 2 into 7. 15 minus 14. Answer is coming out to be 1. Is it clear, Harsha? Please look at it. Any doubt, please ask. Very good, Abhishek, Shreya, Vinay. Bahut badhiya. Wonderful, guys. You are going very nicely. Yes, yes, yes. Fine. So in this question you are saying, na, there you have considered this is link number 2. No, this is link number 1 only. This entire is one link. Okay, that's why you are getting wrong answer. You have done some mistake here. Okay guys, now I feel we have seen a number of examples. Now we are coming up with the exceptions. What are those 1% cases? What are those 1% cases where Kurzbach equation is not valid, or where we need a modification? So my dear, if you see this mechanism, this is link number 1, link number 2, link number 3, link number 4. You know, this is a turning pair, we can consider it as a binary joint. This is a turning pair, we can consider it as a binary joint. This is a sliding pair, we can consider it as a binary joint. Sliding pair, we can consider it as a binary joint, because I told you, in binary joint we can have slider with this, we can have cylinder with piston, we can have two link like this. All these are the example of binary joint. So if that is the case, you see number of links are 4, number of joints are 4, degree of freedom is 3 into 4 minus 1 minus 2 into 4. So answer will be coming out to be 9 minus 8, it will be 1. Is it clear for everyone? Degree of freedom is coming out to be 1. Clear for everyone? Degree of freedom will be coming out to be 1. Yes. So my dear, but in reality, just feel practically, as this link is kept like that. So don't you feel even a small push to this will result in going out of this link? This is kept like that. Even you can say if I leave you, it will go down. It is kept like that. Okay, so when any motion will be starting, it will go down. So when you will be giving rotation to this like this, it will simply go down. Even if you give rotation here, then also it will go down. So when this link will go down, you would be having 3 links. And with 3 links, you cannot have mechanism. You know, degree of freedom is 0. So that is why the answer for degree of freedom is 0 here. But with the formula we are getting 1 here, which is wrong. So here, when this case come, yes, Kurzbach equation was not capable of giving you right answer. Then my dear, you may be thinking, okay sir, this may be an exception. At that time, people also thought, okay, something can be exception. And they continued working. And they found one more such case came into picture. Like whenever we are going to talk about cam and follower. You know, cam and follower, we call it as a mechanism. And for any mechanism, degree of freedom should be 1 only. So degree of freedom for this is 1. But what Kurzbach says? Kurzbach says 3 into L minus 1 minus 2J minus H. Look at it. I am telling you for both cam and follower where the mistake will come, you will see. Here if I am finding out, this is 1, this is 2, this is 3, this is 1. So number of links are 3. This is a binary joint. This is a higher pair. And this is a binary joint. Sliding pair is a binary joint. So 2 binary joint, 1 higher pair. So 2 binary joint, 1 higher pair. When you will find out degree of freedom, it is 3 into 3 minus 1. Minus 2 into 2 minus 1. So you are going to get 6 minus 4 minus 1. Answer is coming 1. So there is no problem in this case. Degree of freedom is coming out to be 1, which should be there. So there was a no problem case. Okay. But my dear, if I give you the same cam and follower with the roller follower. The same cam and follower with the roller follower. Cam and follower with any follower should have degree of freedom 1 only, because it is a mechanism. But when you will calculate for this case, this is link number 1, this is link number 2, this is link number 3, this is link number 4, this is link number 1. This time the number of links are 4. Once again, 1 higher pair I have. This time when you will go for the binary joint, between 1 and 2 is a binary joint, turning pair. Between 1 and 4 is a binary joint, sliding pair. between 3 and 4 is a rotation turning pair, once again it is going to be binary joint. So we have 3 binary joints. So the equation is saying 3 into L minus 1 minus 2 into binary joint minus higher pair. You will say 3 into 3 is 9 minus 6 minus 1, answer is coming out to be 2. But we know if it is a mechanism, answer must come 1 only. Here also Kurzbach equation hands up कि नहीं हो पाएगा. Then my dear, Kurzbach equation needs some modification, because if it is happening for many mechanism, everything we cannot say as exception. It means there is something which we are missing. And I am showing you in both the cases we are missing one thing. You can see, my dear, if you are having this roller follower, just feel the roller follower. It is with the cam. If we are having the roller follower, can you feel one thing, that the motion of roller is possible without any rotation of cam and follower. If I am not even touching the cam, I can rotate this. So this motion have nothing to do with the mechanism. This motion have nothing to do with the mechanism. And such motions are said to be redundant motions. Such motions have nothing to do with the mechanism because they are not affecting input output. So it is a redundant motion. And my dear, then Kurzbach have seen here it was a redundant motion. Then Kurzbach here also noticed that if I am not rotating the input link, I am just pushing this, it will go down. So this linear motion of this link here is also a redundant motion. It has nothing to do with input and output motion. So this is also redundant motion. So Kurzbach found that there is something extra which I was missing. And then he modified the equation. He said the equation should be 3 into L minus 1 minus 2J minus H. It's fine. Because F is giving you degree of freedom, the independent motions. But if a motion is not having anything with input and output, such motion should be subtracted. Then I would be saying it should be minus FR. This FR is the redundant degrees of freedom or redundant motions. So now this became the modified Kurzbach equation. So here this one relative motion is the redundant motion. So you know the answer was coming 1. So 1 minus redundant motion 1, the answer will be 0. Are you getting it or not, guys? Same with the previous case. Same with the previous case. When you are having roller follower, here also minus redundant motion you will do. Redundant motion is the rotation of this roller. So minus 1, answer will be 1. Clear for everyone? Very good, Shreya. Very good, Ashray. Yes, yes, yes. So this is the pure beauty of mechanics, guys. Pure beauty of mechanics. Abdul, you understood piston cylinder is prismatic joint. Cylinder piston can be understood as prismatic. Prismatic means cross section of cylinder remains same throughout. Okay. Dear, for mechanism degree of freedom is 1, not 0. So this is not a mechanism, na? This is not a mechanism, because this will go down, it will become 3-bar chain. It is not a mechanism. Okay? Is it clear? Fine. Now my dear, this question is coming many times. This have been asked in ISRO, asked in engineering services, asked in all the exam except GATE. So I feel maybe this become the question of GATE 2024. Be ready for that. Okay. So they are asking about this. Sir, roller and cam can be a joint. Dear, whenever we are having a higher pair, then higher pair, once we have considered it as a higher pair, then we will not consider it as a joint. Because pair is also a joint only. So we will be taking higher pair separately and rest we will be considering as a joint. Okay. So when we are talking about this, here generally students are doing some mistake. So actually this is given as the turning pair like this. So you need to consider this entire is a one link, this entire is a one link. Like you have kenchi, knife. In the knife you have two links connected like that. So they both are same, two links only. So this is going to be like that. So this type of connection is there. So here you can consider, if this is link number 1 fix, this entire is link number 2, this entire is link number 3. This slider is link number 4 and this fixed one is link number 1. Then this entire is link number 5, 5. This entire is link number 6, 6. This entire is link number 7, 7. This entire is link number 8, 8. This is link number 9. This is link number 10. So you can see the total number of links are 10. Okay. Total number of links are 10. Total number of links are 10. So you can see this is a binary joint. 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 This is a binary, 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 and this is a ternary. Because here slider is present, link number 1 is there, link number 4 is there, this is a ternary. This is the catch here. So when we are talking about the number of links are 10. And this mechanism you have seen, whenever police want to block a path, they are using this. Is it lazy tongue mechanism? So when we are talking about L is equals to 10, 10 number of links. This is 1 binary, 2 binary, 3 binary, 4 binary, 5 binary, 6 binary, 7 binary, 8 binary, 9 binary, 10 binary, 11 binary and 13 binary. Joints are 13. There is no higher pair, no redundant motion. So you will say degree of freedom is 3 into L minus 1, 2 into 13 minus higher pair. Answer will be 1. So here you would be getting the answer as B, what you have given. Aniket, Shreya, Shreyas, Harsha, very good. Farinder. And I would also like to tell you here one more thing, guys, ki it can be any number of loops. The number of loops can be different as well. Like they have given like this, they can give you like this much also only. Like here 3 loops are there, here 2 loops are there. Can be more than 1 loop, can be anything. Answer will remain the same. There is no difference in the answer for this. Please tell me, guys, till this point everybody understood or not? Till this point everybody understood or not? I would like to tell you one more thing. If sometime a spring is mentioned in a mechanism, then you replace this spring by a turning joint. Because you know, this spring can have this compression and expansion, this motion. These 2 links can also have the same motion. So whenever you see this spring in a mechanism, replace it with 2 link with a binary joint. Okay, till date there is no questions on this, but I feel maybe to give you a new question they can give you this. Clear for everyone? Please tell me till this point. We have discussed about degrees of freedom. Very good, Arikesh. Clear for everyone? We are reaching to the Grubler's equation. Now, my dear, whenever we are talking about Grubler's equation, some people are calling it as Grubler's criteria. So, my dear, this is the example of smart work and the winning of smart work over the hard work. You have seen Kurzbach have given us a wonderful equation. And that wonderful equation when Kurzbach have given us, he have taken a lot of time, 6 years, 7 years maybe, and done the work on lakhs of mechanisms, then found that equation to be valid. But my dear, whenever we are talking about Grubler, he have done a small game with that equation and given a thing which is utmost important for the researchers, and he got so much award for his work. What is the Grubler's equation? Grubler says, I am interested in mechanism. For mechanism, degree of freedom is 1. Then Grubler says, I am not interested in higher pair mechanism. I would be talking only about the lower pair mechanism. For lower pair mechanism, when you are saying degree of freedom is going to be 3 into L minus 1 minus 2J minus H. So when we are going to say higher pair to be 0, degree of freedom is 1, I can write 1 here, then 3L minus 3 minus 2J, higher pair is 0. Higher pair is 0. Then my dear, you can write it here, it is 1, 3L minus 2J minus 3. You can write it as 3L minus 2J minus 4 barabar 0. This equation is said to be Grubler equation. You would be laughing at me, sir, for that much work, who can give him award? Dear, this work is silently saying something. If you will open your ears, open your heart, some things cannot be seen, something can be felt only. So you will be like, for God we say, na, God we cannot see, we can feel him. Similarly, you can feel this equation. Air, like when we say Hawa, we are using it, that's why we are alive. But we can feel it, not see this. So if you are having 3L minus 2J plus 2. So if you see this equation, what it is trying to say, let us feel it. My dear, this J plus 2 can be a odd or even any number, but when it is multiplied by 2, it is going to be a even number only. And when we are getting this as 0, it is compulsory that it should also be an even number. Because we cannot subtract odd number from even number and get 0. So obviously it is even minus even 0. So when we are getting even minus even 0, it means 3L is even. 3L is even means L is even, because 3 is odd. If L is even, then only we can get this equation to be satisfied. So my dear, the point is, if number of links are even, then only we will be getting degree of freedom as 1 without higher pair. Yes, if higher pair are there, then this equation has no meaning. So he simply said, if researchers are going to make the mechanisms, and they are making the mechanisms in such a way that they are not using a higher pair, then the number of links should be even. So previously, if people were trying to make a mechanism with 3 link, 4 link, 5 link, 6 link, 7 link, 8 link, 9 link, 10 link, 11 link, now they know. They will try only with 4 link, 6 link, 8 link. They will not try with 5 link, 7 link, 9 link. So 50% of the research work have been reduced. So that is why this equation is going to tell us a lot. And the first mechanism with minimum number of links is 4, is simple 4-bar mechanism. Everybody is clear about this? This is Grubler's criteria, Grubler's equation. Now we are entering in the field of mechanisms. So you can say one part of the chapter is over, and now we are entering into the second part, and I am telling you simple mechanism is the biggest chapter. All other chapters are not that big. So maybe this chapter will be completing by that time. We will be going for the lunch break maybe, but after that other topics will not take much time. Velocity, acceleration, then gyroscope, then that gears, all other things, because their time is there for derivations, and derivations we are not going to do. First chapter is having the concepts, other chapters are having derivations. So derivations we are not going to do, we are directly going for the results. Next theoretical part will be coming in the balancing. Yes, Darshan. So now we are going to enter into the 4-bar mechanism, and as it was the very first mechanism, we also use the word simple 4-bar mechanism. So my dear, now I would be explaining something in such a way which will help you to understand the things properly. If you see this simple 4-bar mechanism, my dear, you can see the very first link is this fixed link. And I would like to say that fixed link is the most important link, because until you fix a link, you cannot get a mechanism. So when we are talking about this fixed link, this is the most important link, because input is given with respect to first link, and we are getting output with respect to fixed link. So my dear, this fixed link is having no motion, but it is said to be the best position of a mechanism, because input and output and entire motion of the mechanism is controlled from here. It is like the position of your father at home or prime minister in the country. Whatever he will say, you have to follow it. And then, my dear, we are having the second position as input and output motion, input and output link. They are good because they are having the well-defined motion. You know, this link number 2 and link number 4, they can only have the pure rotation. So you can say input and output, they are having well-defined motion. Their motion is pure rotation. So my dear, generally I consider this is the first best position, this is the second best position. It is like the prime minister of the country, and this input and output is like the ministers, because minister may not directly order us, but whatever they want they can achieve. They are getting benefits. Okay, so my dear, this is the second best position. And the third position, which is a coupler or coupling rod, this is said to be the worst position. Why worst? Because my dear, whenever we are looking the motion of coupler, it is neither found to be pure translation nor pure rotation, but it is found to be a combination of translation and rotation, and that kind of motion we call it as a general motion. You may be saying, sir, why not pure rolling? Because my dear, when pure translation and pure rotation are connected with some condition, then we are giving them some name, like pure rolling, like simple harmonic motion you will have. But whenever these relation is changing, like at one instant you will be having 60% translation, 40% rotation. At other instant we will be having 50% translation, 50% rotation. At other we will be having 35% translation, 65% rotation. So when this will keep on changing, it is not a single motion. It is a combination of motion. Like in thermodynamics, you have polytropic processes. Isothermal is a process, adiabatic is a process, but polytropic is not a process. It is the processes. All together, when a number of processes are seen, they are said to be polytropic processes. So here also general motion is combination of large number of motions. Clear for everyone? Clear for everyone? Clear for everyone? So that is why we are calling it as a general motion. Okay? So my dear, coupler is having general motion. This is the condition of a common man. Okay? Common man is going to dance wherever these ministers and जहां शासन और प्रशासन चाहेगा वहीं पे नचाएगा. Okay, so this is said to be the coupler or coupling rod. So my dear, now we are going to enter into the field of inversions. Inversions is a very, very important topic, and from here the second part of the chapter is starting. This will not take much time, don't worry. So when we are talking about this inversions, you already know we are having a simple 4-bar chain. Link number 1, link number 2, link number 3, link number 4. Now my dear, when you want to make a mechanism of this, you have 4 choices. You can fix link number 1, you can fix link number 2, you can fix link number 3, you can fix link number 4. So when you will be fixing link number 1, you will get one mechanism. Fixing link number 2, you will get second mechanism. Fixing link number 3, you will get third mechanism. Fixing link number 4, you will get fourth mechanism. And the group of these 4 mechanisms is said to be inversions. Group of these 4 mechanisms is said to be inversions. Is it clear for everyone? Yes, Dharamjeet. So my dear, when we are talking about these are inversions, so if I say the number of link are L, then the maximum number of inversion is going to be the same. Is it clear? So my dear, if someone is asking you the maximum number of inversions in a mechanism, then maximum number of inversions are equals to the maximum number of links. 4 links, 4 maximum number of inversions. Okay? Why I am saying maximum number? Why not exact number? I am telling you the reason behind that. So for that I need to consider some cases. Whatever I am taking is the possibilities only. Okay. So let us say when we are going to fix link number 1, the mechanism will look like this. And let us say when we are having this, we are going to have input link is completely rotating like this. Output link is also completely rotating like this. So mechanism is going to be like this. So when input is rotation, output is rotation. Completely rotated link is said to be crank, partially rotated link is said to be rocker. So here if this is completely rotating, this is completely rotating, we will call the mechanism to be a double crank mechanism. And my dear, let us say when we are going to fix link number 2, then what I found is this input link is completely rotating, but output link is partially rotating like this. This is completely rotating, this is partially rotating. So we will be calling this mechanism as crank rocker mechanism. When I am going to fix link number 3, previously this link was rotating, now this link is becoming reciprocating. Previously this was reciprocating, this is becoming rotating. So don't you feel this time it is rocker crank mechanism. When I am saying rocker crank and crank rocker, just try to feel this is crank rocker. And if I am going to invert by 180 degree, it will become rocker crank. So do you feel when I am going to rotate by 180 degree, if I am going to have a machine and if I rotate that machine by 180 degree, will that machine change? Lathe will become drilling machine after rotating by 180 degree. Will it happen? No. So my dear, as the relative motion between these two mechanisms is same, crank rocker, rocker crank, same relative motion. So such inversions are considered as one inversion only. They will not be considered as two inversions. And when we are going to have link number 4 fix, maybe both are having partial rotations, then we would be calling them as double rocker mechanism. That will be calling as double rocker mechanism. So when we are calling it as double rocker mechanism, my dear, then I would like to say here one thing, that these two are giving one inversion, this is giving one inversion, this is giving one inversion. So total I was expecting that maximum possible inversions were 4, but the actual inversion here we are getting is 3, which is definitely less than the maximum. That's why I said the maximum possible inversions are 4. Whether I will get it or not, that is not compulsory. Now you may be having a doubt, sir, how you would be knowing that when this link will be fixed, then I will get double crank, when I will fix this, I will get crank rocker. How you will be knowing that? So for that, my dear, there was a researcher who worked a lot for 5-6 years like a PhD. And that researcher name is Grashof. This is the second topic from where a large number of questions are being asked in GATE, Grashof law. So Grashof have given a law to tell you that when you would be getting the double crank, when you would be getting the crank rocker, when you will be getting the double rocker. This Grashof law in the paid courses, I take it for 2 hours. Here we are not going to waste 2 hours because there we are explaining the student from the scratch. Here you are coming for revision. You have studied 1 year completely. This is for revision purpose. This is for the purpose of question solving only. Okay. So that is why I will be going fastly from here. If you want to understand the Grashof law, what Grashof said? Grashof said if you have 4 links, out of 4 links they are having the length equals to S, L, P and Q. Here S stand for shortest link, L stand for longest link. P and Q are other 2 link. Like I have 2, 7, 6 and 5. Then you know this is S, this is L, this is P, this is Q. Then he said if you want the continuity in the mechanism, then for that purpose, for continuity in the mechanism, the summation of shortest and longest link length should be less than equals to P plus Q. So the summation of shortest and longest link length should be less than equals to other two link length. If that condition is satisfied, you will be having the continuous relative motion. Now you can see double crank looking like continuous because crank is rotating continuous. Crank rocker is also continuous because crank is rotating continuous. But double rocker is not continuous. Double rocker is this. It is stopping here, stopping here, stopping here, stopping here, stopping here, stopping here. So when I say continuous motion, for continuous relative motion, it means there is a guarantee of at least one crank. There is a guarantee of at least one crank. Now my dear, I am telling you what Grashof law says and how you need to move on. So this is the statement. Now my dear, there are some cases when you are going to have S plus L is less than P plus Q. Law is satisfied. Whenever you get a question on the Grashof law, the first thing you will do is you will check whether the law is satisfied or not. If you find law is satisfied, then what you will do? You will check the fixed link. If at the fixed position, shortest link is there. Always remember, fixed is the best position. Shortest is the best link. If best link is at the best position, means it is like the condition if your father won a lottery. If your father won a lottery, you, your brother, your mother, everybody will enjoy because that lottery will help everybody to party, to enjoy. So my dear, in this condition, everybody means double crank we will be getting. But my dear, if you see that fixed link is not having the shortest link, you always check with this first, this is satisfied or not, then you will check the fixed link. If fixed link is not the shortest link, then you will check the input or output. If input or output is having the shortest link, best link at second best position, this is the condition when lottery आपके पापा की नहीं, lottery आपकी निकली है. If your lottery is there, then you will enjoy for sure, others may or may not be. So that is why this time there is a guarantee of one link rotation, crank rocker. And if you find that neither shortest link is fixed nor shortest link is input output, then you will check the coupler. Then if coupler is having the shortest link, you will say double rocker. So even though law satisfied, still you will be getting double rocker if coupler is present, if shortest link is present at coupler, because best link present at worst position. If you have an encounter specialist but you are putting him into the kitchen, then this is not the mistake of counter specialist, this is mistake of yours. So we call it as misutilization. Is it clear? Means if you want double rocker, then only you will be doing this. Is it clear for everyone, my dear? Is it clear for everyone? So always remember, if you find the shortest link at fixed, you will not check any other position. So they are domination wise. If this is clear, you will go to this. If this is okay, no need to check others. If this is not there, then check other. If this is clear, no need to check other. This should be the sequence you need to follow. The same, this is the 4-bar mechanism with double crank. And the credit goes to makeagf.com for that. This is double crank. Okay. This is the crank rocker. You can see how the mechanisms are going to happen. I am showing you the animations as well. Clear? Crank rocker. Double rocker. Clear for everyone? Now my dear, we are moving to the second case. If S plus L is equals to P plus Q, then once again repeat all the same thing. Law is satisfied. Here also law is satisfied. Is it clear? Ha, Sandy. So this is also law satisfied. So if law is satisfied, once again all the previous case will be repeated. There is no change. But my dear, if you are going to have something different, if you have two links as two shortest and two longest links, means you have 2 mm, 2 mm, then 8 mm, 8 mm. With that also law will be satisfied. S plus L will be equals to S plus L. Because here S will be P and L will be Q. So law is satisfied. But when you are having that, then my dear, you can have two types of configuration. You can have shortest, shortest, longest, longest. That is said to be parallelogram linkage. And when we are talking about parallelogram linkage, it is always giving you double crank. It will never be giving you crank rocker or double rocker. It will always give you double crank. Because if you are going to fix the longest link, then shortest will be input, shortest will be output. Both will rotate, you will get double crank. Similarly, if you are going to fix the shortest link, then you know by the rule, if shortest is fixed, then both will be completely rotating and you will be having double crank. And whenever you are going to connect shortest with shortest, longest with longest, you will be getting it as deltoid linkage. So when we are talking about the deltoid linkage, here if shortest will be fixed, you will get double crank. And if you are going to fix this longest link, then shortest will rotate. So you would be getting, if longest is fixed, you will be getting crank rocker. But never you will get double rocker, because here the conditions are with two shortest link. So that is why even if one shortest link is input, that will become crank. You know, domination is first fixed position, then input output, then coupler. And as they are always following the Grashof law, they are said to be golden chains. They are said to be golden chain mechanism. Clear for everyone, guys? Clear for everyone, guys? Here, my dear, we are moving further now. If S plus L is more than P plus Q, Grashof law not satisfied. If not satisfied, you will be getting double rocker for sure. Now, whatever link is fixed doesn't matter. You will always get double rocker. Okay, this is the beautiful Grashof law. Is it clear, guys, for everyone? Please tell me that. This is the wonderful Grashof law. Is it clear for everyone? Please tell me that. Clear, guys? These are the practical application of simple 4-bar mechanism. The very first application is nothing but the beam engine mechanism. As you know, I told you that Sir James Watt is said to be the godfather of mechanical engineering. And here the story is going to start for the Sir James Watt. He was given the work of making the steam engine, because at that time British government wanted to make a engine, or you can say something, from which the things which are required for war, they can take that to their soldier in the minimum possible time. So for that purpose, they approached Sir James Watt and team. And Sir James Watt has said, okay, we will make the steam engine. And when they started making steam engine, this was the first attempt, which was not the successful one. This was a failed attempt. And you can see, my dear, here, this is the crank rotating. And with the rotation of crank, this will be reciprocating like that. But this reciprocated part was connected with the this oscillated part was connected with the reciprocating cylinder piston arrangement. So because of that, now you know if something is reciprocating like this, obviously it will follow the straight path. But you wanted the oscillation like this. So when you will be going for the oscillation, you need to feel it कि when this piston will be reaching to this position, obviously this will be pushing the cylinder in this direction. So there were huge unbalanced forces were coming onto the cylinder walls. Because of that, this mechanism was helpful or useful only up to the speed of 60 to 80 rpm. But Sir James Watt was making a high speed engine as per the suggestions, as per the requirement of British government. Because at that time wars were very common thing. Right nowadays also wars are going on. Now at that time everybody was having war for the expansion purpose. At that time societies where everywhere you know that wars were there. In India also, Britishers came, you know. So at that time there were a lot of wars. Like in India also Mughals were there, then Britishers came. There was a fight between those both of the things, both of the peoples. So likewise fight was there. Okay, so when we are talking about this was the failed mechanism, but as Sir James Watt is referred as godfather of mechanical engineering, so this failed mechanism is also going to be used at many places. The very first place is the oil refineries. We are using them as oil refineries in the ONGC. Okay, then also you must have seen the tailors using the machine with the foot. They are going to do that, and the machine is rotating, and they are able to take the clothes over the machine. Tailor's sewing machine, सिलाई machine की बात कर रहा हूँ. So when we are talking about सिलाई machine, that also uses the same mechanism, where this is oscillated by the feet of the tailor, and this is rotating by which you are sewing the cloth. Is it clear for everyone? Bhai bolo yaar. This is the beam engine mechanism, the first attempt, but it was not able to give the high speed which was required to run the locomotive by Sir James Watt and team, by the British government, because they were started working on the locomotive engine, the very first locomotive engine of the world. Then my dear, you can see this is the similar thing, like you can see the Silai machine. Okay, so this was the model of beam engine. Okay, now my dear, the second thing is the coupling rod of locomotive. So my dear, this coupling rod was used to couple two wheels of locomotive. These are two wheels of locomotive which are coupled by here. The story about coupling rod we will see in the balancing chapter, not now. So this is about the practical application of simple 4-bar mechanism. Everybody understood? Everybody understood? This is the coupling rod of locomotive. Here the benefit was we will be providing engine only at one wheel, other wheel will be rotating by its own because of the coupling rod of locomotive. Clear for everyone? Clear for everyone? Clear for everyone? Okay, no issues. So guys, we will continue and we will be having break around 140, 150. I feel the break should be taken after completion of this chapter, which is the biggest one. Other chapters are not bigger. Okay, so we would be taking break after first chapter will be completing. Okay, and then other chapters will not take much time. Let us move further. So when we are talking about the transmission angle, my dear, you know that if this is a crank rocker mechanism, if this is a crank rocker mechanism, if this is a crank rocker mechanism, it means this link will be a crank, this will be a rocker. So my dear, for that this theta is said to be crank angle, this mu is said to be transmission angle. So transmission angle is the angle between coupler and output link. I am considering that this is A, this is B, this is C and this is D. So if that is the case, we want to find out the range of transmission angle here, because the questions are coming from the range of transmission angle. Here my dear, if you see the triangle ABD, everybody would be knowing about the cosine rule. Cosine rule says that k square is equals to a square plus b square minus 2ab cos theta. Angle between A and B. Similarly, if I go for the same in triangle BDC, I will say k square is equals to c square plus d square minus 2cd cos theta. Sorry, cos mu. You can see for both the equation, left hand side is same, so right hand side can also be equated. If you are going to equate the right hand side, it is going to be a square plus b square minus 2ab cos theta is equals to c square plus d square minus 2cd cos mu. Now I will be going for the differentiation. Differentiation of a square 0, b square 0. So minus 2ab. What is the differentiation of cos theta? It is going to be minus sin theta. And c square is 0, d square is 0, minus 2cd. It is minus sin mu, d mu by d theta, because differentiation is happening with respect to d mu by d theta. So when you will be having d mu by d theta, it is coming out to be sin theta, ab sin theta by cd sin mu. So when you will be equating it to 0, you would be getting sine theta to be 0. You know sine theta is 0 when theta is 0, pi, 2 pi or any pi. Theta 0, pi, 2 pi, 3 pi, 4 pi, 5 pi. Theta is any pi, we are going to have sine theta to be 0. Clear or not, guys? Clear or not, guys? So my dear, if that is the case, then we would be having, when theta is 0, then mechanism will look like this. As it is crank rocker mechanism, shortest link is the crank. So when theta is 0, this would be the mechanism look like. In this case, this will be the mu with the minimum value. Theta 0, mu minimum. And when we are going to have the second case, when we are going to have theta 180 degree, then you would be having this mu maximum. So when you would be getting theta as pi, mu will be coming out to be maximum. So theta 0, 2 pi, 4 pi, it will give you this, and pi, 3 pi, 5 pi will give you this, and so on. Clear? Why transmission angle we are going to look at this? Because my dear, whenever transmission angle is near to 90 degree, then my dear, it is going to be effective, because you know that whenever you are having this output link, and let us say this is coupler, the angle is 90 degree. So whatever force will be coming, that will be at perpendicular distance d maximum. Because of that, the output torque will be F into d maximum. But my dear, if that angle is not 90, let us say this is going to be like this. This angle is not 90. So in that case, if previously the distance was maximum, this time distance will be lesser. So because of the lesser distance, torque output will be affected. So whenever we are getting the mu near to the 90 degree, then only the output torque is coming out to be maximum. And as the mu value is reaching to 45 degree, my dear, output torque may be such low that it is unable to rotate the link, unable to rotate the mechanism. So that is why we always try to keep mu near to 90, and if mu is near to 90, we call it as a good quality mechanism. If mu is not near to 90, we call it as a poor quality mechanism. Clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Yes, guys. Now there is a term known as mechanical advantage. So mechanical advantage is said to be output torque by input torque, or output power by input power, or output torque by input torque, or it can be written as output force by input force. Is it clear for everyone? So mechanical advantage is defined as output torque by input torque, or output force by input force. That is the definition of mechanical advantage. And my dear, efficiency is defined as output power by input power. Both are different. And there is a term in industrial engineering that is said to be productivity. It is defined as what we are getting as output and what we are giving as input. So they are looking like similar, but they are different. Because when we are talking about output power, can be written as output torque into omega output, input torque into omega input. So we can write it as mechanical advantage into omega output by omega input. So if we are talking about mechanical advantage, it should always be more than 1. When we are talking about efficiency, it is always coming out to be less than equals to 1. It is always coming out to be less than equals to 1. Means efficiency is always less than equals to 1. And mechanical advantage is always going to be more than equals to 1. Otherwise, why it is advantage? We are using this term whenever we are having the screw jack and all. In the screw jack, we use mechanical advantage. Everywhere for such applications, we use the mechanical advantage. Okay, so guys, I am giving you everything in that way, so you need to be there. Okay, if you will be leaving the session, I will also leave. Okay, why I am standing here then? डियर वो भी पढ़ेंगे आश्रय, क्विक रिटर्न मोशन मैकेनिज्म भी पढ़ेंगे. So when we are talking about output by input, it is always going to be more than one. Otherwise it is not the advantage. So you know that mechanical advantage into omega output by omega input is efficiency. So when we are writing the mechanical advantage, we can write it as efficiency into omega input by omega output. So if here I would like to ask you, when I am saying mechanical advantage is more than one, it means always the output force will be more than input force. Always the output torque will be more than input torque. You tell me, is it possible to apply 50 Newton and get 100 Newton? Is it possible to apply less force and get more force? Is it possible to apply less force and get more force? Is it possible to apply less force and get more force? Some students would be saying, sir, no, because they would be saying energy can neither be created nor destroyed. So I am saying, my dear, I am not talking about energy. Yes, energy is conserved. That is why efficiency is never going to be more than 100. But my dear, if you are saying omega, if you are reducing, you can increase the torque, because bar is on the product of T and omega, not on the torque. So yes, it is possible to magnify the force by reducing the speed. So that's why if even whenever we are going to say output omega is going to be 0 for some condition, then mechanical advantage will be going to infinite. And whenever mechanical advantage is infinite, that condition is said to be the toggle positions. They are said to be the toggle position. Why they are said, we will also see them. Okay, so this is about mechanical advantage. And now my dear, we will come to the toggle position. What is toggle position? You know, if I am having a crank rocker mechanism, like this link is having complete rotation, crank, and this is having the partial rotation like this. So if this is the crank rocker mechanism, then my dear, you know, whenever rocker will reach to this position and that position, at this position rocker will be changing the direction of velocity. So as it is going like this and this, this and this, this and this. So at this location and this location, its omega will be 0. And when this is input, this is output, you know, mechanical advantages, efficiency into omega input by omega output. So when this rocker will be changing its direction of motion, its velocity will be 0. Because if I am moving like this, I need to change my direction of velocity. I will stop first. Then I will be changing my direction of motion. In the gearbox also you have, if you want to use first gear, what you are doing? You are reducing the speed, increasing the torque. Engine is giving the constant power. In the starting you need more torque, you go with the first gear. After that you need more speed, less torque. You go with the second, third, fourth gear. Very good, Raja. So whenever we are talking about this mechanical advantage, if at these two locations output will be 0, you would be getting mechanical advantage to be infinity. So we call these two conditions as the toggle position. And my dear, if we say this angle is theta, this angle is beta, and this angle is mu. So I would like to show you when we are going to get the toggle position. Just try to understand. Just try to understand. You know, this is the motion of rocker and this is the motion of crank. So the first case, when your crank will be like this and your connecting rod will be connected like this. This is the first condition. So you can see the beta, which was angle between crank and connecting rod, is 0 here. This is the first condition when you will be getting mechanical advantage infinity. That is the first toggle position. And the second toggle position will be like this. When this is the crank, this is the connecting rod. So this is the second position where beta is 180 degree. So when beta is becoming 0 and 180 degree, these are the two toggle positions where we can get mechanical advantage as infinity. Clear for everyone? Clear for everyone? Now my dear, we have completed the simple 4-bar mechanism. Now we are entering into the single slider crank mechanism. This was the third attempt by Sir James Watt to make the steam engine. It was a successful attempt. And when we are talking about this single slider crank mechanism, it is looking like this. This is a cylinder. Then we have a slider. This slider is connected with the cross head. Then cross head is there with the bearing. And then it is having connection with connecting rod, crank, crankshaft. Is it clear for everyone? Is it clear for everyone? Please tell me that. Yes, just give me a minute. Is it clear for everyone? Clear, guys? Yes. So whenever we are talking about this, my dear, this is said to be external combustion engine. As I said, this was the third attempt by Sir James Watt, which was a successful attempt. And I am saying this is cylinder link number 1, this is slider link number 2, this is link number 2. Okay, I am starting from here. Link number 1, link number 2, link number 3. This is link number 4, 4 and 4. Why 4, 4 and 4? Because this entire link will be having the same velocity. This entire will be having the same velocity. So there is no relative motion between all these three. That's why they are considered as 4, 4, 4. Same link. Until there is no relative motion, we will not be giving any other name to the link. It will remain 4, 4, 4 and 4. So my dear, this is the mechanism which makes Sir James Watt as the godfather of mechanical engineering. This was the first successful configuration for the railway engine. And right now we are also using it in the IC engines configurations also. Okay, so why this is said to be external combustion engine? Because combustion was happening somewhere outside, and when combustion was happening, from where steam was coming, that steam was provided here. That steam was applying force onto the slider, because of which the crank was rotating. So this was the mechanism. Here, my dear, if you will see, between 1 and 2 is a turning pair, 2 and 3 is a turning pair, 3 and 4 is a turning pair, and 1 and 4 is a sliding pair. 1 and 4 is a sliding pair. This is said to be cross head, and this bearing, as it is giving support to this, it is said to be guide or sleeper bearing. So this fixed link is said to be guide or sleeper bearing. This type of bearing is not in our syllabus. That's why in machine design you did not listen this name much. Good afternoon, Kaviraj. How are you, dear? So my dear, when we are having this mechanism, this is a single slider crank mechanism. Combustion is happening somewhere else. That's why we call it as external combustion engine. Here also, if you see, number of links are 4 only. The number of binary joints, okay, not binary joints, number of pairs. This is a turning pair, turning pair, turning pair, and sliding pair. Here also between 1 and 4 is a sliding pair. So I would like to say that between 1 and 2, between 2 and 3, between 3 and 4. These are 3 turning pairs. And between 1 and 4 is a sliding pair. So if you are talking about the simple 4-bar mechanism, there all pairs were turning pair. So we can say here also links are 4 only. If links are 4, it is also a different configuration of 4-bar mechanism. And that configuration is having 3 turning pair and 1 sliding pair. So 3 turning pair, 1 sliding pair, and here if we are having 4 links, can you tell me, if the number of links are 4, how many maximum number of inversions are possible? Tell me how many maximum number of inversions are possible. How many maximum number of inversions are possible? Tell me how many maximum number of inversions are possible. Maximum number of inversions possible are 4 only. So maximum number of inversions possible are 4 only. So here maximum number of inversions possible are 4 only. And in the simple 4-bar mechanism, you have seen the number of inversions initially were 4. Sorry, the number of inversions in simple 4-bar mechanism were 3. But here we will be getting all the 4 inversions. How we will be getting when cylinder will be fixed? So my dear, cylinder fixed, we have seen this. Now my dear, one relative motion is referred as one inversion. Here relative motion is crank is rotating, slider is reciprocating. So you will say relative motion when cylinder is fixed is rotation to reciprocation. Now my dear, when rotation is input, reciprocation is output. This is nothing but reciprocating compressor. And when output is rotation, input is sliding or reciprocation, we call it as IC engine. We call it as IC engine. Okay, we call it as IC engine. Then my dear, whenever we are going to fix the link number 2, which is crank, then you will be getting rotation to rotation. I will show you. You will be getting rotation to rotation. Input will be rotation, output will be rotation. The example is Whitworth quick return motion mechanism and rotary IC engine. Then third inversion, when you will be going for connecting rod fix. When you will be fixing connecting rod, you will get crank and slow tilt lever quick return motion mechanism, oscillating cylinder engine mechanism. This will give you rotation to oscillation. You can see all relative motion are different. Rotation to reciprocation, rotation to rotation, rotation to oscillation. And when you are going to fix the slider or piston, then my dear, you will be getting hand pump. It is also known as bull engine. Okay, beam engine was different, bull engine is different. And when we are talking about this, my dear, here you would be getting oscillation to reciprocation. I will show you all the mechanisms, don't worry about that. Okay, but my dear, for examination point of view, only this is important. For examination point of view, only this is important. So I will just tell you the mechanism and give you the formula. Nothing more than that is required from this chapter. And you should remember that you will be getting Whitworth when crank is fixed. You would be getting Gnome engine when crank is fixed. You will be getting crank and slotted lever mechanism when connecting rod is fixed. You will be getting oscillating cylinder engine when connecting rod is fixed. You will be getting hand pump when piston is fixed. That you need to remember for theory questions. Okay, so my dear, the very first important one is crank and slotted lever mechanism. I would like to tell you, when we are talking about crank and slotted lever mechanism, this is going to be the best mechanism used in shaper and planer. My dear, when I am saying best, why I am writing this word best specifically? Because when for the first time shaper and planer machines came into picture, the very first shaper and planer was made on the concept of Whitworth quick return motion mechanism. The very first shaper and planer was made on the concept of Whitworth quick return motion mechanism. But later on, that was having a problem, because stroke length, if I want to increase, the size of mechanism was increasing too much, which was improved by crank and slotted lever mechanism. So when this mechanism came into picture now, then my dear, after that, now we are not using Whitworth. Nowadays, every shaper and planer is using the crank and slotted lever mechanism. I am showing you the working of that. So you can see here we are going to have a crank. Okay, this crank is rotating like this. You can say this is the crank at that position. And my dear, this crank is having a slider like that. Now my dear, here at this point we are putting a motor. That motor is rotating the crank. And my dear, when motor is rotating the crank from this to this angle, we call this as beta. And when this will be happening, you can see this slider is present in a slotted bar. And this slotted bar is rotating from C1 to C2. And this is further connected with the ram. Ram is connected with the tool. So tool is going from R1 to R2. This is said to be the forward motion. You may be not knowing about shaper and planer, then I would be telling you, like if you have a workpiece and a single point cutting tool, you want to remove the material from that, then tool will be passing from here, material will be removed in the forward motion. And when it will be coming in the backward motion, the material is not removed. Forward cutting will happen, backward cutting will not happen. Forward cutting will happen, backward cutting will not happen. Forward cutting will happen, backward cutting will not happen. So when cutting is happening in the forward motion and not happening in the backward motion, that was a problem. Because backward motion is waste of time. So we wanted to save our time. So we wanted that backward motion should be quick. So forward will take time. Slowly, 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 slowly. Backward should come fast. Slowly, 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 slowly. Backward should come fast. Slowly, 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 slowly. Backward should come fast. That's why we call them quick return motion mechanism. So we wanted the return to be quicker. So as we wanted the return to be quicker, we call it as quick return motion mechanism. And you know that motor is rotating with the constant speed, theta by t. So if you want the time required by forward stroke is more, we need to have the theta rotated for forward stroke is more. And time required for return is less, so theta rotated for return stroke is less. So that is why this beta is the forward stroke angle. In that case, ram will be traveling from R1 to R2. And then when here the slider will reach, the slotted bar will reach, then my dear slider will move from this to this. Crank will rotate by the angle alpha, which is definitely lesser than beta. Then my dear, the backward stroke will happen and tool will be coming back. So you will see tool is going slowly forward, coming backward like this. Slowly forward, coming backward like that. Slowly forward, coming backward like that. So if that is going to happen, my dear, we call it as quick return motion mechanism. Okay? And this mechanism is a quick return motion mechanism. The best one nowadays, it is only useful. Okay? So my dear, here when you are going to find out the stroke length, it is coming out to be 2 times length of slotted bar into radius of crank but a length of fixed link. Here this fixed link is the connecting rod of single slider crank mechanism. The length of this is L. The length of this is R. And the length of slotted bar is LSB. So we can write it as 2 times of L of SB slotted bar into R by L. This is the formula for the stroke length of quick return motion mechanism. And my dear, I would also like to give you one more formula, that cos alpha by 2 is written as R by L. This is derived from this triangle. If you see this triangle, this is L, this is R, and this is alpha by 2. Why I am giving you this formula? This will help you in deriving the questions, in doing the questions. And you know alpha plus beta is nothing but 360, and beta by alpha is said to be quick return ratio. And that can also be written as time required for forward to the time required to return. Is it clear? So here I am not going for derivation. That is how we can save the time, because derivations are useless. Okay. Is it clear for everyone? Yes. Harsha, Akhilesh, Shreyas, Harikesh, Sandy, Aritro, Kaviraj, everybody, please tell me, are you getting it or not? Anywhere if you find difficulty, you can tell me. Okay, don't worry about that. And guys, you know that this is the mechanism. When this connecting rod is moving like this, when this slotted bar is moving like this is sweeping some area. If someone asks you the area swept, you can see this is a part of a circle whose radius is the length of slotted bar. So you can write the area swept by slotted bar as, this can be written as total area will be pi LSB ka square, but we are traveling only this much. So if you will see this much, you know from center this was 90 degree and this angle was alpha by 2. So this angle will surely be 90 minus alpha by 2, and double of that will be 180 minus alpha. So I can write into 180 minus alpha by 360. I am writing again, area swept by slotted bar is pi LSB ka square into pi minus alpha divided by 2 pi or 180 minus alpha divided by 360. Either you keep everything in degree or everything in radians. Is it clear? Yes, Harikesh, this is cos alpha by 2 r by L. Because you can see this triangle, na? You can see this triangle. This angle is alpha by 2. This is 90. This is R. This is L. Write down the cos alpha by 2. It is going to be base by hypotenuse. R by L. Okay, because that will be utilized during the questions. Okay. So guys, do like and share the session. Do like and share the session. Okay guys. अरे भाई फिर डेरिवेशन नहीं देखना ना कृष्णा. Okay, area of swept okay, area of sweeping. So you can see this total area is going to be a area of circle. Area of circle will be pi r square. Radius is length of slotted bar. But we want only this much sector of a circle. So the angle here is pi minus alpha or 180 minus alpha. Total angle is 360. So we are writing pi minus alpha by 2 pi into pi LSB ka square. Okay. We cannot go for the derivation. Derivation wise, Tom can never be end then. Tom will go for 5-6 days. Okay. Is it clear? Now it is clear, Krishna, Harikesh, Abhi, Vinay, Ashray, Mohan. Okay guys. So now we are moving further. This is the Whitworth quick return motion mechanism. Whitworth quick return motion mechanism. Now from here, my dear, you just need to understand that it is coming when crank is fixed. And here input and output both are rotating, so we can call it as double crank mechanism, or you can say it is rotation to rotation. What is going to happen here is we are having a small circle like this. And then we are having a bigger circle. And this is the center of small circle, this is the center of bigger circle. I feel bigger circle needs to be redrawn. This is the bigger circle. And this is the fixed link. And on this we would be having a slotted bar like this, and one end of the slotted bar is going to keep on rotation on the smaller circle, and here we would be having a slider present in the slotted bar, and this slider will be rotating in this bigger circle. This is the case, and then I would be having a connection like this. With this there is the RAM. RAM is having a tool. This is moving like this and this. This is the mechanism. Now my dear, you need to understand animation is also going on. Credit goes to gif.com. You can see this is the animation of Whitworth mechanism, how it is going to happen. Okay, so you need to understand here one thing, that whenever this point will be reaching here, this is, I am saying it as A, this will be A1. At that time, this will be coming here when the slider will be reaching here. So this point I am calling as this is B, this is B1. And at that time RAM would be here. I am calling it as R1. And when this A1 point will be reaching here, this B1 will be reaching here, this R1 will be reaching here, we will be calling it as R2. So this R1, R2 will be the stroke length of the tool. And here you can see, whenever this motor is attached here, motor is rotating. When motor is going to travel this angle, which is beta always more than alpha, at that time forward stroke is happening. And for this return stroke is happening. So that is why it is also a quick return motion mechanism. Although I am explaining you this, but that explanation is not required for the exam. For exam, you just need to understand कि when you will get Whitworth mechanism, when the crank of the single slider crank mechanism will be fixed and input output both will be equals to the input output both will be rotation. And here one thing you need to understand, that when this point will be reaching here, you will be reaching to the extreme position. When this point will be here, you will be reaching to the extreme position. So that is sure that the distance R1 R2 should be equals to the diameter of smaller circle. Why? Because when this is here, this is here. When this is here, this is here. And in between these 2 points only this link is there, which is a constant length. So we would be saying that the dia of smaller circle is nothing but the stroke length. So that is the problem. If you want to increase the stroke length, you need to increase the diameter of smaller circle. Corresponding to that, the diameter of bigger circle will increase. Corresponding to that, the size of entire mechanism will increase. So entire mechanism will become bigger in size, which we never want. हम कभी नहीं चाहेंगे mechanism बड़ा बने. So my dear, that is why if you see the crank and slotted lever mechanism, here stroke length depend upon slotted bar length, crank length, connecting rod length. Even by reducing the connecting rod length, we can increase the stroke length. So for stroke length, there are 3 parameters there. So here if I want to increase stroke length, it is going to be easier than the Whitworth. That's why Whitworth is replaced by crank and slotted lever mechanism. Is it clear for everyone? Please tell me that. So question wise, all other mechanisms are not important. So as we are preparing for GATE, when we are coming for paid course, we need to cover all exams, GATE, ESC, ISRO, DRDO. So we go for detail of every mechanism. But for GATE, only numericals are coming on this. All others are not having any numerical part. So that's why we will not waste much time over them. Okay, we will be just having more time on this mechanism which we have given. Now we will see other mechanism fastly, because we will give time where the questions are coming. I will tell you everything what is coming in exam, okay, but not as per the PhD point of view. So when we are talking about oscillating cylinder engine, here also the connecting rod of single slider crank mechanism is kept fixed, then we get this mechanism. Here my dear, you need to understand there are 2 types of connection. Whenever you join the slider with this link as a welded joint, then if this is link number 1, this is also link number 1, because there is no relative motion between these two. But if we are joining a slider with the sliding pair, with the turning pair, then we will be having this motion, relative motion. So here if this is link number 1, this will be link 2. So in oscillating cylinder engine, we are having this as link number 3 and this as also link number 3. So we are going to have a welded joint configuration. So my dear, here when this crank will be rotating, this and this link are connected to each other. So when this will be rotating, this is not a turning pair. So for motion of this slider, cylinder has to rotate like that. Cylinder has to oscillate like that. I can show you the animation. You can see. This animation will make you clear about everything. Please tell me, are you clear about this or not? So you can see this cylinder is oscillating like that. And when the cylinder is oscillating like that, when the cylinder, once again credit goes to gif.com. So when we are talking about this cylinder is going to rotate like that, this was the second attempt by Sir James Watt in making the steam engine. Here some team member was also there, William Murdoch was the person, and this engine was specifically given the name of Wobbler. And this engine was a very compact engine, and this was utilized in the small steam engine at that time. Nowadays also we are using them in the small toys and also in the prototypes. So when we are talking about this oscillating cylinder engine, now you can see when cylinder is oscillating, but in the locomotive we were requiring a very big size cylinder. So 800 kg cylinder, if we are going to have oscillation about a pin, my dear, if the speed will be increasing, the accident will be so severe that you will be not able to tell how many people were there in this room. So that is why we will never prefer this configuration for high speed. It was also good for 60 to 80 rpm. So this was the second failed attempt, and third successful attempt was single slider crank mechanism, which you have already seen. So when they were coming, this was came first, single slider was came later, but now we have arranged it in the order of inversions. Like first law, second law, third law of thermodynamics came. Zeroth law came after second law. But why we said it zeroth law? Because after arranging we know it is the fundamental law. So that's why zeroth is coming before the first law. Okay, so that is how it came before single slider crank mechanism. But when we have arranged in the form of inversions, that was coming first, this was coming later. Clear guys? Please tell me, are you getting it or not? Next is rotary IC engines. Next is rotary IC engine. To understand that, I would be saying that just consider we are having a cylinder block, and on that cylinder block we are going to have 7 to 9 cylinder. I am not making 7 to 9, I am making only 4 because I am just going to explain it to you. And as you know, crank is fixed. This is the center of cylinder block. This is the fixed crank. Now my dear, if you would be having this to be piston of this cylinder, similarly the piston of this cylinder will be somewhere here, the piston of this cylinder will be somewhere here, the cylinder of this cylinder, this piston will be somewhere here. Now my dear, why 7 to 9 cylinder? Because more number of cylinders were required, because this was made for the application of aircraft. By the Wright brothers, this was the very first aircraft engine. Why 7 to 9 cylinder? Because more power was required, so more cylinders were there. And why odd number? Odd number helps in better balancing. So when we will study the balancing of radial engine, you will get to know the idea behind that. So here my dear, when the combustion will happen, there will be a very high force coming onto the piston. So when my dear piston will try to apply the same force to the connecting rod is joined with the fixed crank. So if I am keeping fixed like that, you are applying force here, that force will be transferring here. And you cannot move my hand until you break the shoulder, because I am resisting it. So that is why it cannot move. But the same forces are also transferring to the cylinder walls. And cylinder block is free to move. That's why cylinder block will start moving, because crank is fixed. And when this cylinder block will start moving, this is happening in every cylinder. So you can see this will be rotating with a very high speed, and this rotating cylinder block you will be attaching with the aircraft propeller shaft, and it will keep on rotating at very, very high speeds. So you can see the animation. You can see combustion is happening in all the cylinder one by one. So they are showing it in one cylinder initially. Clear for everyone? बोलो भाई आ रहा है कि नहीं? आ रहा है कि नहीं? अभी 3.5 घंटे ही हुए हैं. First chapter is about to over. Okay, you can see input is rotating. What is rotating? The connecting rod. Output is rotating. What is rotating? Cylinder block. Okay, so that is how the things are going to happen. Now my dear, we are reaching to the hand pump, the last inversion of single slider crank mechanism. In next 15-20 minutes I will complete double slider crank mechanism, and then we will have a break. Okay, so don't worry about that. Okay, so by 2 p.m. we will have the break, don't worry. Okay, and then we will be having the break. After break we will see eye center approach, relative velocity approach, acceleration approach. Okay, after that we will have other topics one by one. And my target is to complete the theory of machines without vibration by 9 p.m. because 9 p.m. is my paid class today. So up to 9 p.m. I want to complete all the topics. This is the maximum time. Okay, fine guys. So when we are talking about the hand pump, so my dear, hand pump mechanism we can get by slider is fixed. In many of the books it is given by cylinder fixed. Don't go by that books. Okay, I have told many times. As we are having marathon, otherwise in the paid courses or in the basic fundamental series, I derived it how hand pump is becoming. So for the timing, we are going to say how it is coming. I am showing you in the small. Let us say this is a crank, this is a connecting rod, this is a slider, this is a cylinder. Now it is a single slider crank chain. It is not a single slider crank mechanism because no link is fixed. Now let us say I am going to remove the cylinder from here. Now we are left with only 3 links, 1, 2 and 3. And let us say I am going to fix the slider. And after fixing it, I am going to make it hollow. So when I will be make it hollow, it will look like this. And now connecting rod cannot be in the air. So to join the connecting rod, I am providing a turning pair here. So this was the crank. This is the connecting rod. Now my dear, I am going to provide a link in place of cylinder because we have removed the cylinder. So in place of cylinder, we are having a plunger, and with the welded joint connection, a plunger and plunger rod is attached. So if this is link number 1, this is 2 and this is 3, this will be 4, this will be 4. Now my dear, we are going to extend it. And after extending it, I am going to oscillate it. When it will be oscillated, as at this point this is not fixed, this will go up. And this will go up and this crank will be coming in this position. And your connecting rod will rotate like this. And your plunger will come up. Here vacuum will be created. Because of vacuum, water will come up. And when water will come up, you will take the water out. This is the mechanism going on in front of you. Clear for everyone? Clear for everyone? Clear for everyone? This is the hand pump and here slider is kept fixed. Okay, we are keeping the slider. So this thing you may be thinking, sir, it is like a cylinder. Yes, you can say this is a cylinder. But this cylinder is the cylinder of hand pump. It is not the cylinder of single slider crank mechanism. This mechanism is formed from single slider crank mechanism in this way by keeping its slider to be fixed. And like I have shown you hand pump, I can show you other mechanisms also. But that is not required for BTech level, for GATE exam, that you will be studying in the masters, when you will go for masters. Like I have shown you now how hand pump is formed. You can see every mechanism like that. With this single slider inversions are over. Now we are moving to the inversion of double slider crank mechanism. But before that, let us see some questions and then we will see double slider inversions and then we will take break. So by 2 p.m. we are going to take break. This is the question in front of you. You can see a 4-bar mechanism with all revolute pair has a fixed link 30, input link 40, coupler 50, output link 70, and now you can say which one of the following statement is correct. Both link can execute full circular motion means double crank. Both link cannot means double rocker. Only output link cannot execute means crank rocker. Only input means rocker crank. So you need to tell what will be the answer for this. I want answer from your side, guys, for this question. This is from Grashof law. Darshan is saying A is the answer. I want answer from all of you, then I will give you solution. 2 p.m. we will take break, don't worry. Yes, what would be the case? What would be the answer? Tell me, guys. Yes. Solve it. Very good. Plus L. S plus L is 100. What is P plus Q? P plus Q is 90. 40 plus 50. So you can see S plus L. 30, 70 is 100. P plus Q is 50 and 40, 90. Is it clear? Is it clear? Is it clear? So Grashof law is not satisfied. When Grashof law is not satisfied, then the answer will be double rocker. Okay? When Grashof law is actually, this was a GATE question, but in GATE question, Grashof law was satisfying. So data is changed in such a way that Grashof law is not satisfied. So when it is not satisfied, what you will be having? You will be having double rocker. Everybody got it? Harikesh, Sandy, Ashray, Harsha, Shivram, Ajay, Sandy, Raja, Darshan. Next question. This is a good one. This is a good one, guys. Let us see how many of you give the right answer for this question. Everybody. PQRS, planar closed kinematic chain, is formed with the rigid link PQ, QR, RS and SP with all revolute joined, the link to be fixed to obtain a double rocker mechanism. The link to be fixed for double rocker mechanism. So my dear, we have PQ, QR, RS, PQ, RS, and they are saying that it should be a double rocker mechanism. So you know we will be getting double rocker mechanism. First of all, if low is not satisfied, any link can be fixed. Okay, but you can see this is shortest, this is longest. So here S plus L is less than P plus Q. So low is satisfied. So only when shortest will be coupler, then will be double rocker coming. So my dear, they are not asking double crank, they are asking double rocker. So double rocker will be coming when shortest link is coupler. So they are saying for that PQ should be coupler. And you know, in a simple 4-bar mechanism, coupler is the link. Coupler is the link just in front of fixed link. So my dear, if you want PQ to be coupler, then RS to be fixed. So the answer for this is going to be C. This is a wonderful question. Is it clear? Because fixed, if PQ is fixed, you will get double crank. They are saying we are getting double rocker. Clear, Faninder, Sandy, Ashray, Vinay, Harsha, Harikesh. Answer will be C. Very good, Shreyas. Okay. Now we are having this mechanism. You know here, this is the longest link, this is the shortest link. Tell me which mechanism it is. So you need to first check whether the low is satisfied or not. If low is not satisfied, then no need to go for any calculation. Tell me guys. Here you know low is not satisfied. S plus L is more than P plus Q. So simply say double rocker mechanism. Yes. So guys, now this is the last question on Grashof law. Then we will see others. ABCD is a mechanism. AB 200, BC 300, CD 400, DA 300. They are asking which one of the links should be fixed to get double crank mechanism. Which link to be fixed for a double crank mechanism? Which link to be fixed for a double crank mechanism? You can see this is shortest. Longest is CD. This is P and Q. So S plus L, P plus Q. So you need to fix shortest to get double crank. A would be the right answer. Okay, now my dear, we have seen all these mechanisms. Now we are entering into the double slider crank mechanism, the last topic of this chapter. After which the first chapter will be over. So when we are talking about double slider crank mechanism, this time two turning pair are converting into two sliding pairs. Here this is link number 1. This, okay, first of all we are saying this is link number 1. This we call it as slotted plate. This is a slotted plate. This we call it as link 1 slotted plate. And my dear, on this slotted plate we have this slider, which is link number 2. We have this slider, which is link number 2, and this slider, which is link number 3. And to these two sliders there is a link which is connecting them, and this link we are calling it as link number 4. So total 4 links are there, and between one and the slider 3, between 1 and the slider 2, between 1 and 2, 1 and 3, we have sliding pair. But you can see between 3 and 4, 2 and 3, we have turning pair. So 2 and 3, 3 and 4, we have turning pair. So I told you now, this time 2 turning pair, 2 sliding pair, and we call it as double slider crank mechanism. Clear for everyone? And when we have this configuration, this time if I ask you how much maximum inversions are possible, please tell me that. Because in previous 2 mechanism questions have already been asked. In simple 4 bar maximum the total actual inversions were 3. In single slider inversions were 4. Here how many inversion maximum can be possible? Maximum I am asking. Maximum inversion is equals to number of links. Maximum inversions are equals to number of links. Arey, how many links are there? Bhai, links are 4. So maximum inversions possible are 4. But here also we will not be getting the maximum inversion. Here also we are going to get actual inversions as 3. Actual inversion we will be getting 3. I am showing you how we are going to get 3. First of all, we will be fixing link number 1. When we are going to fix link number 1, which is slotted bar, you would be getting elliptical Dremel, which is a device used to plot the ellipse by civil engineers. Then if you are going to fix any of the slider, you will get Scotch yoke mechanism, which is giving you simple harmonic motion used in the power hacksaw machine. If you are going to fix the link connecting the slider, you will be getting Oldham coupling, which is used to connect the shaft with lateral misalignments. One by one we will see. Okay. So my dear, when we are going to fix the slotted plate, we are getting this mechanism. I can also show it in this way. Like this is a slider, this is a slider, and they are connecting like this. And when this slider will be coming down, this slider will be going in right. And for simplest way of explanation, we can also show it like this. You know, when it will be going down, it will be going right. If I want to see the locus of any point on this link, P, X, Y, then you can say this is going to be X, this is going to be Y. I am saying this is AB, let us say. So if you are going to say that triangle, this angle is theta, this angle is also theta. If I see this triangle A, P, Q, you can write X by AP as cos theta. Similarly, if we see the triangle BPR, we can write Y by BP sin theta. If you have studied coordinate geometry, you would be remembering sin square theta plus cos square theta is 1 by trigonometry, and when I will be using this relation, I can get the locus. I can write it as x square by AP ka square. Can you tell me this equation represent which of the geometry? Can you tell me this relation represent which geometry? Yes, this is giving us ellipse. My dear, but ellipse will be there only when AP not equals to BP. Because if AP will become equals to BP, it will give you circle. So if P will become the midpoint, then you will be getting the circle. But my dear, out of infinite possibility, only one possibility is giving us circle. All other possibilities are giving us ellipse. That's why the name of the device is nothing but elliptical Dremel. So that is why we are calling this device as elliptical Dremel. Clear for everyone? Clear for everyone? So we call it as elliptical Dremel. So my dear, if we will be calling it elliptical Dremel, it is used for ellipse. If someone will ask you semi-major and semi-minor axis, then 2AP and, sorry, if someone will ask you major and minor axis, this is 2AP and 2BP are major and minor axis. Okay? Then my dear, this is how it looks like, the animation part. Clear? Now my dear, we are moving to the next mechanism, which is Scotch yoke mechanism. So my dear, here we are going to fix this one of the slider. Here elliptical plate is free to move, but slider is kept fixed. So when we are going to have this slider to be fixed, this is connected with another slider like this. So my dear, when you will be giving the rotation to this link, then this slider will reach to this position after some time. But if slider is moving like this, slotted plate also have to move. So slotted plate will also shift like this. This is the new position of the slotted plate. So can you see when this rotation will happen, slotted plate will go this, and when it will be coming back, it will be coming back. You can also show this mechanism as this. So when this will be rotating, this will be going like this, coming back like this. So this is going to produce simple harmonic motion. So when you want to produce simple harmonic motion, when you want to produce simple harmonic motion, SHM, then my dear, we call this mechanism as Scotch yoke mechanism. It is used in power hacksaw machine. It is used in power hacksaw machine. It is used in power hacksaw machine. Okay? This is the mechanism you can see. This is the mechanism you can see. Okay? Then my dear, one more representation. Then we have, if connecting rod is fixed. If connecting rod is fixed, this one. Initially you are having the slider like this. Let us say this time my slider is getting connected with a shaft like this. And if I will be rotating this shaft, this slider will also rotate. So let us say slider will rotate like this. But you know, slider cannot rotate without rotation of slotted plate. So slotted plate here will also rotate like this. Slotted plate is like this and this. So if this part is going here, this also will be going here. So here also the rotation will take place like this. And slotted plate was having a slider. That slider will also rotate like this. So if I attach one more shaft with this slider, that will also rotate. So you are giving rotation here and you are getting rotation here. This is said to be the transmission of power with the help of couplings. If we have two collinear shafts, then to join them we are using the flange coupling. If you are having two angularly misaligned shafts, we are using universal joints. But if you are having one shaft like this, other shaft like this is said to be lateral misalignment. Then we used Oldham coupling. This is said to be Oldham coupling. And my dear, if this is the D distance, you know that coupling is going to have connection with both the shaft. So coupling will be rotating with input also, with output also. Input have this axis as central axis, output have this axis as central axis. When something is rotating, with two bodies having different center of rotation, that body has to slide, which you can feel here. You can feel this in between thing is the Oldham coupling. You can see this is sliding also. So we are going to have this coupling in this way that it is having a projection, horizontal projection like this. Likewise, and vertical projection on the other side. Why like that? If this is a coupling, here it is like that, here it is like that. So that here I am holding with vertical and here I am holding with horizontal. So that coupling shall not fall down. Okay. So you can see, my dear, this sliding motion is happening and the velocity of sliding is given as d into omega. Here d is the offset or lateral misalignment, omega is of input shaft. From here numerical can come this year because till now it have not been asked. So maybe gate 24 will be having eyes on this. This is the d, the difference between the axes of both the shafts. You can see both the shafts are having different center. Oldham coupling, one more animation. Clear for everyone or not? Please tell me that. This time you will get the PDF at the right. Okay, because today I am taking the class from a smart board where this PDF tool is working. So don't worry. Here today you will get PDF with annotations. Okay, but I will be teaching in that way only until you would be there with me till night. Okay, if I will feel students are reducing, then I will also go faster, skipping the things. Okay, not skipping the things, skipping the derivations part. So be there with me. ये सिर्फ मेरा मैराथन नहीं है, आप लोगों का भी मैराथन है. Okay, is it clear guys for everyone? Yes, wonderful guys. So with this we have completed it. Now let us solve some questions on crank and slotted lever mechanism. Then we will take the lunch break of 40-45 minutes. That's why Harikesh. Crank and slotted lever mechanism, find the length of stroke if quick return ratio is 2 and slotted bar length is 250. So you know that quick return ratio is beta by alpha. It is given as 2. And you know that alpha plus beta is 360 degree. From these two equations, find out the value of alpha, find out the value of beta. Then you know cos alpha by 2 is R by L. And stroke length is 2 times of slotted bar length into R by L. So you need to find out the answer. All the data are given to you guys. Yes, Mohan. Yes, Harikesh. Solve this question. This is from crank and slotted lever mechanism. Yes. I am happy guys the way I am looking at you guys in the first day when we were taking SOM. Then casting welding also class happened more than 10 hours. You guys have shown a lot of support and I'm happy with that. And that will definitely help you in exam because these revisions are the best revisions. Because you are listening to the things once again from me. The same things. Whenever we are listening the things, it is easier and long time remembrance is possible than what you are reading. Answer for this is, you need to find out. First of all, you will be getting alpha 120, beta 240. So alpha by 2 is cos 60. Cos 60 is R by L. Okay, put this value here, you will be getting the answer to be 250. Very good. This question, figure shows the layout of a quick return mechanism of oscillating type. The driving crank BC is 30. Okay, R is 30. R is 30. They are saying the time ratio of working stroke to the return stroke is 1.7. So they have given the time required for forward to the return stroke is 1.7. This is also beta by alpha. Okay, and the length of working stroke length is given as 120 mm. Then find out which of the statements are true. They are saying time of return stroke is 1.7 times more than cutting stroke. Time of return stroke is 0.59 times more than cutting stroke. Center to center distance between A and C is 75.74. It can be a MSQ also, mind it. Treat it as a MSQ, multiple select question. So when we are having stroke length as 120, we are going to have this is length of slotted bar is not mentioned. They have said the driving length is R is given. Yes, R is given. So the length of slotted bar is not given, into 2 into R by L. Okay. Yes, but you know cos alpha by 2 is R by L. So you can find out the L from here. First of all, A or B, which one is correct? Time of return stroke is 1.7 times more than cutting stroke. Is it correct? No, return stroke is faster, so A is wrong. Time of return stroke is 0.59 times. Time of return stroke is not more. A and B both are wrong. So you need to check whether C is correct or not. Arey, B is wrong, bhai. Time of return stroke is this time more. Return stroke can never be of more time, bhai. Return stroke is always taking lesser time. So when you would be having this, beta by alpha is 1.7. So beta is 1.7 times of alpha. So you need to just find out alpha, as alpha plus beta is 360 degree. Find out alpha, then use cos alpha by 2 relation. You will get the length to be 75.74 mm, and then you will be saying C would be the right answer. Is it clear for everyone? Clear for everyone? Arey bhai, forward stroke is taking more time, na? Return is always faster. So return is always taking lesser time. So we can write T forward by T return is beta by alpha is always more than 1. Clear? Tell me, are you getting it? Are you getting it, guys? Okay. So with this we have completed this chapter, guys. Now there are many questions, but these questions you will see. One question let us do, okay? Others we will be doing in the practice sessions. Okay? Let us solve this question. Given figure shows quick return motion mechanism, crank OA rotates clockwise and OA is given. This is OA, R, and this is OO dash is L. So they have given R as 2, L as 4. You know that cos alpha by 2, R by L. From here you will get alpha. Then alpha plus beta is 360. You will get beta. Okay, and they have asked you the ratio. So beta by alpha you need to find out. These are the types of questions which are coming. This is the PYQ of GATE only. Yes, answer will be 2 here. Answer will be 2 here. Very good. Likewise, here they have given alpha by beta is 1:2. Whenever they give 1:2, it means they have given alpha by beta. So you know for this beta will be 240, alpha will be 120. So you can write cos alpha by 2 is R by L. They have not given R, they have given L. From here directly you will get R as 250. These are the types of questions which are coming in GATE from this mechanism. Very easy questions. So guys, now we are going for a break. Okay, now we are going for a break, and after the break we would be having the next topic, that is eye center approach. Okay, so I would like to tell you here the class will resume now at 2:45. Okay, so this is the break. Okay. If you want, we can reduce 5 minutes. Okay, 240 कर लेते हैं. ठीक ठीक लगा लेते हैं 240. Okay, so we will be back at 2:40 p.m. Okay, so we will meet and then we will start second chapter, velocity analysis and acceleration analysis. Okay, that will take 1.5 hours up to that. Then we will enter into flywheel, governor, cam, balancing, like that. Vibration we are not going to cover today. Vibration will be covered with machine design I am planning. Let us see, that also I will inform you at the end of this session. So let us meet after the lunch break. Okay. Gears will also be with Darshan. Everything will be covered. Gears will be covered today only. And tire tom will be covered today. Okay. So we will meet again at 2:40. Okay. Yes guys, are we ready? Am I properly audible, visible? Please tell me that. And do like and share the session guys. Let me once again share in the Telegram channels. Class is resumed now. Okay guys, now we are starting. So you can see this is the schedule of mathematics and aptitude classes on this channel, and we would be coming up with every day 3 to 4 hours mini marathons. Okay, for every topic, one day mathematics, one day aptitude, one day aptitude, one day mathematics, like that, and every topic will be covered. Okay. And guys, if you want one-to-one counseling from our counselor, the link is there in the description of this session. You can fill the Google form for that. Now we are going to start, my dear, the velocity analysis. Okay. Now we are, yes. Harsha, hi Aniket, fine, Ajay, Raja. Okay, I already told you one thing now, that tomorrow machine design marathon would be at 6 p.m. so that you get some rest also in the morning time. So tomorrow we will be having 6 p.m. rest, we will be having on the same time. Okay, fine. So let us continue guys. So now we are talking about, my dear, velocity and acceleration analysis. First we will go for velocity, then we will go for acceleration. Now my dear, if you remember, when you were studying the metal cutting, you were defining something called as material removal rate. Okay, हाँ, मकर संक्रांति is there tomorrow. पतंग उड़ानी है क्या? गेट है यार, गेट दे लो, मकर संक्रांति तो हर साल आती है, ठीक है? अभी एग्जाम पर ध्यान दो, उत्तरायण, मकर संक्रांति, I know festival is there. So guys, when we are talking about the velocity analysis, why it is required? Because whenever cutting tools are going to machine the workpiece, if you want to find out the material removal rate, we will definitely be requiring the velocity. You must have seen material removal rate is FdV, है ना? You were finding out like that. So velocity would be required. So that is why it is important. And why acceleration would be required? To get the forces. So that is why velocity, acceleration are becoming important, and we need to find out them. And for this field, the godfather was none other than, sir, who was the godfather of this field? Arnold Kennedy. Arnold Kennedy. Then my dear sir, Arnold Kennedy want to go for the velocity and acceleration analysis for the mechanisms. And when he have seen the very first mechanism as simple 4-bar mechanism, he was very well aware just by looking at the mechanism that this input link will be in the rotation, output link will also be in the rotation. Rotation may be complete or partial, but their motions are well defined, which is pure rotation. So if I say this is a mechanism OABC, so on link OA and BC, you want to write velocity of any point, you can directly write V is equals to R omega. Like if you want to write velocity of A, you can directly write OA into omega OA. So it is very easy to write. And you know, OA is the input link for which your birthright is input. Without input, you cannot get output. So input will always be given to you. And if omega of input is given to you, you can find out the velocity of A very easily. And when you can find out velocity of A, there is no problem in this link. The problem was there with this link. The problem was there with this link, which is called as coupler. Because the motion of coupler is neither translation nor rotation. Here I am giving you a thumb rule. If any link is connected with the fixed link, its motion is well defined. And if any link is not connected with the fixed link, its motion is not well defined. Like if you see this OA and BC are connected with the fixed link, so their motion is well defined. Similarly, when you will be having single slider crank mechanism, here my dear slider is connected with this connecting rod, crank and this. Here also slider and crank. Crank is rotating, slider is reciprocating. But connecting rod is a problematic. So whenever some link is connected with the fixed link, its motion is well defined motion. Well defined means either it will be pure rotation, pure translation, pure rolling. You will be knowing that. SHM. But if some link is not connected with the fixed link, like here AB link is not connected, like here connecting rod is not connected. So likewise, such links are having the motion which is a general motion. So when we are talking about the connecting rod for single slider crank mechanism or double slider mechanism or coupler in the simple 4-bar mechanism, they are having the general motion. They are having the general motion. So any link, if it is not connected with the fixed link, any link if it is not connected with the fixed link, its motion is going to be general motion. You may be thinking, sir, kya general motion laga rakha hai? What is the problem with general motion? Like we have derived the relation for pure translation. Likewise, we can derive the relation for pure rotation. Likewise, we can derive the relation for general motion. But the problem is general motion is not a single motion. It is the combination of infinite number of motions. For every motion, we need to derive a separate relation. So if you are going to derive a separate relation for every motion, for infinite motions, it is similar to impossible, near to impossible. So my dear, that is why it is not that simple to deal with. So finding the equations for general motion is not a good idea, because there are infinite configurations. In one instance 60% translation, 40% rotation. Okay. Other instant 50% translation, 50% rotation. So for how many positions you will find out the equations of motion for this general motion? So that is going to be near to impossible. So we cannot go for it. We cannot go for it. So my dear, that is why second idea came into picture. What was the second idea? That convert this general motion into pure translation or pure rotation, into some known type of motion. So for that, my dear, Sir Arnold Kennedy have given two approaches. One is said to be eye center approach, other is said to be relative velocity approach. Actually, Sir Kennedy studied pure translation and pure rotation in detail. And when he studied pure translation and pure rotation in detail, he get an idea that yes, general motion can be converted into rotation. But for that, what was the idea? Idea was, he have seen that if some body is in pure rotation, like let us say we have this body is in pure rotation, then when some body is in pure rotation, the idea is its velocity is always perpendicular to radius. Like this is radius, this is velocity. 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 So the point is velocity is always perpendicular to the radius. So just Sir Kennedy reversed this statement. If some body is in rotation, velocity is perpendicular. So he said if we will be sitting perpendicular to the velocity, we will feel the motion is rotation. So what he have done, he have taken this AB link, that is connecting rod, and he have seen the motion of this at time t. And after dt, he found it reached to the new position a dash b dash. He said this is the position at t plus dt. I am showing you the enlarged view, otherwise in dt time that much motion is not possible. And when this motion is happening, this AB is the part of this mechanism only, because motion I read just with the help of the motions of mechanism only. So I am just showing you enlarged view. And my dear, you can see from A in dt time, A reached to A dash, B reached to B dash. So I can very easily say that the direction of velocity, direction of motion is this here, and direction of motion is this here. And if you are going to sit perpendicular to that, so I will take the perpendicular bisector. What do you mean by that? If you would be looking at point A from this green line, you will find point A is in the pure rotation. You will find point A to be in the pure rotation. Similarly, when you will be taking a perpendicular from BB dash, from this blue line, you will say point B is in pure rotation. Point B is in pure rotation. But my dear, if you are going to say the intersection of both, from this point A and B, both will be in pure rotation. So if you are going to sit at this point, you will see A and B both are in pure rotation. Likewise, you can take any number of points and you can make their perpendicular bisector. You will find every perpendicular bisector is passing from this point. And this wonderful point was given the name of I center of rotation. And they have said this is the point from which this entire link will looks like in rotation, but this is known as instantaneous center. Why? Because at other instant the velocity direction will change, perpendicular bisectors will change, so the point will change. So this point is a moving point generally. So as this point can be moving, we cannot say this is a permanent center. So that's why we call the name instantaneous, because this is defined for a particular instant. What happened to this in the next instant, nobody knows. That's why we call it as I center of rotation. And from this center, if you take a axis perpendicular to the plane of paper, to the plane of slide, this is said to be I axis of rotation. So about this point and axis, you will find this AB is in pure rotation for that particular instant. So that is why, as you know, if this is radius, it is rotating with omega, the velocity is r omega. So what you are doing, you are joining the center with the point. So if I is the center, you want to write the velocity of A. So you would be writing velocity of A with respect to I as AI into omega AB. This is the concept of I center. Similarly, if you want to write down the velocity of B, you would be writing BI into omega of AB. So with that, you can write the velocity at any point. Let us say you want to write down the velocity of this point R. You will take the distance from R. So velocity of RI into omega of AB. Is it clear for everyone? This is the wonderful concept of I center. So you just need to sit perpendicular to the direction of velocity. This was the concept of I center. Is it clear for everyone? Now my dear, I would like to tell you that as this I center is not a fixed point, it is a moving point. If it is moving in some path. Path of motion is said to be locus. So my dear, I would like to say the locus of I center. The locus of I center. We call this point as we call this locus as centroid. Similarly, I axis of rotation is also moving. When I center will move, I axis will move, and that is said to be the locus of I axis. It is said to be axode. So centroid and axode are nothing but the locus of I center and I axis of rotation. Is it clear? So my dear, here I would like to tell you, if we are going to define it, that if we are going to have I center as a fixed point, it is not moving, let us say. It will happen when we are having a simple 4-bar mechanism. You know that this point is always a fixed point about which this link is rotating. So if this I center, this time this point will be acting like I center. Yes, this instantaneous center is a fixed center. It can be. So if this is a fixed center, then my dear, if you are going to say its locus, it will remain that point only. And if you are talking about axode, it will be an axis passing from this point. It will be an axis passing from this point. So that will be nothing but line. Then my dear, let us say we are going to have this I center moving in a straight line like this. Then locus of I center is a straight line. But when you will be passing axis from this, these axes will make a surface like this. This surface is nothing but a plane surface. So xod will be a plane surface. My dear, let us assume the eye center is moving in a curvature. So eye center is moving in a curvature and you would be making the axis from these points. Then my dear, the axis from this point can also be made. Then it will be making a surface like this. So if it is a curvature, it is a curved surface. You can simply say whatever this is, add one dimension to that. Whatever this is, add one dimension to that. You can say add thickness to that. So this is how we can define the centroid and xod. Now my dear, we are going to talk about the number of eye center in a mechanism. Number of ICs. My dear, if we are having number of links in a mechanism as L, then we would be having the number of eye centers as LC2. You can also write it as L into L minus 1 divided by 2. Is it clear for everyone? Is it clear for everyone? So number of eye centers are given as LC2, which is L into L minus 1 by 2. Okay, so if we are going to have number of links as 4, the number of eye center will be coming out to be 4 into 4 minus 1 by 2. And my dear, when we are talking about this, if number of links are 6, then eye center will be 6 into 6 minus 1 by 2, 15. Okay, so my dear, when we are defining the eye centers like that, I would like to tell you key eye center is nothing but instantaneous center of rotation. Eye axis is nothing but instantaneous axis of rotation. And my dear, now how it is defined actually? It is defined as IMN. So we can say it is the point about which relative motion of link M and link N is pure rotation. So my dear, IMN is defined as the point about which the relative motion between the two links is going to be a pure rotation motion. That is how we define IMN. And I would also like to tell you, as we are talking about relative motion between M and N, then IMN or INM would be the same point. They are not going to be different point. Previously also I told you, rotation to reciprocation or reciprocation to rotation is considered as same only. So my dear, that is IMN or INM is going to be same. So let us say if we are having a 4-bar mechanism, you already have seen 4-bar mechanism will be having 6 eye centers. So those 6 eye centers would be defined like this: 1, 2. Actually I should write I1, 2, but I will be writing normally 1, 2. This is my representation. 1, 2, 1, 3, 1, 4. Then we will not be having 2, 1 because 1, 2 and 2, 1 are same. We will not be having 3, 1. 1, 3 and 3, 1 are same. We would be having 2, 3. Then we will be having 3, 4. So these are the 6 eye center which are defined. Because 1, 2 or 2, 1 are same. 2, 3 or 3, 2 are same. 1, 4 or 4, 1 are same. 4, 2 or 2, 4 are same. That's why these are the 6 eye centers which are defined. Now my dear, if you want to apply the eye center approach, you need to find out all the eye center. That is the first problem with this method. And finding out all the eye center is not an easy task, it is a hectic task. So my dear, if you have 6 eye centers, you cannot find all the eye center if you don't know any of the eye center. So that is why always remember that we are always having some known eye centers. We are always having some known eye centers, and with the help of them we can find out the unknown eye centers. With the help of that we can find out the unknown eye centers. So I would like to say, if the number of links are 4, then minimum 4 eye centers would be known to us. Like here, if I am writing 6 eye centers, I am telling you these 4 eye centers you would always be knowing. Rest 2 we will be calculating. I am saying minimum that much number of eye center will be known to us, that is equals to the number of links. Is it clear for everyone? Is it clear for everyone? And rest eye center we can know. So definitely, as we are going to find out the unknown eye centers with the help of known eye centers. So let us see what are the various known eye centers we have. Let us see what are the various known eye centers we have. So my dear, first of all we are going for the known eye centers. So the very first eye center which we are knowing is there with the turning pair. So when we are talking about the turning pair, my dear, then this point is considered as the eye center, because about this only these links are in rotation. So if this is link 1, this is link 2, then this pin joint is I12. Similarly, whenever we are talking about the rolling pair, in the rolling pair I already told you that the motion of rolling is coming because of translation and rotation, and the velocity of translation and rotation is same. So to define eye center we need to sit perpendicular. So for that, let us take, if you are talking about this point, translation velocity will be this, rotation velocity will be this, then the resultant will be this. Sitting perpendicular to the resultant will pass from here. Translation is this, rotation is this, resultant is this, sit perpendicular will pass from here. For this point, this is translation, this is rotation, this is resultant, sit perpendicular passing from here. So this point of contact in the rolling pair will be acting like eye center I12. So for turning pair at the point of pin joint, for rolling pair, the point of contact are acting like the eye centers. Moving to the sliding pair, my dear. So if we are talking about the sliding pair, let us say you are having a surface like this, and this is the block. If you are going to talk about any of the point, this point have velocity in this direction, in this direction. Why? Because in translation the magnitude and direction of velocity always remains the same. So if you will sit the perpendicular to this, if you will sit perpendicular to this, these are going to be two parallel lines. And when the lines are going to be parallel, my dear, they are never intersecting. The things which never happen, we say they will be happening at infinity. So we would be saying if this is link 1, this is link 2, I12 will be at infinity. Okay, I12 will be at infinity. Then my dear, we are going to have convex and concave surface. So if we are having this type of surface, the slider velocity will be here in this way, here in this way. If you are going to sit perpendicular to them, they will be touching at the center of curvature. So center of curvature will be acting as I12. Here also if you will see, velocity direction is here like this, here like this. Sitting perpendicular will take you at the center of curvature. This will be acting like I12. So here also if you will say this is a straight line, this straight line can be considered as a circle whose radius is infinity. So if this is the circle surface and its radius is infinity, then center will be where? Center will be at infinity. So you can say for sliding pair, eye center is at center of curvature. Eye center is at center of curvature. Eye center is at center of curvature. Is it clear for everyone? Guys, just give me a minute. Just give me a minute, I am coming back. Please tell me, is it clear for everyone? Okay. Yes guys, sorry for the disturbance. Is it clear now? Is it clear now? Very good. So guys, we have seen the known eye centers. These were the known eye centers. Now my dear, we will see how the eye center approach is working. Okay. For that, a theorem was given. That theorem is said to be Kennedy's theorem. What Kennedy's theorem says? Kennedy's theorem says if you are having three links M, N, P, from these three links you can have three eye centers. One eye center is IMN, other is INP, other is IMP. And they are saying all these three eye centers will lie on a straight line. All these eye centers will lie on a straight line. If they will lie on straight line, then only you will get the relative motion between these three links. Otherwise, you will not be getting the relative motion between these three links to be a constrained motion. Okay. So if you want relative motion between three links, then their three eye centers should lie on a straight line. Always. That is the Kennedy theorem. And he have given a contra example also, like if you see the 3-bar chain. Here you can see this is I12, this is I23, this is I13. All three are not at straight line. So you know there is no relative motion happening. So relative motion is possible only if all the three eye center made up by these three links will be in a straight line. That is the Kennedy theorem, and we are going to use it now one by one in simple 4-bar mechanism, single slider and double slider. Okay, and with this will complete the Kennedy theorem part. Then we will go to theorem of angular velocity. Now my dear, we will continue till flywheel. After flywheel we will have the tea break. Okay, try to complete it by 5:30. Okay, let us move further. Let us move further guys. So we have seen the Kennedy theorem. Now we are going to apply simple 4-bar mechanism, eye center approach on simple 4-bar mechanism. Just try to understand it. OABC is the simple 4-bar mechanism. Just try to understand the complete approach. We will see 1, 1, 2, 2 questions also. So my dear, this is link number 1, link number 2, link number 3, link number 4. 4 links. First of all, what will be the first step? You will say the number of links are 4. So how much will be the number of eye centers? 6. Second step will be, you will be writing all the eye centers like 1, 2, 1, 3, 1, 4. 2, 3, 2, 4 and 3, 4. Is it clear? So when you are writing all these eye centers, now we will be looking at the known eye centers. So you can see this is link 1, this is link 2, this is I12, known eye centers. This will be I23. This will be I34. This will be I14. So as I said, these 4 eye centers are known to you. Now to find out the unknown eye center, they have given a trick. They said you make a circle, and in this circle make a polygon which is having the side equal to the number of links. 4 links, 4 side quadrilateral. Give them the numbering 1, 2, 3, 4. When we are going to have the numbering 1, 2, 3, 4, my dear, now you can see 1, 2 is known, 2, 3 is known, 3, 4 is known, 1, 4 is known. All these are joined with the solid lines. We have 2 unknown eye center. We will be starting with the very first row. In very first row, 1, 3 is unknown. So that we will be joining with the dotted line like this. And if you want to reach from 1 to 3, as 1, 3 is unknown, then you would be going from this path 1, 2, 2, 3. 1, 2, 2, 3. Then if you want to go from the other path is 1, 4, 4, 3. 1, 4, 4, 3. Now whatever I have done, this is nothing but the Kennedy theorem. Look at it how it is Kennedy theorem. Because my dear, what I want to say here is I said if I want to go from 1 to 3, the path is 1 2 2 3. If I want to go from 1 to 3, the path is 1 4 4 3. So this is in the normal way we are saying. But how it is Kennedy theorem? Because Kennedy theorem said if we have 3 links 1 2 3, it would be having 3 eye center 1 2 2 3 1 3. He said all these 3 will be on the same line. So that's what I want to say. I13 will be available on the line joining 1 2 and 2 3. It means all these 3 would be in a straight line. Similarly, if I am having 1 3 and 4, there will be 3 eye center 1 3 3 4 1 4, and all 3 should be in a straight line as per the Kennedy. And here also I am saying the same, that 1 3 will be found on the line joining these two. It means all these 3 would be found on the same line. So this is the Kennedy theorem I am using. But how I am using is, look at it. I am saying 1 3 is available on line joining 1 2 2 3. Line joining 1 2 2 3 is this. Line joining 1 4 4 3 is this. So I am saying I13 is lying on line joining this and line joining this. So it would be lying on the intersection of both. This will be I13. Clear for everyone? We found out I13. Now my dear, similarly we will be going for the second eye center. Similarly I will be going for the second eye center. For second eye center, second is 2 4. So if I want to go for 2 4, once again you have two paths. One is 2 1 1 4. Other is 2 3 3 4. So once again I am going to do the same thing. 2 1 and 1 2 are same. Extend the line of 2 1 and 1 4. Extend the line of 2 3 and 3 4. And this will give you I24. Everybody please tell me you got it or not. We got both the eye centers. So my dear, we found out the unknown eye centers with the help of the known eye centers. Is it clear? So we found out the unknown eye center with the help of the known eye center. Now my dear, I told you for input link omega will be given to you as a birthright. So if you are going to find out velocity of A, you can directly write it is going to be OA into omega 2, and that will be known to you. Let us say we got it. But at the same time we know A point is lying on the link AB, and we have just seen according to the eye center approach that we can also write VAI with respect to I, AI into omega AB. But the point is AB omega we don't know, but already VA we know. But whatever VA is coming, that is coming with respect to fixed link. So my dear, when we are talking about AB, AB is link number 3. I can also write it AI into omega 3. Obviously, when I am looking it in front of link number 3, I am thinking it as a link number 3. So my dear, obviously I center should also be associated with link number 3. But I center associated with link number 3 are many. 1 3 2 3 and 3 4. But I want to find out the absolute velocity, because I center approach and relative velocity approach. Relative velocity approach, as the name suggests, is famous for relative velocity. So by default I center approach is famous for absolute velocity. So if you are looking for absolute velocity, you should go with the fixed link I center. One link is fixed link, so 1 3 would be chosen. So we would be writing here, it can be written as AI13 into omega 3. So if question will come from this topic, they will be giving you this distance. And if you know this distance, then my dear, this distance is known to you, velocity of A is known to you, you can very easily find out omega 3. Why we want to find out omega 3? Because once we know omega 3, B is also on that same link. So we can write V of BI13 is equals to BI13 into omega 3. This will give me VBI3, and this is going to be the absolute velocity of B, and I can also write velocity of BC as BC into omega 4. So velocity of BC and velocity of BI13 will be same. Okay, so if you know this, you can find out omega 4, and omega 4 will be known. So every unknown we have found out with the help of eye centers. That's why we call this approach as eye center approach. Please tell me guys, everybody understood this approach or not? Please tell me guys, everybody understood this approach or not? Then we will be moving further. Okay guys. Parinder, Shreyas, Vinay, Darshan, very good. So guys, this was the eye center approach for simple 4-bar mechanisms. Okay. So we have seen all the eye centers. Kennedy theorem also we have discussed. Okay. Now we are going to see the same approach for single slider and double slider. Okay. We will see the single slider and double slider. This is the cylinder and piston arrangement. Connecting rod, crank and crankshaft. Here also if you will see 1, 2, 3, 4. You know the procedure? First link was 4. Second number of eye center is 6. What are those? 1, 2, 1, 3, 1, 4. 2, 3, 2, 4, 3, 4. There are 6 eye centers. Out of these 6 eye center, I would like to say 1, 2, 2, 3, 3, 4, 1, 4 are the known eye centers. And if these 4 are the known eye center, we will see where they are. First of all, this is link number 1, this is link number 2, so turning pair is there. So this is going to be I12. This is going to be I23. This is going to be I34. I14 will be at infinity. I14 at infinity. Okay, why? Because of sliding pair. Now my dear, next step is I will be making a circle, quadrilateral, because number of links are 4. 1, 2, 3, 4. I will be going for the very first unknown. The very first unknown is 1, 3. So very first unknown is 1, 3. If I will be going for 1, 3, 1, 3, 1, 3, you know for 1, 3 what is the way to go? It will be lying on line joining 1, 2, 2, 3. It will be lying on line joining 1, 4, 3, 4. So 1, 2, 2, 3. 1, 2, 2, 3, 1, 2, 2, 3, 1, 2, 2, 3. 1, 2 is this. 2, 3 is this. Line joining 1, 2 and 2, 3 is this. Line joining 1, 2 and 2, 3 is this. Then 1, 4, 3, 4. Line joining 3, 4 and 1, 4 is this. So you are saying I center 1, 3 will be lying on line joining these two and line joining these two. So intersection of these two lines will give you the I13. So this is going to be the I13. Clear for everyone? Then my dear, the second unknown is 2, 4. For 2, 4 the path is this. If you want to go for 2, 4, then you will say 2, 3, 3, 4. 2, 1, 1, 4. 2, 3, 3, 4. Line joining 2, 3 and 3, 4 will be this. And then we have line joining 2, 1 and 1, 4. Here 2, 1 is here, 1, 4 is at infinity. But we know two parallel lines meets at infinity. So my dear, if I am saying that I14 is lying on this line, then I14 will also lie on this line. Because these two parallel lines will meet at infinity and I14 will be there on both the lines. So that is why this will be the line joining I14 and I21. So first you were saying that I24 will lying here. Then you are saying I24 is lying here. So obviously intersection will be having I24. This point will give you the I24. So only eye center part is different for every mechanism. Rest will remain the same. You would be given the angular velocity omega 2. With the help of omega 2, if this is O, this is A, this is B, you can find out velocity of A, O, OA into omega 2. Then with the help of that you can write velocity of AI13 is equals to AI13 into omega 3. So this will give you the value of omega 3. Then my dear, you will be saying velocity of slider is nothing but velocity of B I13, which is nothing but BI13 into omega 3 Is it clear? The same calculation as it is. Clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Everybody understood? Okay guys, this was single slider crank mechanism. Now we are moving to the double slider crank mechanism. I feel today we will be completing velocity analysis in record time. Okay, because in classes eye center takes 3 hours, relative velocity takes 3 hours, acceleration takes 4 hours. That we are going to complete all the 3 in 2 hours or maybe 2.5 at the max with the questions. Okay, so my dear, now we are going to have the double slider crank mechanism. Double slider crank mechanism. Abhishek, these whatever we are going on, they are questions only. Okay, because what they are asking in the question, whatever I am doing, this is GATE 2007 question actually. So they are GATE questions only. They are asking where I13 will lie, where I24 will lie. So these type of questions, they are questions, they are not concept actually. Question will be coming on angular velocity theorem, which is the next topic. Okay, so from here they are just asking you where is the eye center. So that is what I am doing in front of you. This is a GATE question, this is a GATE question. This is whatever we have done, this is asked in engineering services and ISRO. So whatever I am doing, they are questions only. Okay, because approach I should teach you once. Why I am repeating is 3 times? Because these are questions. Now tell me, this is link number 1, link number 2, link number 3, link number 4, and I have added questions in these slides for every chapter. Don't worry, questions separately will also come. There I will not do all this. I will ask you and you will be answering directly. Tell me how many links? 4. How many eye center? 6. Write all the eye center 1, 2, 1, 3, 1, 4. So whatever I am doing, this is not theory actually, dear. This subject is not at all theoretical. Whatever I am doing, they are questions only. So they are 6 eye centers, and you know we need to go for the 4 known eye center first of all. So can you tell me where will be I12? 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 Vertical क्या होता है? Infinity में बोलो ना. I12 will be lying at infinity. I23 is this one. I34 is this one. And I14 is this one at infinity. So I14 at infinity on this line, I12 at infinity on this line. So once again I can say I know the 4 eye centers. Make circle quadrilateral 1, 2, 3, 4. Now my dear, you know 1, 2 is known, 2, 3 is known, 3, 4 is known, 1, 4 is known. Then my dear, we would be talking about the first unknown, 1, 3. If you want to go for 1, 3, you will be going for 1, 2, 2, 3, 1, 4, 4, 3. So when we are talking about this is 1, 2 at infinity on this line, 2, 3 is this. So this is the line joining 1, 2 and 2, 3. So eye center is lying on this. Then 1, 4 and 4, 3. You know this is 3, 4. 1, 4 is on this line. So this is the line joining 1, 4 and 3, 4. So you are saying eye center 1, 3 will be on this, eye center 1, 3 will be on this. So this intersection will give you eye center 1, 3. 1, 3 is not a problem at all. Here the problem is there with the 2, 4. 2, 4 is also unknown. So when we are talking about 2, 4, then 2, 4 will be 2, 3, 3, 4, 2, 3, 3, 4 and 2, 1, 1, 4. It is very interesting. This was asked in GATE 2007. So when we are talking about this, everybody knows that the line joining 2, 3 and 3, 4 is nothing but, line joining 2, 3 and 3, 4 is nothing but this is 2, 3, this is 3, 4. This is the line. But you know where is 2, 1 and 1, 4? 2, 1 is at infinity, 1, 4 is at infinity. So if two eye centers are at infinity, where will be the line joining those two eye centers? If 2, 1 is at infinity, if Vadodara is in Gujarat, Ahmedabad is in Gujarat, road joining them will also be in Gujarat. If Agra is in UP, Mathura is in UP, the road joining them will also be in UP. And you want this road to join that road. So this road has to go Gujarat to join that road. So my dear, if you are saying all these eyes, both these eye centers are at infinity, so line joining these two will be also at infinity. So this line has to go to infinity, and where it will join at infinity, there only the eye center 2, 4 will be there. So you will say I2, 4 will be at infinity. Is it clear for everyone? Please tell me that. Here many students have confusion. Is it clear for everyone? Clear for everyone? Now my dear, have you noticed I have done in front of you, three analysis. And in all the three analysis, you can notice one point, that we always started with link number 2, then reached to link number 3, then reached to link number 4. So it's fine for 4 link problem. But let us say if I would be having 6 link, first link is fixed, input is the second. So I want the velocity of 6. First I will be going from 2 to 3, 3 to 4, 4 to 5, 5 to 6. It was a very hectic task. So eye center approach was having 3 problems. One is finding out eye center was a hectic task for a big mechanism. Second was whatever we are calculating only for one instant. And for that instant only we can talk, because eye center will be changing throughout. Third was we cannot skip any link. We cannot directly find out the angular velocity of 6 if angular velocity of 2 is known. So for the solution of this, a wonderful theorem was given, that is said to be theorem of angular velocity. In the paid course I derive also this, but here we cannot go for derivation, it will be time taking thing. So we will directly write the theorem of angular velocity as omega m I I1m is equals to omega n Imn I1n. So when you are going for eye center approach, for sure you would be calculating all the eye centers first. Once you have already found out all the eye centers, then you would be knowing the distance between two eye centers. I am going to take a practical case. Let us say we have a 6 link mechanism. Second link is the input. First is the fix. 6th is the output. And let us say input link omega is given to us and they are asking you the 6th link omega. Those who have studied in the paid course, they would be remembering, near to this I was telling you a complete story of Sir Arnold Kennedy. But this is marathon, so just hold on your emotions. Okay, and don't say, sir, please repeat the story. So we will go with the expressions here only. So when we are talking about this omega m, omega n, you are going to say this is the input, this is the output. So you would be writing m as 2, n as 6. So we are going to say omega 2, I26, I12, omega 6, I26, I16. Now my dear, if it is eye center approach, finding out eye center is the basic step, we cannot skip it. You have to find out the eye centers. There is no bar over that. But yes, we can skip the calculation of omega 3, omega 4, omega 5 with this. How we can do that? This will be known to us because it is your birthright, Janam Siddha Adhikar. This will be the distance between two eye centers, which will be known to us after finding out the eye centers. This is the distance between two eye centers will be known to us. So if out of 4 things, 3 things are known to us, cannot you find out omega 6? So my dear, we will be able to find out omega 6 from here without going for omega 3, omega 4, omega 5. So what do you mean by that? From omega 2 we calculated omega 6 without calculating 3, 5. So 3, 4, 5, obviously it is going to be advantageous for us. But my dear, here we get only magnitude. You may be saying, sir, what about direction? So for direction also something was said. You already know if we take three links 1, m and n. By Kennedy's theorem, there would be three eye center 1m, 1n and mn. So let us say if all these three eye center when we are having, if you want the relative motion between the three links, then all these three eye centers should be in a straight line. So these three eye centers can be in a straight line like this. We have 1m here, mn here, 1n here. We can also have mn here, 1m here, 1n here. Try to understand this. If you would be sitting at mn always, you can see 1m is on this side, 1n is on this side. Both 1m and 1n are on the same side. So for such condition, when 1m and 1n are on same side, then my dear, I would like to say omega m and omega n, they will be in same sense. Same sense. Means if this is clockwise, this will also be clockwise. If this is anti-clockwise, this will also be anti-clockwise. And my dear, if you are sitting at IMN and you find out that 1m is on this side, 1n is on that side, means both are on the opposite side. It can be 1n here, 1m here also. So if I am saying 1m and 1n are on opposite of mn, then I would like to say omega m and omega n will also be opposite. For clockwise it will be anti-clockwise, for anti-clockwise it will be clockwise. Anybody have any doubt, please ask. Anybody have any doubt, please ask. Do like and share the session, guys. 5 hours are already completed in this session. We are going in a wonderful way. Clear for everyone? Okay, guys. Wonderful. So this was the approach. Now we are having the questions, guys. Shreyas, I am saying that you just need to see those three eye center. What are three eye center? Like in this case we have 1, 2, 1, 6 and 2, 6. For relative motion between 1, 2 and 6, all these three eye center will be on straight line. 1, 2, 1, 6 and 2, 6. You need to sit over 2, 6 mn and you need to see where are 1m and 1n. If 1m and 1n are on the same side, then omega m and omega n will be in same sense of rotation. Okay, and if 1m and 1n are on the opposite side, means if here is 2, 6, here is 1, 6 and here is 1, 2, then they are on opposite side. Opposite side means if omega m is clockwise, omega n will be anti-clockwise. Please tell me, is it clear for everyone now or not? Then we will move further. Clear for everyone or not? Please tell me that. And don't worry, with the question also you will be having better idea. Now we are entering into the question because eye center approach chapter is over here. Okay, so we started around at 2:50. है ना? At 2:50 we started and you can see less than 1 hour we completed the chapter. I already told you the time required is there only in the simple mechanism. Eye center is over. Now we will see only 3-4 questions here. Relative velocity is smaller than that. That will be completing maybe in 30-35 minutes. Acceleration will also be over in 30-35 minutes. Okay. So flywheel will be over in next 30-35 minutes or 1 hour. So by 5:30, maybe 5:30 we would be having the second break when flywheel would be over. After that we will be left with cam, governor, gyroscope, gear balancing. Okay, so there the major time would be required only for gear. Gear is the big chapter. Okay, let us move further. Let us move further. First of all, this is the very first type of question which is coming in GATE, and this type of question have been repeated many times. Sandy, vibrations are not today, na? Vibration is a separate topic. Vibration today will not be covered. Vibration would be separately covered. Okay, we would be having a separate marathon of 3.5 hours for vibrations. Vibration is a big topic, and that is a separate subject as per your GATE syllabus. Okay, so don't worry, we will cover that also. So this is a rod of length 1 meter is sliding in a corner as shown in the figure at an instant when the rod makes an angle 60 degrees with the horizontal plane. The velocity of point A on the rod is 1 meter per second. The angular velocity of the rod. They are giving velocity of A as 1 meter per second. You know, when A will be coming down, B will be going in this direction. You know, if velocity of A is given, you can sit perpendicular to that. Velocity of B is known, you can sit perpendicular to that. So this point will become the I center, and this angle is 90, you know that. So my dear, if this is 60, this will be 30, you know that. You know, velocity of A with respect to I can be written as AI into omega AB. Velocity of AI is given as 1 meter per second. Distance AI you can calculate from this triangle. Okay, you can apply the sine theta. Okay, you can apply the sine theta to find out AI, and you will be able to find out omega AB. Tell me the answer, guys. You can use the sine theta. Sine theta is, if this is theta, perpendicular upon hypotenuse, AI by AB, you will get the value of AI. Tell me the answer, guys. Very good, Vinay. So when you will find out AI, you know this angle is 30, sine 30 is 1 by 2. So AI will be coming out to be 1 or 1 by 2. 1 by 2. So you would be putting the value, it will be coming out to be 2 radians per second. Clear for everyone? Vinay, Shreyas, Faninder, tell me. Harikesh, tell me. Shreyas, fine. Sandy, tell me. Shivram, tell me. Abhi, tell me. Clear for everyone or not? Very good, guys. Very good, guys. बहुत बढ़िया. Next question is this. This is the question from Theorem of Angular Velocity. Okay. These are the two types of question which are coming from this chapter. Third type is finding out I centers. The input link O2P of a 4-bar mechanism, O2P of a 4-bar mechanism is rotated at 2 radian per second in counterclockwise direction given. The angular velocity of the coupler PQ when the angle O2, O4, OP is 180 degree. First of all, I will be making that configuration what they are talking about. This is O2, O4. They are saying when this will be P. Okay, O2, O4, P. This angle is 180 degree. And this is Q. This is the condition given, guys. And this O2, O4 is the fixed link. And my dear, you know it is rotating like this. First of all, they are asking you the omega PQ. If this is 1, this is 2, this is 3, this is 4. You can say omega 2 is given. Omega 3 is asked. So we need to consider 3 link, 1 to 3. It is 3 I centers would be there. है ना. So 1 2 3 we are having omega 2 I12 I23, omega 3 I13 I23. That is what the theorem of angular velocity is. Omega m I1m Imn, omega n I1n Imn. So for that I require I center 1 2 2 3 and 1 3. 3 I centers are required, and I feel some of them are known to us. This I center is I12. This I center is I14. This I center is I23. This I center is I34. So only I13 is not known to me. I13 is not known to me, but I know what I will be doing for this. I will make a circle 1 2 3 4. I want to find out 1 3. You know, to get 1 3, it should be on the line joining 1 2 and 2 3. It should be on the line joining 1 4 or 4 3. So 1 2 2 3. 1 2 2 3 line joining is this much. 1 2 2 3 line joining is this one. 1 4 4 3 line joining is this one. So at I14 only I will get I13. Yes, as all the I centers are moving, there would be an instant when two I centers will coincide. It is possible. It is possible that two I centers are getting coincide with each other. If that is the case, 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 that is the case, my dear, you can write here omega 2, which is given as 2 radians per second. I1m Imn, I12 I23, I12 I23 is this O2p. It is given that actually, okay, this is PQ, O2p and O4 O2 is A. So we are given that this distance is A is equals to omega n, omega 3 we need to find out. I13 I23. This is I13, this is I23. So O2 O4, O2 O4 and O2p. This is 2A. From here omega 3 will be coming out to be 1 radian per second. Everybody understood this or not? Please tell me that. Everybody understood this or not? Please tell me that. बोलो भाई. फनेंद्र, अजय, विनय, अभी, शिवराम, श्रेयस, आश्रय. Yes, Harsha, are you there or not? Fine, fine, fine. Very good, Darshan. बहुत बढ़िया. So everybody is getting it. Please tell me. Okay, guys. Very good, guys. So moving further. We are entering into the next chapter, relative velocity approach. Okay. So guys, we are entering into the next chapter, that is relative velocity approach. So my dear, in the relative velocity approach, in the gate you will be getting only simple 4-bar mechanisms, but in engineering services conventional, even 6-bar mechanisms can be asked. So right now whatever the discussion we would be going for as per the gate we are going, so we will go only for 4-bar mechanisms. And here I will teach you 3 things. One is the velocity diagram. Second, I will be teaching you is the special case of simple 4-bar mechanism. Third, I will teach you the special case of crank and slotted lever mechanism. And out of these three, only the questions are coming from this chapter. So first of all, what is the concept of this chapter? That is relative velocity approach is, the concept is relative. That we always are able to see the things relative to us. Like if one of your friend is moving with a velocity of 20 meter per second and you are moving with a velocity of 10 meter per second. So this is A, this is B. If I ask you velocity of A relative to B, means if I want to find out what velocity of A you can see, for that what we will do, your velocity we will make it opposite. Your velocity we will make it opposite and we will give it to A. So when we will be giving 10 meter per second opposite, originally you have 20. So A will be looking, when B will be looking at A, he would be saying the velocity is 10 meter per second. This is said to be the concept of relative velocity. Okay, I will tell you in much better way. Everybody have seen the movie Three Idiots. In the Three Idiots, just try to remember the scene when results come. And when Raju and Farhan checking the results, they are not getting the name of Ranchhod Das Chanchad in the list. Because they were checking in the last part of the list. Because they were saying when we are at the last list, he will also be. And what they found, they are last two and Ranchhod Das Chanchad name is not there. So they feel their friend is getting failed. They are very, very upset from that. Then they see a character, Chatur Ramalingam, was weeping, crying. Then he asked why he is crying. Then nearby persons, Raju, came to know and he said, because he got second. Then Farhan asked, who is first then? He says, Ranchhod Das Chanchad. Then they are getting more depressed. They were not happy when they get to know their friend is failed, but they get more sad and depressed when they get to know their friends had got the top position. Because they know when they will be going to home, their parents will be saying, your friend got first, you got last. Learn from him. So we are able to see what is not with us. Let us say you got 60 marks in GATE, your friend got 61. You would not be having any problem until he gets 60. But that 61st marks is going to create all the problem. Okay. So like I would like to tell you, when I was preparing for GATE, we were also having a group of friends, and we two friends were like, we were good ones, so we wanted we would go to the same IIT or same NIT for the MTech. And when our marks were differentiated by 0.5, I got 0.5 extra, colleges became different. Okay, so that is a different idea. But otherwise, whenever we are having the problem up to 12th class, when our parents are having comparison of our friends with us, then it is always going to be a problematic thing. Now, so that is why we are always able to see whatever we don't have. So Sir Arnold Kennedy have used this wonderful concept, and he said, we are going to talk about this link. Now, this link was a problem, coupler. He wanted to make the general motion at pure rotation. So what he said, take the coupler. What he said, take the coupler. Let us say this is the coupler AB. He said, this AB is having the general motion. Okay, let us say that general motion AB is having, which is the combination of pure rotation and pure translation. This is pure translation, this is pure rotation. Let us say this link is in general motion, whose pure translation component is 2 meter per second. You know, for pure translation, every point is having the same velocity. So every point is having the same velocity, 2 meter per second. And in rotation, every point is having same omega, but velocities are omega. So here velocity will vary linearly like this. This may be 5, this may be 4, this may be 3, this may be 2, this may be 1, this may be 0. So when you will add this, general motion will come. So here velocity is 2, here velocity is 7. This is the velocity profile. So my dear, what Sir Arnold Kennedy was saying, कि you need to sit at A. When you will be sitting at A, the velocity of A you will also be having. And when you are already having this velocity, now if you will see velocity of B with respect to A, it would be coming out to be what? This 2, this is 7. So you will be able to see what? 5 only, na? You will be able to see 5 only, which is nothing but the velocity of rotation. So which is nothing but the r omega. Yes or no? Why? Because of the concept of relativity. So my dear, whenever we are going to sit at A and we are going to see the velocity at B, we will be able to see what we not have, and we not have rotation. Because translation we also are having. So according to us, this motion will become pure rotation. It is not, but it will look like. So that is why he have given a wonderful equation from here. He said कि if you are having a link AB, if you are having a link AB, this is A, this is B. You are looking it as pure rotation. He said velocity of B with respect to A is given as r omega, that is correct. And it is nothing but perpendicular to AB in sense of omega. If omega is like this, it would be having like this. This was the statement given. And if you can understand this statement, this chapter is nothing. Very easy. I will be starting with the simple 4-bar mechanism, and then we will go to directly the special cases and then questions, and by 4:30 we have a target to complete this. We will very easily do, and I am telling you whatever I am teaching you here, that would be enough for GATE. GATE would be asking from here only. Okay, so let us move further. So do like and share the session, guys. Do like and share the session. We are moving further then. Fine. So first of all, okay, here we will see. We are going to have a simple 4-bar mechanism. Okay. So when we are going to have this simple 4-bar mechanism OABC, then my dear, you know that key omega of OA will be given to you as a birthright. Link number 1, link number 2, link number 3 and link number 4. Okay. So it would always be given to you. So you can very easily find out velocity of A with respect to O as OA into omega 2. OA into omega 2. And you would be calculating, let us say it is coming out to be 5 meter per second. Now my dear, how we are going to deal with this relative velocity approach? First of all, we will see the fixed point. And if you are able to see, point number O and point number C are the fixed point. So my dear, first of all, we will be plotting the fixed point O comma C. O comma C. So my dear, if you are already aware of omega 2, first of all, we will be finding out velocity of A with respect to O. So when you will be finding out, you have already found out 5 meter per second. Let us consider 1 meter per second as 1 centimeter. So 5 meter per second we will be plotting as 5 centimeter. So we would be plotting a line of 5 centimeter. We already know direction will be perpendicular to the link. So direction is known to us, magnitude is known to us. We are showing this configuration diagram with the capital letter, velocity diagram with the small letter. Is it clear for everyone? Okay guys, now we are going to talk about the next point. Whenever we get the next point as A, now you will be sitting at A, you will be looking at B. So when you are sitting at A, you are looking at B, my dear. This time velocity of B with respect to A is going to be perpendicular to AB for sure. That is correct. Okay, so velocity of B with respect to A is going to be perpendicular to AB, that is for sure. But my dear, we don't know the exact magnitude for that. And direction also, it can be upward also, it can be downward also. So we will go with both the possibility. It can be upward also, it can be downward also. We did not get any new point. So that is why now we will be sitting at C. And when we will be sitting at C and watching at B, then velocity of B with respect to C will be perpendicular to this. We don't know the magnitude, we don't know the direction, but we know the possibility of direction. So we will be going for both the possibilities. So you were saying this line will give you velocity of B with respect to A. And this line will give you velocity of B with respect to C. So the intersection point will be B. And if you are going to join this, it is velocity of B with respect to C. And if you are going to join velocity of B with respect to A, it can also be written as AB into omega AB. So AB's link length, we can find out omega AB. It can also be written as BC into omega BC. BC is known to us, omega BC we can find out. Nahi Harikesh, that's why I want to say GATE will not be asking from this. Their scale pencil are not required, so that's why question will not be coming from this. Then why you are teaching, sir? Why you are wasting our time? Because my dear, from where the question is coming, there this concept is required. Now you know the concept. I will not go for the same thing in single slider and double slider. Why? Because this diagram is useless for GATE. So now I am coming on to from where the GATE will be asking. Are we ready? I am coming on to two special cases from where GATE will be asking the question. Are you ready for the same? Are you ready for the same? Shri Krishna, Harikesh, Harsha, Vinay, Darshan, Abhi, Sandy. Very good. Shivaram, Parinder, Ajay. Okay guys. So now we are coming on to that special case. First special case is if input and output parallel to each other. If input and output links are parallel to each other, what is that condition? O, A, B, C. Once again you will go for the fixed point O, comma C. Now you will be sitting at O. This is 1, 2, 3, 4. Omega 2 is known to us. So we can very easily find out velocity of A with respect to O is OA into omega 2. Okay, so you know the direction of velocity will be perpendicular to the link length. So we know the direction, we know the magnitude, because birthright will be given to us. And you would be having this velocity and this point you will be getting as A. Whatever the new point we got, now we will be sitting at A, we will look at B. When you will look at B, we don't know omega AB, so velocity of B will be perpendicular to AB, that is known to us. Velocity of B with respect to A will be perpendicular to AB, only that is known to us. So we will be going for both the possibilities. One possibility may be upward, other possibility may be downward. We didn't get a new point, so we will see on sit. We will sit on C. When you will sit on C, the velocity of B with respect to C will be perpendicular to BC. So that possibility we are going to make it with the yellow color, either this way or that way. You were saying that B with respect to A on this line, then B with respect to C on this line. So B will be at the intersection, so A and B will coincide. So we can write velocity of A with respect to O is equals to velocity of B with respect to C. It can be written as OA into omega 2 is equals to BC into omega 4. This will be helpful thing for the questions. They can also ask you velocity of AB, which should be equals to AB. And you know AB is 0. Because velocity of A with respect to O minus velocity of B with respect to C, it is 0 because both are equal. And if someone will ask you omega AB, you can write VAB by AB. So VAB is 0, omega AB is 0. So my dear, if I ask you what was the name of link AB? What was the name of link AB? Can you tell me that? Can you tell me the name of link AB? Can you tell me the name of link AB? It is coupler. Very good. Name of link AB is coupler. And my dear, coupler was having which type of motion? Coupler was having which type of motion? It was having general motion. Coupler was having a general motion. General motion include both translation and rotation. But you have just said that omega is 0. So can I say for this particular case this general motion will reduce to pure translation? Because if you see link AB, you are getting the velocity of A and velocity of B to be same. So all the points will be having the same velocity, which is possible only for pure translation. So this is the condition when your coupler will be in pure translation. Only for this particular instant, my dear. Is it clear? Questions will be coming from this. And this is the question I am showing you. In this question, you need to tell me the omega of B, omega of O to B. I am asking you the second part of the question. First part they are asking whether it is crank, rocker, crank, whatever. But I am asking you what would be omega to B for this case. You can see this angle 90, this angle 90. It means both these links are parallel to each other. Just tell me omega O to B. I am giving you hint. Velocity of A O2 will be equals to velocity of B of BO. This is O4. BO4. So you can write O2A into omega O4B into omega 4. Find out. Okay. O2A is 60. Omega given is 8. This is 160. You need to find out omega 4. So 8, 20. Omega 4 will be 3 radian per second. Everybody got 3. Faninder, very good. Ajay, very good. Sandy, very good. Harsha, very good. Shreyas, very good. Everybody is clear, guys? Please tell me that. So Monday, Tuesday, Wednesday, be ready for the practice sessions of TOM, MD and production part 1. Because next 3 days I am not having any marathon of yours. So that is why I would be coming for practice sessions in the night. Because marathons would be smaller. And yes, this is a crank rocker mechanism if you will be finding out. Because this is 240. This is 60, this is 160. when you will find out this will be coming out to be 260. Law will be satisfied, shortest link is input, so it would be crank rocker mechanism. Very good Ajay, बहुत बढ़िया. Today no practice session, why? Because 9 to 11 I have a paid class, और यार सुबह से रात तक पढ़ा रहा हूँ, थोड़ा सा रेस्ट करने दो, ठीक है? So we would be having practice session on Monday, Tuesday, Wednesday, 3 days. Production, Tom, MD. Okay? Because on those 3 days your marathon will be smaller. So when your marathon would be smaller, so we can, because 9 to 11 today I have paid class also. So it will not be possible to take. Yes. Solve this question. हाँ, कल आप लोगों ने कहा था कि चंद्रा सर लेंगे, तो इसलिए मैंने नहीं रखा. मैं तो ले लेता कल, आप लोगों ने कहा था सर चंद्रा सर ने रखा हुआ है, तो इसलिए मैंने नहीं रखा. Practice session time Save you will be getting on my Telegram channel. Most probably it would be at 11:30 p.m. 11:30 p.m. because 6:30 to 11 I have classes. After that only we can have. तो मुझे नहीं पता था ना आश्रय, बता देते तो I could arrange. No issues, we will plan. Don't worry यार, सभी प्रैक्टिस सेशन होंगे और 20 से 30 में भी रोज एक प्रैक्टिस सेशन है. Don't worry. Okay, here you know once again you will say velocity of A is equals to velocity of B. So what is velocity of A? 10 into 5. Answer will be 50, na? They are asking velocity of B. They are not asking angular velocity. Yes, if they would ask angular velocity of BC, then it will be 50 by 3. Clear for everyone? Very good Teja, very good Fanindra, Shreyas. Okay, where is I center I24? We have seen this question now. Yes, Darshan, very good Ashray. Where is I24? Let us say how many of you give the right answer for this. Infinity na? Infinity. In some of the books it is given n, which is wrong. It is at infinity only. What are the number of eye center in a 6-link mechanism? What are the number of eye center in a 6-link mechanism? LC2, 6C2. 15 would be the answer. This is a question once again. Solve this, then we are going to the third and last part of this chapter, that is crank and slotted lever mechanism. Solve this question, guys. Very good. Ajay is saying the answer to be 2 by 3. What about others? I want answer from everybody. And I am telling you, here we are doing the gate level questions. In the practice session, we will go for slightly better level questions. Better than gate. They are all gate type of questions. Yes, once again, velocity of B is velocity of C. AB into 1. CD into omega CD. CD is 1.5 times AB. Omega CD is 1 by 1.5. D is correct. Okay, solve this last question. Then we are moving to the last topic of this chapter. दर्शन ऐसा कुछ नहीं है. Actually, paper is not made by the organizing body only. For making of paper, there is a team made every year. In that, big IIT professors are there, some NIT professors are there. So every year it is going to be like that. It is not कि ISC अलग पेपर बनाएगी, IIT अलग बनाएगी, ऐसा कुछ नहीं होता है. ठीक है, मिथ है ये सबका. Okay. Very good, guys. So answer of this will be VBA, VCD. Whatever the questions are we are doing, don't you feel they are not ISC problem, they are previous years only. So it is not like that. Okay, so AB into 10, CD into omega CD. So we would be having omega CD as what? You know, AB is 5, CD is 2. It is 5, it is 2. 25. Very good, guys. So let us see the crank and slotted lever mechanism. Yes, guys. This is the last case, after which we will enter into acceleration analysis. Okay. So this is chapter number 3 is about to over. Relative velocity approach. So my dear, when we are talking about this crank and slotted lever mechanism, you know it is a mechanism which is used in shaper and planer. Forward stroke is slower, return is faster. But you should also understand this, कि when your slotted bar is reaching at this place and this place, then they are changing the direction of motion. So can I say if this link 1 is fixed, this link 2 is crank, link 3 is slider, link 4 is slotted bar. Can I say omega 4 at this location will be 0? Omega 4 at this location will be 0. So at these two locations, omega 4 will be 0. And you know that RAM is associated with that only. So when RAM will be moving, that will also be moving from R1 to R2. So at R1 and at R2, RAM will also be at rest. Means its velocity will become 0. So obviously, by symmetry, in between the velocity will become maximum. In between the velocity will become maximum. So when the forward stroke is happening, it is starting from 0, becoming maximum, then maximum to 0. Then return maximum, maximum to 0. Maximum 0, maximum 0. Maximum 0, maximum 0. Maximum 0, maximum 0. Like that. But forward maximum and return maximum will be different, because return stroke is faster than the forward stroke. So this can also be derived, which I derive in the paid course, but here derivation is not required. So I will give you the direct result. Omega 4 maximum during forward stroke is given as R by L plus R into omega 2. Omega 2 is constant because crank is rotating at constant speed. Similarly, omega 4 maximum in the reverse stroke, R by L minus R into omega 2. Clear for everyone? Clear for everyone? Okay, guys. So this R is crank radius, L is connecting rod length. You know that this is R, this is L, Okay, so my dear, this is one thing. And if you want to talk at any instant, like here if I am talking about, you know when I will be getting velocity maximum in forward, when this is the slider, and when the slider is here, then I will be getting the maximum velocity in the backward stroke. So if you are talking about at any particular instant, you know that when you are having a motor which is rotating with omega, so to the crank one velocity will be there, which is nothing but v is equals to r omega, and this velocity will be having two components. One component is perpendicular to slotted bar, which I will write v perpendicular. Other is v parallel to slotted bar. Perpendicular is going to help the slotted bar to rotate, and parallel component will be the velocity of slider on the slotted bar. So my dear, if you know this angle, then you can find v perpendicular is, let us say this angle is phi, it is v cos phi, and this is v sin phi. So at any instant we can find out this particular components. Clear for everyone? But generally questions are not coming from that, questions are coming from these two formulas. So with this we have completed relative velocity approach. Now we would be entering into the next chapter. Okay. Okay, this last question let us do. Before we go into acceleration, let us do this last question. This is slightly difficult, that's why we are doing. This is a 1 mark question from I center. Is it clear for everyone? So when we are talking about this, direction of velocity of p is given. We will be sitting perpendicular to this. Velocity of q, this is given. We will be sitting perpendicular to that. Okay. This is I center. You know this angle will be 70 degree. If this is 20, this will be 20. This is 45, and you know this is 90. So this is also 45. This will be, this is 70, this is total 65, this will be 45. So if you want to write down the velocity of p, you will say velocity of p is equals to pi into omega pq. Velocity of q, qi into omega pq. They are saying that find out the velocity of p if velocity of q is known to us. Just divide both of them. Vq by Vp, Qi by Pi. You don't know Qi Pi, but you know the sine rule of triangle. We can write Pi by sine 65, Qi by sine 70. From here you can get the ratio of Pi by Qi, and you can solve the answer. You need to find out velocity of q. This is a very good question for 1 mark. This type of question should be done if you are good in calculations. Otherwise, do them at the last. Tell me the answer for this, guys. Tell me the answer for this, guys. Solve it, guys, solve it. Till then I will take some water. Yes. Tell me the answer. Tell me the answer, guys. I feel answer will be coming out to be 0.96. Clear, guys? Clear for everyone? Okay, we are moving to the acceleration analysis now. We have done the velocity completely. Now we are going for the acceleration analysis, next chapter. Is it clear for everyone? So when we are talking about acceleration analysis, like I have made the velocity diagram, similarly we can make acceleration diagram. But again, those diagrams will not help you in GATE, they will help you in ESC conventional paper. Because in GATE and ESC objective, you are not going to draw with the pencil and scale and all. So here we will go as per the requirement of exam only. So I will just tell you all the three types of acceleration, and then we will move to the Coriolis component, and then we will see Klein's construction. So we are doing it completely only, okay? Only that 1% which is not required we are leaving, okay? So we are requiring, first of all, what is the acceleration? Okay, you know acceleration is defined as dv by dt. You know that velocity is a vector quantity. You know that velocity is a vector quantity, and as it is vector quantity, it is having both magnitude and direction. So if magnitude will be changing, acceleration will exist, direction will be changing, acceleration will exist. And if a body is in pure circular motion, let us say you are saying that body is rotating with a constant omega, then also it is having change in direction of velocity at every instant. That's why it is said that circular motion is always a accelerated motion. Circular motion can never be a uniform velocity, it will always be a accelerated motion. So if that is the case, my dear, I would like to tell you, if you are going to have a link like this, you know we are talking about link AB, and we have converted its general motion into the pure rotation. So we have converted the general motion into the pure rotation. We can very easily say that as here the direction always changing. So to change this direction, some component of acceleration is responsible, and that acceleration is said to be the radial acceleration. We also call it as centripetal acceleration, and it is given as omega square r. It is also written as omega square AB. R is link length. Is it clear? And this it can also be written as V square by R. This is said to be radial or centripetal acceleration, and this acceleration is always acting towards the center. This acceleration is always acting towards the center. Clear for everyone? Clear for everyone? So this is about the radial or centripetal acceleration. But my dear, now let us say we are also given that it is rotating at omega, but also some acceleration alpha is also acting. Now my dear, you also know that when there is a alpha acting, alpha is d omega by dt. So if alpha is in the sense of omega, velocity will be changing at every instant. Like previously, this body was having a velocity here as 2 meters per second. Then here maybe its velocity will be 3, here maybe 4, here maybe 5, here maybe 6. Because direction and magnitude both will vary because of alpha this time. So my dear, if I consider the same instant, I want to just see the change of magnitude. So previously it was 2, then became 3, then became 4, then became 5. Likewise it was increasing. So I can say about the second acceleration, which is acting in the sense of alpha. Like alpha is this, so this will be acting in sense of alpha. And it is given as the tangential acceleration. It is r into alpha. It is perpendicular to the link length. This was parallel to the link length. This is perpendicular to the link length. And it is given as r into alpha. This is said to be the tangential acceleration. Here r is once again AB. And my dear, if you are going to have omega here and alpha here, then my dear, the acceleration will become retardation. This time this will be the direction of tangential acceleration. This will be the direction of velocity. So with that time, velocity will be changing in magnitude first and then also in the direction. So this is the tangential acceleration. This is the radial or centripetal acceleration. Everybody is clear or not? Please tell me that. Everybody is clear or not? Please tell me that. These are the two accelerations. Generally, they would be acting all the times. Clear bhai? Harikesh, Savi, Abhi, Darshan, Shreyas, Raja, Ashray, Vinay, Sai Krishna, Sandy. Yes. Tell me guys. Clear? Okay guys, wonderful. Now my dear, we are coming on to the third acceleration. So one is radial acceleration due to change in direction, given as v square by r or omega square r. Second was tangential acceleration, which is given as ab into alpha ab. And you can see both the accelerations are perpendicular to each other. If you see radial and tangential, they are perpendicular to each other. If you will say, here is the link, this is omega, this is alpha, then you can say that radial is this, tangential is this. A radial, A tangential. So the net acceleration can be given as this. So we would be having the net acceleration A radial ka square plus A tangential ka square. Now my dear, we are coming on to the third very important acceleration, that is said to be Coriolis component of acceleration. My dear, first of all, I would like to ask you, what do you understand Coriolis component of acceleration is a real acceleration or imaginary acceleration? Is it a real acceleration or imaginary acceleration? Is it real or imaginary? It is real or imaginary? It is real or imaginary? Many students feels it is an imaginary acceleration because they don't find it many times. But I would like to say this is real only. But this is acting in the special case. It is acting like whenever we have a link which is rotating with omega, and on this the slider is sliding with velocity of v. At that time it is acting on the slider and given as 2v omega. So this acceleration is real, but it is not always acting. It is coming in a special condition when a slider slides on a rotating body. When a slider slides on a rotating body, then only this will be acting. And my dear, the magnitude of this acceleration is 2v omega. Always remember, this is acting on the slider. Now if this is acceleration, this must have a direction. So let us talk about the direction. You know, this is given as omega, this is given as v. This is the one case. Acceleration, direction is very important. This is v, this is omega. This is omega, this is v. All the four cases I am making in front of you. Let us see the direction. Magnitude is in front of you. Now we will be checking the direction. So my dear, just look at it. If velocity is in this direction, omega is clockwise or anti-clockwise? Omega is clockwise or anti-clockwise? Omega is clockwise or anti-clockwise? Clockwise or anti-clockwise? Clockwise. So if omega is clockwise, you just need to do one thing. Rotate the velocity by 90 degree in clockwise. Just imagine a clock. You can see this is the direction of velocity. According to the watch, the time is 3 p.m. or 3 a.m. whatever. So if you will be rotating it in clockwise direction, it will be showing you 6. So the direction of Coriolis will be this. Once again, this time, if you are going to make the clock, it is 9. If it is omega is clockwise, rotate it in the clockwise direction. After 9, the time will be 12. So this is the Coriolis. It is anti-clockwise. So if the time is 3, clockwise will give you 6, anti-clockwise will give you 12. This is the Coriolis. This is also anti-clockwise. 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 So if this is anti-clockwise, this is velocity. Clockwise will give you 12. Anti-clockwise will give you 6. This is Coriolis. Everybody is clear about the direction of Coriolis? These are the 4 cases possible. I have shown you all. Rotate the velocity vector by 90 degree in the sense of omega. Clear for everyone? Now my dear, this I am showing you that yes, practically it is there. When you are having a slider and this link is rotating with the omega and this is having a velocity of v, you know that because of omega this link will be rotated up to this point. Then my dear, if slider is at this position, but after some time slider will reach here, and this is happening because of slider is sliding on a rotating body. But if you are not having slider on a rotating body, you are having just slider alone, then you are giving angular velocity of omega and translation of v. This will make the slider reach here. So this extra motion is coming because of Coriolis. So that's why I said Coriolis is a real acceleration. Faninder, are you asking about the direction? Are you asking about the direction, Faninder? Tell me. Are you asking about the direction? Okay, just do one thing. You need to check whether the omega is clockwise or anti-clockwise. Don't say upward, downward. See clockwise or anti-clockwise. If it is clockwise, imagine a clock. See the direction of velocity, it is this. Now you tell me, if you see the clock, after 3, if you are rotating this by 90 degree, time will be 6 only, na? So this is the direction. The same I have done all the cases. If it is anti-clockwise, just go opposite by 90 degree. Clear? It is very simple. Don't think like upward, downward. Think like clockwise, anti-clockwise. Like if this is the direction of velocity, just imagine the clock. Clockwise would be this, so anti-clockwise will be this. Just imagine the clock. Anti-clockwise. Clockwise would be this, anti-clockwise will be this. Now it is clear. Now it is clear, guys. Clear for everyone? Bolo bhai. Is it clear for everyone? Okay. So guys, this is the question. Okay, note this. Just wait. Yes, this is the question. This is the question. In the figure shown, the relative velocity of link 1. The relative velocity of link 1 with respect to link 2. You know link 2 is rotating and link 1 is sliding. So relative velocity means sliding velocity. It is given as 12 meter per second. And this is rotating with 120 rpm. Omega is 2 pi n by 60. So you need to find out Coriolis. Coriolis is 2v omega. Find out and give the answer. Solve it and get the answer, guys. Faninder is getting 302. Answer will be coming out to be 302. Yes, it is correct. Very good. Next question. A link OB is rotating with a constant velocity of 2 radian per second. In counterclockwise, and block is sliding radially on it outward with 0.75 meter per second. The magnitude of the absolute acceleration. They are asking you the absolute acceleration. For this, I would like to tell you a case. Like, if you see this slider, it is at a distance of r, let us say. This link is rotating with omega, alpha, and slider is moving with v. And if they ask you the absolute acceleration, my dear, there are 3 acceleration which are coming into picture. As it is rotating, a radial acceleration will be acting here. As it is alpha is given, tangential acceleration will act here. Coriolis acceleration, if you want to see, you can see omega is in clockwise direction. So rotate velocity vector by 90 degree clockwise. You will be having Coriolis also here. So if you can see, this is radial, this is tangential, this is Coriolis. So they are at 90 degree to each other. Net acceleration will be a radial ka square, a tangential plus Coriolis ka square. Clear for everyone? Clear for everyone? Then, my dear, whenever we are talking about the next, you can also have, this is omega, this is alpha. Slider is moving like this. For this case, you would be having this as radial, this as tangential, and this as Coriolis. So this time you know this is radial. Now if tangential is more than Coriolis, then you would be having this as A tangential minus A Coriolis. And if Coriolis is bigger, then you would be having A Coriolis minus A tangential. But in both the case, net acceleration will be coming out to be square root of A radial ka square plus A Coriolis minus A tangential ka square. Because Coriolis minus tangential and tangential minus Coriolis ka square is the same thing. You can write it anyway because square is there, na? So, is it clear for everyone? Please tell me. This is the maximum possibility when all the accelerations are existing. But in general, they are giving only two acceleration existing, radial or tangential or radial or Coriolis. With three acceleration, they have never asked till now in the gate. I have shown you all the possibility. You can see this question now. They have given omega, they have given V. So only radial and Coriolis will be there. Priyanka, actually what you are saying is that is a depending fact. First of all, thanks for the thing. Yes, we are trying to give you the best here. But the problem is there is no problem with the PYQs. PYQ is a good thing. But at this time, students are also going for revisions. So that is why we are keeping marathon, because marathons are required for revision. And don't worry, I was also planning to have like PYQs of vibrations especially. So if we would be having a session like that, if I will get good response, then don't worry. From 21st to 30th, we will go for PYQ. There is not a problem. PYQ is a good thing, yes. And we have many times done the PYQs on YouTube. Not complete we have done. Okay. So no problem. We will plan it like that. Is it clear for everyone? What would be the answer? 5. You know that A radial is omega square r. Omega square r. Omega is 2. R is 1, 4. Then A Coriolis is 2V omega. What is A net? You know that this is radial and this is Coriolis. So A radial ka square plus Coriolis ka square. 5. C is the right answer. Clear for everyone, guys? Clear for everyone? Now, my dear, we are coming up with one last thing, that is Klein's construction. On Klein's construction, this is an underrated topic. Till now, very few questions are asked, but I feel that question should come from this. Klein's construction. Last topic of acceleration analysis, as I told you, that by 5 p.m. this chapter will be over, and now we will be entering into kinematic dynamic analysis, then flywheel, and maybe by 5:30, 5:40 flywheel will be over, and then we will enter into the other topics. After flywheel, I may directly go to the gears. After gears, cam governor will not take much time because they are small topics, gyroscope also. Okay, let us move further, guys, because we are not going for derivations. So Klein's construction, whenever we are talking about, here also I will directly give you from where the question will come. In the GATE ESC, when we are talking about the paid course, in the paid course we derive all these things. Okay, but here we will not derive, because in marathon we are covering 80 hours content in 8 to 9 or 10 hours. So obviously everything cannot be covered in detail. Yes, we can go for some things in detail, some things with the formula. But for exam, this is the best revision which I am going with. OAB. This is the omega. I am only not doing those derivations which have no role in exam. So my dear, first of all, Klein's construction was given for a condition when alpha crank is 0. Means crank is, first of all, it is given for single slider crank mechanism. First of all, it was given for single slider crank mechanism. First of all, it was given for single slider crank mechanism. Second of all, it was given for alpha crank 0. If alpha of crank is given, then Klein's construction is not valid. So they said if you want to make the velocity diagram of this mechanism, you need not to make the velocity diagram, just do one thing. You just put a perpendicular here, extend the connecting rod length, and where both of them are cutting, give the name P to them. And if you can see a triangle OAP, triangle OAP, this is showing you the velocity triangle. But this velocity triangle is actually oriented by 90 degree. Because in reality, when you will be making the velocity triangle for that, you would be making the fixed point O, and here ground is fixed, O and G. Then you can see omega is given like this, so velocity of A will be, you can see this is the mechanism, below this is rotating with omega. Velocity of A will be in this direction. So we can find out velocity of A with respect to O as OA into omega 2. And let us say it is coming out to be 5 meter per second. And we are assuming 1 meter per second as 1 centimeter. Then my dear, we can plot it. We can plot it like this. O comma G, this will be the A point. Now when you will be sitting from A, velocity of B with respect to A will be perpendicular to AB. I will make both the possibilities like this. We did not get any new point. We will sit from ground. From ground you will see slider is moving like that. So the velocity of slider will be either in this way or in that way. So if you will see, the velocity triangle is coming like this. This is velocity of slider. This is velocity of A with respect to B. And if you will make it like this, this is velocity of B with respect to A. If you see this triangle and this triangle, they are not looking same. Because this triangle is 90 degree oriented view of this. Like if I am going to rotate it by 90 degree, then this will be coming here. And this will completely be rotating by 90 degree. This is how it looks like. So this will be O, this will be B, this will be A. Now they are looking same. But still there is a difference. When you are talking about OA, this OA is OA into omega OA. But here OA is OA only. So it means there is a scale factor of omega as well. So if you want to write down the velocity of B with respect to A, so you know here velocity of B with respect to A is this AB. You can also write it as AP into omega of crank, because omega of crank is scale factor. Similarly, if you want to write down the velocity of slider, here you can write is OB or GB. Here you would be writing it as OP into omega OA, because this is a velocity triangle, but there is a scale factor of omega. This is the wonderful Klein's construction. So you can see that person have given a wonderful thing by which you can make the velocity triangle without any hard work. In reality, this is the diagram, but he was saying you can use it for the values. Then my dear, velocity triangle is still simple. When he have given the concept of acceleration diagram, then you will be holding your head like that. Because even if you see all these things in your dream, in the morning you will not be able to tell what you have seen in the dreams. This is the power of mathematics. He said if you want to make the acceleration diagram, that also I can show you how. He said take AP as radius, make a circle like that. Then he said take AB as diameter, take a circle like that. Then he said join both the circles in intersection point like that. Extend it to the line of stroke. And then he said finally कि this A, he has said this is Q, this is R. He said AQ RO. This is acceleration diagram. And like velocity diagram was 90 degree oriented, acceleration is 180 degree oriented. And it was having a scale factor of omega square, OA. It means if you want to write down the acceleration of A with respect to O, you can write OA into omega square OA. Because there is no alpha for OA, so only radial acceleration will be there. If you want to write down the acceleration for AB, you will write acceleration of B with respect to A, radial acceleration. Radial will be AQ into omega square OA, which is the scale factor. You know radial acceleration is along the link. Tangential is perpendicular to the link. So you can write the A tangential BA as AQ as QR into omega square OA. And this is the slider acceleration. Acceleration of slider is OR into omega square OA. Everything needs to be multiplied by omega square OA. I have given you this in a very fast way because till date there is no question on that. If the student of paid course is present here, he would be knowing that how I derived in the class this. I have taken around 1 hour for this because I have made the diagrams from the analysis first of all, but that was all required for engineering services, not for GATE. For GATE only you should know the scale factor and second thing the orientation. So here orientation is 90 degree, scale factor is omega. Here orientation is 180 degree and scale factor is omega square. Clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Yes. Harsha, Ajay, Darshan, Vinay, Abhi, Sandeep, Ashray. Very good. Faninder. Savi, where is the problem? Velocity or acceleration? Actually, in this for GATE, you just need to remember two things. One is about the scale factor. For velocity, it is omega. For acceleration, it is omega square. And second is velocity is oriented by 90 degree, acceleration is oriented by 180 degree. Yes, Savi, what velocity or acceleration? Velocity or acceleration? Velocity or acceleration? Tell me, Savi, then only I will go. Acceleration. Okay. So you can see what we have done. First of all, for velocity, we have put it a perpendicular and extended the connecting rod. This is the velocity triangle. Now, radial acceleration we are getting with the help of velocities only. Omega square r, v square by r. So, take AB as radius. Make a circle from that. Then take AB as diameter, make another circle from that. Join the intersection point of both the circle, extend it to the line of stroke. This AQRO is the acceleration diagram. Now this OA is along the OA. Along the link is radial acceleration. So this is giving us radial acceleration. But how acceleration is defined? Omega square OA. So it means here if it is giving OA, real acceleration is omega square OA. So it means scale factor will be omega square, and scale factor remains same for the complete diagram. So for this, if scale factor is omega square, for other three will also be omega square. So for this, scale factor is omega square. So we have written acceleration of AO is OA into omega square OA. Then if you see AQ is along the AB, along the link is radial acceleration. So we have written acceleration of BA radial, that is AQ into omega square OA. This is the scale factor. Tangential acceleration is perpendicular to the link length. So this is QR. It is tangential acceleration of connecting rod. So this tangential acceleration is QR into omega square OA. Omega square OA is the scale factor. Then this is the slider is in translation. So for slider only one acceleration. There is no radial tangential because slider is in pure translation. So we have written this OR as the slider acceleration. But there is a scale factor of omega square. Actually here I am telling you from this diagram only. But when you will study for ESC or in the paid course when we study, then there we make acceleration diagram without cleans. Then we match both of them. But here it is wastage of time because it is not coming in gate. Why? Because there you will not be having scale pencil to draw. So you should only remember two things. One is orientation, velocity diagram by 90 degree, acceleration diagram by 180 degree. Second is scale factor. In velocity is omega, acceleration is omega square. Otherwise this topic is of 1 to 1.5 hours. Okay, but we have to go as per the gate exam. Is it clear now, Savi? So just remember two things. For velocity diagram 90 degree omega. For acceleration diagram 180 degree omega square. Clear for everyone? Okay guys, chapter is over. Chapter is over. Only theory question from that can come, and numerical we have done from acceleration already. Now we are moving to the next question, next chapter guys. This is chapter number 5. We have completed velocity, we have completed acceleration. Now whatever this chapter we are starting, this is the starting point of flywheel as well. Okay, so we are starting now the flywheel. You will get the PDF on my Telegram channel. Fine guys. So when we are talking about the kinematic and dynamic analysis of single slider crank mechanism, so kinematic analysis means finding out velocity, acceleration, jerk, those kind of things. So my dear, here also derivations are there. We will just see the expressions. If you see, this is OA is the crank length. AB is the connecting rod. And N is said to be obliquity ratio. It is coming out to be L by R. It is coming out to be L by R. And for Sir James Watt engine, N was quite bigger because cylinder was of very big size. So N is quite bigger in size. And my dear, you can see whenever we are talking about a cylinder, in cylinder there is some clearance volume. So our slider will be moving from this to this location. So this is the stroke length, let us say. So I am taking a particular point when slider have started moving from B1 and it reached till B, and B2 will be coming somewhere here, the extreme point. So this is the displacement of the piston. So when we are going to derive the expression for displacement, velocity and acceleration, now once again we will not waste time on the derivation. This is the expression for displacement we are getting. Here you can see very easily that theta is the crank angle, beta is the connecting rod angle. and omega is the angular speed of crank. So when we are going to derive the expression for displacement of piston, it is coming out to be x is equals to r into 1 minus cos theta plus n minus n square minus sin square theta. This is displacement. Then you will go for velocity. Velocity is dx by dt, but time is not there, so dx by d theta into d theta by dt. D theta by dt is omega, so it is omega dx by d theta. So when you would be going for derivation, you would be getting the expression for velocity, and velocity will be coming out to be this: r omega sine theta plus sine 2 theta by 2n. Then my dear, you will go by the same logic with acceleration. Acceleration will be coming r omega square cos theta plus cos 2 theta by n. Then my dear, you will be going for the connecting rod angular acceleration. You know, omega cr can be written as d beta by dt. It is similar by the logic omega of crank was d theta by dt, because theta is the crank angle, beta is the connecting rod angle. So when you will calculate omega of connecting rod, you will get omega cos theta by square root of n square minus sin square theta, and alpha of connecting rod will be minus omega square n sin theta. So these derivation I could do, but not required. And the notes you will be having on my Telegram channel, there these derivations are done if you are interested. Okay, if you are interested in derivation, definitely you are preparing for 25, not for 24. Okay, so this is about the kinematic analysis. This formula is very helpful to find out the velocity of piston. Questions are coming directly from this. Okay, now we are moving to the dynamic analysis of single slider crank mechanism. That I will tell you in detail, because that will be giving us direction to go towards the flywheel. Okay, that will be giving us the direction to go towards the flywheel. Okay, from here only you can say the flywheel is starting. Dynamic analysis of single slider crank mechanism, and flywheel is the starting of dynamics actually, because you know, theory of machines is having two parts: kinematics of machine, dynamics of machine. So gears, flywheel, balancing, governor, gyroscope, they all are the part of dynamics. Okay, is it clear? So dynamics of machine we are starting now. Okay, let us see. So when we are talking about the dynamic analysis, you need to understand the working of the engine. So my dear, I am showing you how the Sir James Watt engine looks like. In Sir James Watt engine, this is the slider we have. And why we call it as a double acting engine? Okay, I am making it again, don't worry. This is the real diagram. This is the slider. हाँ भाई, Harikesh, PDF will be available. Okay, just let me show you. Look, when I am doing this, it is asking for keep. I am saying keep. Okay, so you can see it is shown now. So now whatever PDF you will be getting, it will be having the annotations. Okay, moving further. Actually, previous PDF you did not get because there some issue was there with the PPT. So annotations were not saved, but today annotations will be saved. In all other sessions they will be saved because I am taking from my home. Okay, previous sessions I have taken from office. There some problem was there in that smart board. Okay, So now my dear, we are having this slider. So from here high enthalpy steam will be coming. High enthalpy steam. And my dear, that high enthalpy means high energy content is there with the steam, and which will be pushing the piston like this. And as this will be pushing the piston will be expanding and you would be getting some work done for sure. Then my dear, your slider will be reaching here. And my dear, now what will happen? The steam which was here initially as high enthalpy steam, that would be converting into low enthalpy steam. So once again, some high enthalpy steam will be entering from here. Now when this high enthalpy steam will be pushing the piston, then this low enthalpy steam will go out. And similarly, when piston will go here, once again high enthalpy steam will come. This side high enthalpy steam will become low enthalpy, that will go out. So when piston is moving here, when piston is moving here, when slider is expanding on this side, sorry, steam is expanding on this side or that side. This stroke is a power stroke, this stroke is also a power stroke. This is a power stroke, this is a power stroke. So every stroke is a power stroke actually. Is it clear? So why both the stroke were kept like power stroke? The reason behind that was because Sir James Watt was looking for more energy to run the locomotive. So to get the more energy, to run the locomotive, more energy was required. So both the strokes were kept as power stroke. And my dear, I would like to tell you that whenever you are going to have this slider, this side, whatever steam is applying the pressure, let us say that is P1. On this side you will be having connecting rod. So here entire area is subjected to the pressure, but here some area will not be subjected to the pressure. That is why if P1 and P2 are the pressure on both the side, you would be writing the net force because of the gas, which is said to be the gas force. It is written as P1A1 minus P2A2. And I am telling you, A1 is pi by 4 diameter of piston ka square, and area of 2 is pi by 4 diameter of piston minus diameter of connecting rod ka square. Clear for everyone? Clear for everyone? This will be the gas force, my dear. This will be the gas force. Okay? But my dear, you know, whenever we are having this cylinder, I am showing you the movement. You know, when the piston is moving from this position to this position, you should be knowing here piston was at rest. And here velocity of piston was 0, here also velocity of piston is 0. So in between somewhere velocity of piston will be maximum. Is it clear? So if in between velocity of piston is maximum, I am considering this motion. So it means in this motion, this piston will be in some acceleration. And Newton's first law says whenever a body is at rest, it wants to be at rest. Whenever a body is in motion, it wants to be in motion. So you are going to try to pull a body which was at rest. You are trying to pull a body which was in rest. You wanted to pull a body which was in rest. You wanted to pull a body which was in rest. So if you want to pull that body which was in rest, my dear, you are providing that kind of acceleration. And because of that, inertia force will be coming, because if you are going to give some acceleration to a body, body will also be applying the same to you. That force is said to be inertia force. That is the resistance of the body, because you are not letting them at rest. Okay? The Newton first law says a body will keep on its state of motion until an external force is acting onto that. Is it clear? So my dear, it wants to be at rest, but you are applying the force to pull the piston. So piston also will apply an inertia force. Yes or no? So my dear, when we are talking about inertia force, it is defined as m into acceleration of piston. You know acceleration of piston, we have calculated r omega square cos theta plus cos 2 theta by n. But we need not to write this. If you want to find out what is the net force acting on the piston, then my dear, net force acting on the piston is nothing but gas force minus inertia force. Inertia force will always oppose the motion, minus friction, and plus minus mg. Mg will be coming into picture only for the vertical engine. Like if you are having a vertical engine like this, then piston is moving in this direction, mg is also acting in this direction, you will have plus mg. And if you are having the engine like this, piston is moving upward, mg is downward, then you will be having minus mg. So only for vertical engine this mg term will come. This is the net force acting on the piston. This will be given to you in the question, so don't worry about that. Now my dear, whenever piston will be getting that force, piston will try to move to the connecting rod, and connecting rod will try to move the piston. So my dear, whenever we are talking about connecting rod, as this connecting rod force is coming because of this mass only, piston will also apply some force onto the cylinder walls. So my dear, if you want to find out these forces, you can say Fc cos of beta is equals to F net. From here you can find out Fc as F net by cos beta. Okay, and similarly you can write Fc sin beta as equals to F on the cylinder wall. So you can write F on the cylinder wall as F net by cos beta into sin beta. Okay, but these are not much important. Important forces which are acting on the crank. Because finally this connecting rod force is coming here, which is divided into two components. One component is acting towards the center along the crank. Other is acting perpendicular to the crank. So if this angle is theta, this angle is also theta. If this angle is beta, this angle is also beta. So total angle is theta plus beta. Total angle is theta plus beta. Which F is positive, Darshan? Friction is always opposing the relative motion. And I am taking only the motion of first half, mind it. For other half the things would be opposite because piston will be deaccelerating at that time. Okay, but acceleration and friction have nothing to do with each other. Friction always acts relative. Inertia force direction will change. Okay, so you need not to worry about the individual forces because F net will be given to you in the gate. You would be getting the combination of this. Now my dear, when you are going to say this Fc, this angle is theta plus beta, and if that is the case, Fc will be having two forces. One is F radial, other is F tangential. F tangential is responsible for rotation of crank and F radial is coming onto the center. Is it clear? So my dear, from that we can write F radial as Fc, F radial as Fc cos theta plus beta. What is Fc? F net by cos beta into cos theta plus beta. Then Ft will be F net cos beta into sin theta plus beta. Everybody is clear? Any doubt, please ask. Yes, Faninder, Savi, Darshan, Harsha, Harikesh, Vinay. Yes. Okay guys. So when we are going to have this F tangential, this is the force which is responsible of rotation of crank. Faninder, I am coming on to that. This is that formula. When someone will ask you what is the twisting moment will be Ft into R. This formula you need to remember. Twisting moment will be F net by cos beta into sin theta plus beta into radius. This is the formula you need to remember. This is the twisting moment which is responsible for rotation of crank. Okay, and when we are talking about this is responsible, you know, twisting moment is given as I into alpha. You know that twisting moment is a function of theta and beta, and we know theta and beta are the function of time. Theta and beta are changing with the time, so I is a constant. So we can say alpha will change with respect to time. So if alpha is coming as a function of time, it means acceleration changing with time. Acceleration changing with time means jerks are present. And if jerks are present, vibrations will be there. So as vibrations are present in the system, my dear, whenever alpha is going to change, alpha is responsible for change of velocity. So acceleration, which is responsible for change of velocity, if acceleration itself will change, definitely it will change the velocity to a very high ranges. Like previously velocity was ranging from 10 to 20%, but 3 to 4% of jerk if it is present, it will convert this 10 to 20% into 80 to 90%. Just feel acceleration is velocity final minus velocity initial by time, that is acceleration. If acceleration itself is changing, you can just imagine what will happen to velocity then. So my dear, because of that the things are going to become very, very critical. So that's why we want some device which is going to help us. And what is that device? We are calling them instantaneous fluctuation control devices. Instantaneous fluctuations control devices. When we are talking about instantaneous fluctuations control devices, you know that fluctuations means fluctuation of speed. They can come from two sides. They can come from inside the cycle and they can come from outside the cycle. When they are coming from inside the cycle, then my dear, for them the device use this flywheel. And when we are going to have outside the cycle, the device uses governor. I am not going into the detail of flywheel and governor here, because we will see that detail in their chapters. Okay, why to repeat again and again? So let us see directly flywheel. But why we need flywheel? From the fluctuations coming from inside. Why inside fluctuations are coming? Because you know there is a suction stroke, there is a compression stroke, there is a power, there is exhaust. Suction stroke requires energy minus 10 joule, let us say. Compression requires minus 20 joule. Power is going to provide 160 joules, let us say. Exhaust require minus 10 joule. So out of 4, only one stroke is giving you power, others are consuming the power. So it is like on the 1st of every month your father is putting 20,000 rupees in your bank account. Then every day you are spending it. So your bank balance will keep on changing. So that change of bank balance, we are saying it as fluctuations of energy or fluctuations of speed. Okay. So that will keep on happening because one day we are getting, all 30 days we are spending. So now my dear, these fluctuations are going to happen, and when we are talking about flywheel, flywheel will help us to control these fluctuations. Why the problem is there with these fluctuations? The problem is when the speed will be changing, because if you are talking about a crankshaft, it is a crankshaft which is rotating with a regular speed of omega. So when this 160 joule is coming to the crankshaft, my dear, crankshaft can store any energy in the form of rotational kinetic energy. Because of that, its omega increases too much. So it start rotating with very high speed. Previously it was rotating at 600. It directly goes to 2000 rpm. But on the other instant, when exhaust stroke comes, some energy is getting lost, because of which omega reduced to 1700. Then suction stroke comes, omega reduced to 1400. Then compression come, omega reduced to 600. So this variation is going to happen in one cycle, and if you have 1000 rpm means 1000 times these fluctuations are happening in a minute. So definitely crankshaft will be having the vibrations like that. And that vibrating crankshaft, if you are putting into the wheels or the engines or anywhere, you cannot run it for the longer duration. It will be breaking after some time. So if you don't want to do that, you need to control these fluctuations. And for controlling these fluctuation, we require fluctuation control device, which is said to be flywheel. Is it clear for everyone? Clear for everyone? So we are entering the chapter flywheel from here. We are entering to the chapter flywheel from here. Turning moment diagram for a double acting steam engine. We have just seen the double acting steam engine. In the double acting steam engine, you have seen that both sides we were getting the power. So my dear, you should know one thing, that we have seen the variation of pressure there. High enthalpy steam converting into low enthalpy was going out, like that the things were happening. So pressure was varying. So if pressure will be varying, force is pressure into area, force will vary. If force is vary, torque is force into radius, torque will vary. So that is why whenever I make the diagram between torque and theta, you can consider it is going to be the same as between pressure and theta. So you will see for the double acting steam engine, practically this type of curve is coming. So you can see the variation of torque are too much, and they are coming when we are not using any flywheel. So if you want to see, this is the area under the curve. And if you want to find out this area under the curve, you know 0 to 2 pi is one cycle. Why one cycle? Because starting position of the piston and last position of the piston will remain same after 2, because pi, 2 pi. Although you can see, sir, this curve and this curve are same, why not time period is pi? Because we are saying time period if the cycle is over, and after completion of cycle, initial and final condition should be same, which is not same here and here, which is same here and here. Because if you have this cylinder, double acting steam engine, so piston is going to move here in the first pi, coming back in the second pi. So time period should be 2 pi. And if you want to write down the work done in the cycle, you will be saying 0 to 2 pi T d theta. So integration T d theta 0 to 2 pi will give you the work done. Is it clear for everyone? Is it clear to everyone? So you know this is going to be a variable torque. So for this we were having problems. So what we were looking for flywheel, we don't want from flywheel that this torque, this work done will increase. No, we want the same work done at constant torque. So let us say we want the same work done at this mean torque, which is a constant torque. So if you want it at the constant torque, you can also write it as Tm into 2 pi. From here you can find out the mean torque is 1 upon 2 pi 0 to 2 pi T d theta. Sometimes they are asking that mean torque. So mean torque is that value of torque which, if remain constant throughout the cycle, will give you the same work done. So you can say this area of rectangle is also equals to the work done in cycle. So my dear, this white one is what we are getting without flywheel. This yellow one is what we want from flywheel. But flywheel cannot give us this. Flywheel is giving us somewhere in between. Flywheel is giving us this green type of curve. Means flywheel reduces fluctuation but does not completely eliminate them. Flywheel reduces the fluctuation but does not completely eliminate them. Flywheel reduces the vibration but does not completely eliminate them. Is it clear for everyone? बोलो भाई, थक गए क्या? फरिंदर, आश्रय, विनय, डोंट वरी, फ्लाईव्हील कंप्लीट होते ही ब्रेक लेंगे, टी ब्रेक. ओके, डोंट वरी. Is it clear for everyone? So my dear, whenever you are going to have this, I would like to tell you, whenever you show this, you see this curve, then my dear, you can see whenever we are having our original curve lesser than t mean, then my dear, this thing is said to be the fluctuation. This is negative fluctuation. And when our torque is more than t mean, we call it as positive fluctuation. Negative, positive, negative. Actually, positive, negative has no meaning. We call them as fluctuation. So this hatched area are fluctuation. And I would like to say all the summation of positive fluctuations are equal to the negative fluctuation. So you can say energy is conserved about t mean line. We can say energy is conserved about t mean line. Energy is conserved about t mean line. What do you mean by that? It means whatever the positive fluctuation and the negative fluctuation, they are equal. Net is zero. And that is there because this is the total work done we are getting from the engine. This is the work done we are getting. Why I am saying this is the work done we are getting? Sometimes we are producing less than the required. Sometimes we are producing more than the required. Sometimes less than the required. Sometimes more than the required. Okay? Is it clear? So that is why energy is conserved about the t mean line. Energy is conserved about the t mean line. So you already understood that speed will be keep on increasing, decreasing, increasing, decreasing. Whether flywheel is there or flywheel is not there, but with the flywheel those changes are very, very less. So if the speed is fluctuating, then my dear, we are going to define some things. We are saying n max is the maximum speed, n min is the minimum speed, and n mean, which I can define it as n max minus n mean by 2. So maximum speed, minimum speed and mean speed. Based on that, there is a character defined as CS, coefficient of fluctuation of speed, which we define it as delta n by n mean. So CS can be written as delta n. What is delta n? N max minus n mean. And n mean you already know. This is coefficient of fluctuation of speed. You can also write it as omega max. Omega is 2 pi n by 60. Omega min by omega mean. Clear for everyone, guys? Clear for everyone, guys? Yes. So my dear, similarly we are having maximum energy as half I omega max ka square. Minimum energy as half I omega min ka square. And we can write the mean energy as half I omega mean ka square, or we can also write it as work done in a cycle. So like we define coefficient of fluctuation of speed, there is something called as coefficient of fluctuation of energy, which is defined as delta E by E mean. We can write it as E max minus E min by E mean. Is it clear or not? Please tell me. I am coming on to the numerical part, don't worry. Clear for everyone or not? Please tell me that. I will also tell you how the flywheel is going to work. Okay? Then my dear, we will see the relation between CE and CS. You are saying CE is E max minus E min by E mean, half I omega max square omega min square omega mean ka square, half I will get cancelled out. So you can write it as omega max minus omega min, a square minus b square, omega max plus omega min. We can also write it as omega mean into omega mean, because it is omega mean ka square. You can see omega max minus omega mean by omega mean is nothing but CS, and omega mean is nothing but omega max plus omega min by 2. You know max plus mean will get cancelled out. So you would be getting 2 here. So CE will be coming out to be 2 times of CS. CE is coming out to be 2 times of CS. Sometimes they can ask you the relation between the expression for omega max by omega min. I am directly giving you 2 plus CS, 2 minus CS. You can go and do it by derivation also, but this is the result from which direct questions can come. Now I am coming on to the topic from which every year numerical is coming. 90% of the question on flywheel are coming on one relation, that is energy equation of flywheel. So we are coming on to the energy equation. Okay, all these things we have already discussed. What is the energy equation? Energy equation. My dear, energy equation is giving us the delta E. Yes, Faninder. So delta E can be written as E max minus E min. E max is half omega max ka square, half omega min ka square. Yes, I also will be there. So you can write delta E as 1 by 2 into I omega max square minus omega min square. So when we are talking about delta E 1 by 2 I, we can write it as omega max minus omega mean, omega max plus omega mean. And my dear, if I divide it by omega mean and I multiply by omega mean, you know this max minus min by omega mean is nothing but CS, and this max plus min by 2 is omega mean. So we can write delta E as I omega mean square CS. This is the fundamental equation from which a large number of questions are coming from the flywheel. And my dear, when you say this delta E, this is the fluctuation of energy. This is the fluctuation of energy which is stored by the flywheel. I is the mass moment of inertia, which is given as mk square, where k is the radius of gyration. K will be r if we are going to have rim type of flywheel. In rim type of flywheel, total mass is at the outer radius, and k will become r by root 2 if we have disc type of flywheel. Clear? Clear? Yes. So my dear, sometime they can ask you the mass of flywheel. You can measure from here, you can find out from here, calculate from here. Okay, For disk, R by disk is like this. Clear for everyone? This is the equation from which a large number of questions are coming from the flywheel. Okay, is it clear for everyone? Please tell me that. Clear for everyone till this point? Please tell me that. Then we will move further. Yes, very good, very good, very good, guys. Now we are coming to the IC engines. Coming to the IC engines. After that, multi-cylinder engine and punching press flywheel will be over. Okay. So we would be having break around 6:05 or 6:10 for 20 minutes for tea break. After tea break, we will be coming up for the gears. Gear trains. Okay. And then we will see governors cams. Okay. Vibrations, we will have the separate session, don't worry. Let us move further. Turning moment diagram for a 4-stroke IC engine. When we are talking about the 4-stroke IC engine, you know that we are having a cylinder like this. We are having a piston like this. So my dear, for suction stroke, you are going to pull the piston back. You are going to pull the piston back. So you are doing work on the system. Why you are doing it? To create the vacuum here, so that the fuel air mixture can come inside. So as you are doing the work is done on the system, not by the system. Work done on the system is negative. So that is why you would be getting initially the negative curve, but slightly positive it is becoming. Why? Because whenever this fuel air mixture will be coming inside, it will also have some pressure. So because of that, some positive area will be coming. Otherwise, majority negative area is there. Actually, this diagram is not exact. If you want to see the exact diagram, then it would be coming like this. This is T, this is theta. You would be having the first suction stroke is like this. You would be having it like this, very small positive. Okay, then my dear, when your piston reaches here, it would be compressing. Compression is once again work done on the system, which is negative. So compression curve is coming out to be more negative. More work is done like this. Then my dear, here comes the power stroke when combustion will be happening. When combustion is happening, there is a complete push onto the piston because of combustion. So we are going to get a huge work done there. This is said to be the power stroke. Then my dear, in the exhaust, whatever the gases are there, those would be taken out. They will be pushed, piston will be pushed again. So my dear, because of that, work is done on the system. Once again, you would be having the negative. Small positive is coming because of volt timing diagrams. You have studied the volt timing diagram in IC engine. So my dear, suction, compression, power, exhaust. So if you want to write down the work done, it is once again pi, 2 pi, 3 pi, 4 pi. For 4-stroke IC engine, you know cycle time is 4 pi. You would be going to integrate from 0 to 4 pi T d theta. And my dear, this is what we are getting without flywheel. From flywheel, we want the same work done at the mean torque. So that mean torque is a constant term. So we want to get the same work done at constant torque. So from here we can define T mean as 1 by 4 pi. Integration 0 to 4 pi T d theta. This will give us the mean torque. And guys, I would like to tell you one more thing, that this positive area and these negative areas, summation of all three negative area will be equals to summation of one positive area. So my dear, if you want to find out the fluctuation of energy, always advisable to calculate this positive area, and that is said to be our delta E. This is said to be our delta E, the fluctuation of energy. That is said to be our delta E, nothing but the fluctuation of energy. And guys, if you are having this fluctuation of energy, just you need to say delta E is nothing but I omega mean square Cs. If Cs is given as 1%, you will say it is 0.01. If it is given plus minus 1%, you will take it as 0.02. Clear for everyone? Harikesh, 2 pi to 3 pi is the power stroke. So a work is done by the system. And once again you are taking the gases out. So once again it will become negative. Slightly positive is coming, just like previously was coming. We need not to go into that. That explanation is the part of engines, IC engine, not for the theory of machines. For theory of machines, this is required. This I have done. This is theory of machines. Clear for everyone? Clear for everyone? Very good, guys. Now, my dear, we are talking about the multi-cylinder engine. Here, many students have doubt. Actually, the multi-cylinder engine came into picture because when you want more power, the size of cylinder will be bigger. So, sometime to not have that bigger cylinder, we can also go for the multiple cylinder. Like in IC engine, we need a compact engine. We go for the 4-cylinder inside, 4-cylinder engine, 6-cylinder engines. Yes or no? So that is the case of multi-cylinder engine. Now if we go for the multi-cylinder engine, just I am telling you a hypothetical case. Just I am telling you a hypothetical case. This is pi, 2 pi, 3 pi and 4 pi. I am telling you a hypothetical case. That hypothetical case is this. Let us say you are having one suction, compression, power and exhaust. Because of this, here we have minus 10 joule, minus 20 joule. Here plus 160 joule and here once again minus 10 joule. Let us say you are having one more cylinder. In that cylinder also the same thing is going on. So for that minus 10, minus 20, plus 160, minus 10. Let us say one more cylinder is there. We are talking about 4-cylinder engine. Then in that engine also here minus 10, here minus 20, here plus 160, here minus 10. Then one more cylinder is there, as we are working with the 4-cylinder engine. There also minus 10, minus 20, plus 160 and minus 10. If you are going to total them, this will become minus 40, this will become minus 80, this will become 4 into 160, 400, it is 640. It is minus 40. So don't you feel, if you are going to make single diagram, if you are going to make the single diagram for this, don't you feel the fluctuations will be increasing? In place of minus 10, you are having minus 40. Minus 10, minus 20 becomes minus 80, 160 becomes 640. Can you feel that fluctuations will increase? Can you feel fluctuations will increase? Now the mean line will be coming here. So you can feel the fluctuation of energy is coming more. And if you want to store this delta E, it would be requiring big size of flywheel. The size or inertia of the flywheel will increase. So my dear, to avoid this, an idea was given. Actually the idea was given for the balancing. But with the balancing, we tried to take the benefit of reducing the size of flywheel. So my dear, with that what we have done, we have changed the stroke positions. We said, just see once again, we said when compression is going on in the first cylinder, why not we are keeping power of the second cylinder here? And when the compression is happening in the first cylinder, why not we keep power of the other cylinder? What is the benefit of that? Just try to look at it. Let us say you are saying that this is suction, compression, power and exhaust. This is for the first cylinder. If we are going to keep the power of second here, exhaust, suction and compression, then we are going to have the power of third here. This is exhaust, suction, compression. Then we are going to have power of fourth here. This is just a hypothetical, it is not real. Okay, if power of 1 is coming here, here will be compression, here will be suction, here will be exhaust. So this time you would be having a balance. Here also you will have minus 10, minus 10, minus 20 and plus 160. Here also you will be having minus 10, minus 10, minus 20 plus 160. All four strokes are coming from 0 to pi, pi to 2 pi, 2 pi to 3 pi, 3 pi to 4 pi. If that is the case, resultant diagram will be coming like this. So you can see now the fluctuations are already coming like that which flywheel was giving us. if you remember the first diagram for double acting steam engine, this was without flywheel and this was expectation from the flywheel and this was provided by the flywheel. Here flywheel we are not using, without flywheel only we are getting this, and this is possible by changing the position of stroke in different cylinders. When one cylinder is having suction, we have provided power of some others. So when we are going to have different strokes in different cylinder, it is similar to like you are 4 friends. You are convincing your parents that my pocket money will be coming in the first week, we all will enjoy. Second's pocket money is coming in the second week, you all will enjoy. Third's pocket money will be coming in the third week, you all will enjoy. Fourth pocket money is coming in the fourth week, we all will enjoy. So in all the 4 weeks you will be enjoying, because every week you are getting someone's pocket money. Is it clear for everyone or not? Clear for everyone or not? So when we are doing that, my dear, fluctuations are automatically reduced, and because of that reduction in the fluctuation, this time either flywheels are not required, and if flywheel is required, the size of the flywheel required is very less. So with a very small size of flywheel we can go ahead now. With a very small size of flywheel we can go ahead now. That is the beauty of this concept. Clear for everyone? Clear for everyone? Clear for everyone? Yes. So guys, this is said to be the concept of firing order. You can see different cylinders, crank positions are different. So for that, what we are doing, we are having a crankshaft. One crank is like this, other crank is like this, other crank is like this, and other crank is like this. Because crankshaft is single, cranks are multiple. Every crank will be having a connecting rod, every connecting rod will have a slider, every slider will be in a cylinder. So we would be having 4 arrangements, but they would be at different position to each other. Because of that, the things would happen like that. Clear for everyone or not? Please tell me that. Clear for everyone or not? Please tell me that. अब मुझे लग रहा है आप लोग थक रहे हैं. Okay? So इस तरीके से तो मुझे नहीं लग रहा हम पूरा कर पाएंगे. Are we getting it? Please tell me that. So this is how we have removed the requirement of flywheel. Now my dear, I am telling you one more beautiful thing, how the flywheel is working actually. So my dear, previously this was a crankshaft. When power stroke happened, a large amount of power was coming. So because of that, half I omega square energy was getting stored. So my dear, your crankshaft was moving from 600 to 2000 RPM. Then when suction stroke was happening, this 2000 was going below to 1700. 1700 was going below to 1400. 1400 was going below to 600. So this cycle was moving from 600, 2000, 1400, 600 like that. This was the cycle going on. 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 600 to 200, sorry, 2000, 1700, 1400. This was without flywheel. So my dear, when we are going to add flywheel, flywheel is sitting on the crankshaft like that. So whatever the energy previously coming 160 joule, previously that was going only to the crankshaft. But now it will be going to the crankshaft plus flywheel. So when these two bodies will be absorbing that amount of energy this time. So because of that, whatever was coming to crankshaft, like previously 10 chapatis was taken by one person. Now the same is taken by 2 persons. Chapatis will be divided. So this time fluctuation of speed will change. Both are rotating with omega. Some energy will be stored by flywheel, some will be stored by crankshaft. So now the energy will be stored as half I crankshaft omega square plus half I flywheel omega square. Omega is same because both are sitting on the same member. They are rotating with the same omega. So this time when once again the power stroke will happen, when flywheel is there, 600 may become 1000. And then 1000 when the exhaust stroke will be there, it may be happening 900. Then suction will reach it 800. Compression will make it 600. So the fluctuations which were from 600, 2000, 1700, 1400, 600, now they are reduced to 600, 1000, 900, 800, 600. So don't you feel fluctuations are reduced now? Don't you feel fluctuations are reduced now? Don't you feel fluctuations are reduced now? So when the fluctuations are reduced, I can say this time the need of flywheel will be lesser. So this is how the need of flywheel is getting reduced. This is how the flywheel is working. This is how the flywheel is reducing the fluctuations of speed. Everybody is clear? So we have seen up to multi-cylinder also. So I have already told you multi-cylinder diagram will be coming like that. So my dear, I am making a small diagram to understand it. For multi-cylinder, let us say this is the diagram coming. We are saying this is point A, this is B, this is C, this is D, this is E. This area is A1, this area is A2, this area is A3, this area is A4. If you want to write down the energy at A, let us assume it to be E. If you want to write energy at B, you can write it as E plus A1. If you want to write energy at C, you can write it as E plus A1 minus A2. If you want to have energy at D, you can write it as E plus A1 minus A2 plus A3. And if you want to write energy at E, E plus A1 minus A2 plus A3 minus E4. But you know that when you are starting at A, ending at A, cycle is over. So this energy and this energy should be equal. So this should be equals to E. From here you would be knowing the values of all the 5 energies. From here you need to find out which energy is maximum, which energy is minimum. This will give you delta E. And you know delta E is I omega mean square CS. So this will give you which size of flywheel would be required here. This will give you which size of flywheel will be required here. This will give you which size of flywheel will be required here. Clear for everyone or not? Please tell me that. Sometime, my dear, the areas are given in mm square. Then they will give you 1 mm square is this much joule. So you can convert using the scale factors. Clear for everyone? Clear for everyone? Sometimes they give different scale factor for y-axis and 1 axis, x-axis. They may say that 1 mm is equals to 6 Newton meter and 1 mm is equals to, let us say, 1 degree. Then what you will be doing? You will write 1 mm square as equals to 1 mm into 1 mm. And you would be putting both the scale factor. In that way you can find out the energy which is given in terms of area mm square. We are left with 2 more topics which are, but before we go on to these 2 topics, let us solve some question. Are we ready to solve some question? Please tell me. I want to give you a wonderful concept, but before that let us solve some numerical. Okay, I want you to do some questions before moving. This is the question from gate only. Solve it. This is the question from gate only. For a certain engine having an average speed of 1200 rpm, this is n mean. Flywheel is approximated as a solid disk is required for keeping the fluctuation of speed within 1%. So CS is 0.01. Delta E is 2 kilojoule. Radius of gyration is R by root 2. Radius is 0.5. N mean is 1200. You know the formula is delta E I omega mean square CS. Solve it and find out the value, guys. Solve it and find out the value, guys. Flywheel will take 15-20 more minutes. After flywheel we will take the break and then we would be covering the gears and gear trains. Okay? Solve this question. Solve this question. Solve this question, guys. Solve this question, guys. Yes. Okay, Ajay is saying the answer is 51 kg, which is correct. So when you will be putting the value, it is 2000 joules. I is mk square. K is R by root 2. So 0.5 by root 2 ka square. CS is 0.01. So mass will be coming out to be 51 kg. So this is the type of question which are coming in GATE more in number. Okay, guys. So now I am coming on to one more thing. Before that, let us solve one more question. Okay. Yes, let us solve this question. After this question, we will go to the punching press. Then one question on punching press, flywheel will be over. Okay. So guys, this is saying the turning moment curve for an engine is represented by the equation. They have given you the equation as, in this question, I want to make you learn something. 20,000 plus 9,500 sine to theta minus 5,700 cos to theta. Let us say this is given to us and he is asking to find out the work done. My dear sir, I feel like for previous question, no, Ajay, actually just look at it. Whenever they say it is 1% positive, you will take 0.01. And whenever they say 1% about the mean speed in both the sides, then you will take 2%. And or if they give you plus minus 2%, then also you will double it. Is it clear? Actually, maybe in the previous question, we will go once again, no issues. Okay, but as I said, that is a previous years of GATE question and the answer is 51 only. Okay, so I am telling you, actually whenever you are going to have the statement on both the sides, then you need to multiply it, but they will be mentioning it in, yes, Darshan, that's what I am saying is, if they, okay, I will once again show you, maybe that statement I have not seen properly, but yes, if you are having this on both the sides of mean, on both sides of mean speed, then definitely you will take it 2%. Okay, yes, it is correct. Okay, but if it is saying 1% about the mean speed, then you will take 1% only, because they are not saying on both the sides. On both the side, if it says, then 1% about mean speed means 0.5 here, 0.5 there. Okay, so don't get confused. So if they say on both the sides of mean speed, then take 2%. 1% will become 2%. Clear now? Clear now, Ajay, Darshan, Faninder? Yes. Don't worry, I will show you that question again in that case. So guys, here if this equation is given and he is asking you to find out work done, how you will find out? You know, for work done, we need to go for T d theta integration for the cycle time. In this question, we don't know the cycle time. Many of you may be using your brain in this way. Ki, sir, we know that sine theta is coming like this. And if sine theta is coming like this, sine 2 theta will be going with the double speed. So it will be going like this. So if sine theta is having time period of 2 pi, sine 2 theta will be having a time period of pi. Always remember, if sine theta is having a time period of 2 pi, then sine m theta will be having a time period of 2 pi by m. The same is with the cos theta. Okay, but my dear, here we have sine 2 theta here, cos 2 theta here. So here, if they mention it double acting steam engine, we go for 0 to 2 pi. If they mention it 4-stroke IC engine, we will go from 0 to 4 pi. Good evening, Shivram Patil. But he is not mentioning like that. He is just saying the turning moment diagram of an engine is like that. So when he is saying like this, now this is your responsibility to find out the time period. And for that you would be saying the time period for sine 2 theta is 2 pi by 2. The time period for cos 2 theta is 2 pi by 2. So it is becoming pi, it is becoming pi. Pi by 1, pi by 1. So it is very easy. You can say time period of this is pi. But let us say if your function would be like this. If you have a function of sine 3 theta, cos 5 theta, then here you would be having time period as 2 pi by 3. Here you will be having time period as 2 pi by 5. Then you will be taking LCM of numerator, HCF of denominator. LCM of numerator will be 2 pi, highest common factor of 3 and 5 will be 1. Then 2 pi would be the time period. To teach you that, I have given you this concept, this question. So my dear, here we are having 0 to pi only. So when you would be finding out the work done, you can write down T d theta integration from 0 to pi. My dear, when you will be integrating sine 2 theta from 0 to pi, you will get 0, because sine 2 theta 0 to pi, whatever the positive area, the same is the negative area. It is 0. Integration of cos 2 theta, cos 2 theta, cos 2 theta from 0 to pi will be 0. So this will give you simply 20,000 pi. Are we getting it or not? Please tell me. Yes, Shivram, Faninder, Darshan, Ajay. Are we getting it or not? Please tell me that. Very good, very good, very good. So we would be getting this as 20,000 pi. Now they can also ask you the mean torque. So you will say mean torque into pi, because cycle time is pi, is equals to 20,000 pi, which is the work done. You know, T mean into the cycle time is the work done. So you would be getting mean torque as 20,000 Newton meter. Clear for everyone? Now my dear, if you want to apply, and someone will ask you find out the delta E also. How you will find out delta E? You would be assuming the curve like this. You will assume, let us say this is the T theta curve, and let us say this is the T mean line. Why we are assuming like this? Because we know in IC engine we have only one power stroke. So we want to find out the positive area only, and this will give me the delta E. So if you want to find out this is theta 1, let us say, this is theta 2, let us say. If you want to find out delta E, you can write, you can see above curve is for torque, below curve is for T mean. You know the rule of integration. Whenever you want to find out the area, you would be writing here as T minus T mean into d theta. And integration will be from theta 1 to theta 2. Integration will be from theta 1 to theta 2. Now the problem is we don't know the value of theta 1 and theta 2. But we know at theta 1 and theta 2, T and T mean are equal. So you know T is 20,000 plus 9,500 sine to theta minus 5,700 cos to theta is equals to 20,000. T mean, this will get cancelled out. From here we can write tangent to theta 5,700 upon 9,500. From here you would be getting some value of theta 1. And you know that when we are talking about the tangent theta is having a time period of pi. So if you would be getting the value of theta, this one, at this you are getting some value, the same value will be coming after pi. Okay, this is the curve for tangent theta. You will be getting some value of theta from here. Yes or no? Yes or no? So whatever, okay, you are finding out 2 theta, let us say. So whatever you would be getting some value, the second value will be plus 180. Let us say here you are getting some 2 theta 1. Then it will be 2 theta 1 plus 180 degree. Then my dear, you can write theta as theta 1, comma, theta 1 plus 90 degree. So you would be getting these two values like that. And when you will be integrating between these two, you will be getting the delta E value. After that, you just need to do delta E is equals to I omega mean square CS. Is it clear for everyone or not? This type of question are generally not coming in GATE. They are the conventional type of question. But still, as I am giving you all the things, that's why I have tried to clear this concept to you. Is it clear, Harikesh, Ashray, Shivram, Faninder? So 8 hours are completed from the morning and flywheel is about to over. So let us see the last part of the flywheel and then we will be going for the break. Okay? Break chapter nahi, tea break. Okay? So guys, okay, after break, would you like gears? After break, would you like gears? Because after that, gears is the most important topic. Okay, so after flywheel break, we will see gears and gear trains. Okay. Now we are going to have the punching press. So my dear, in the production, if you have attended my class day before yesterday when I have taken casting, welding and sheet metal operations. So when we have discussed casting, welding, sheet metal operations, then in sheet metal operation you studied blanking and punching. The same operation we are talking about. So my dear, you just feel that this is the sheet in which you want to make a hole. And for that, you are going to have a punch like this. Now this punch have to go down and come back. This you can get in the reciprocation, which can be provided by single slider crank mechanism and can also be provided by cam and follower mechanism, by any of the following. So you would be having, let us say, this to be connecting rod crank like this. Like here is shown, this crank is rotating. So when this crank will be rotating, this punch will be going down and coming back, and it will be creating the hole in the sheet. But here, where comes the flywheel? Actually, my dear, here we have a motor, and that motor is rotating this crank at some speed. So motor is giving some P power, let us say 5 kilojoules per second. So it is giving 5000 joules per second. So every second this much power, this much energy is given by the motor to the setup, to the cam, to the crank. But my dear, energy is required only for 1 second when this punch is passing from here. And this 1 second, to make a hole, let us say the energy required is 30,000. In this 1 second, I need 30,000 joules of energy during the cutting process. So my dear, motor is giving 5000 per second. So the entire cycle should be of 6 seconds. So that in 6 seconds, motor will be provided 5000 into 6, that is 30,000 energy. We are assuming there is no loss because of air friction. So if 30,000 energy is required, 5000 is given by the motor every second. But the problem is cutting is happening only for 1 second. So rest 5 seconds when motor will give the energy, who will store that energy? So for that purpose, flywheel is required. So for first 5 seconds, flywheel will be storing, and in the 6th second, the storage of flywheel plus the energy of motor is together given to the cutting operation. This is how the flywheel is helping us. You can take it in this way, that flywheel is going to provide the same energy which it is storing. Previously what you were doing, power stroke, flywheel was storing the energy. In suction, flywheel was giving. In compression, flywheel was giving. In exhaust, flywheel was given. This time it is different. Previously it was, you are getting some salary first day, you are spending it every day. Now from that salary you want to give to your parents a car of 6 lakh rupees. So you are keeping 50,000 rupees in the saving every month. 50,000 January, 50,000 February, 50,000 month, March, April, May, June, you are going till that. Till November you have given 50,000 every month. And it becomes 5,50,000. Then last month you will get the salary 50,000, you will take 5,50,000 from the bank, total 6 lakh, you are going to purchase the car. So for first 5 seconds when cutting is not happening, flywheel will store that energy, and in the 6th second flywheel will provide it, and motor will also provide. Both together will get the cutting operation done. But my dear, you should know that if crank is rotating, let us say crank is rotating from theta1 to theta2 during the cutting operation. Let us say it is going from this to this angle when the cutting is going to happen. So there is some angle delta theta for which cutting is happening, but total time rotated by the crank is 2 pi. Similarly, during cutting, let us say plate is moving up to T thickness, and I am telling you during the cutting, the time for punching divided by total cycle time. This ratio will always be equal. You can also write it energy required in energy given by the motor during punching time by energy given by the motor by cycle time. And it can also be written as the thickness, which is distance travelled by the punch during operation, divided by the stroke length. So these all ratios are always going to be equal. But this is not of our use right now. We are going to make it useful by saying energy given by the motor during punching is punching time into power rating of motor. Energy provided during cycle time by the motor is cycle time into the power. What is the energy stored by flywheel is cycle energy minus punching energy. So you can say it is nothing but cycle time minus punching time into power. Then my dear, this delta E can be written as I omega mean square CS. So with this delta E, you can definitely find out whatever is required. Mass of flywheel, I of flywheel. Is it clear for everyone? Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Savi, Ashray, Vicky, Vinay, Darshan, Ajay, Abhi, Faninder, Shalom. Anybody have any doubt? Please ask. Very good. So guys, now we will be doing one question. After that we will go for break, because this question, okay, after this question one more thing I would like to tell you, the types of flywheel, and then we will complete this, and after this we would be having the break. Then after the break we would be having the gears and gear trains chapter. Okay, and then we will plan when to have the vibrations. Okay, and about machine design tomorrow also we will talk about. Okay, all these things we will have a discussion. So my dear, whenever we are talking about this, a punching press is driven by a constant torque electric motor. The press is provided with a flywheel that rotates at maximum speed. The radius of gyration of the flywheel is 0.5 meter. Press punches 720 holes per hour. So you can see the number of holes. 720 in 3600 seconds. 720 holes in 3600 seconds. Can you tell me what you will get with that? Can you tell me what you will get with that? Yes. What we will be getting from that? Can we say 1 by 5? One hole in every 5 seconds. So you got cycle time as 5 seconds. You can see they have given punching operation takes 2 seconds. So punching time is 2 seconds. They have given 15 kilonewton meter of energy is required for every punching operation. You know that energy required during the punching operation is energy cycle, which is cycle time into power rating. So it is given as 15 kilonewton meter. Time is 5 seconds. So I feel you can get power as 3 kilowatts. We got 3 kilowatt power rating is required. Very good, Aniket, for the motor. Now you know, we know the power. We know the delta E. What is delta E? Cycle time minus punching time into power rating. And that we can equate it with I omega mean square CS. So they have given you that maximum speed is 225 RPM. And you are given the minimum speed as 200 RPM. So omega mean will be maximum plus minimum by 2. 225 actually. And they have also given you delta omega. Okay, so just put these values here. you will be getting the value of mass, because they have also given the radius of gyration. Radius of gyration is also given. Put the value, get the answer, guys. This will complete your punching press part. And I am telling you, when I teach this in the class, then I tell you what is the difference between punching press, hydraulic press. Then I told you the criticality of the punching press. The operators, whenever they are working, they are given the insurance first, because if the finger will be coming inside, it will go on forever. So all those things are not required for gate. So that is why, means they are not required for exam point of view. They are good when we are understanding it for the first time. Tell me, guys, tell me guys. What would be the mass? You have every data in front of you, just need to find out the mass. Nahi, Faninder, that is not the right value. You need to see that delta E. This is, I feel, 9 kilonewton. Now it is 9 Newton meter. This is delta E. Radius of gyration is 0.5 meter. So m into 0.5 ka square. Then omega mean square. Omega mean is 212. Into CS is 25 by 212.5. Yes, everybody solve it. Farinder is getting 6.77. Everybody is getting the same or something different. Solve it, solve it. I feel I have solved this question for you. Let me see, do I have the answer for this? Answer will be coming out to be 618 kg. So some mistake is done by you. 618 किलो आएगा. Okay, these two questions are giving us all the types of calculation. Very good, Ajay, Ashray. Very good, very good. So some calculation error you may be doing. This is omega mean square. You can cancel this square. Now multiply, you will get the mass very easily. Clear for everyone? Okay. I feel we are doing some mistake. Because this is in RPM, na? This is not omega mean, this is n mean. Okay? So you need to write it as 2 pi by 60. You need to multiply by 2 pi by 60 ka square. Then you will get the right answer. Okay, I have not done that actually. This is delta E I omega mean square CS. So I is mk square. Yes, it is 0.5 ka square. It is also 9000 Newton meter. But when we are talking about omega mean, it is 2 pi into 212 by 60 ka square into CS is delta n by n mean. This is the case. Now you will be getting the correct answer. Everybody understood the mistake done by you guys and me? Very good, Abhi. Farinder, you will also get now. I feel so. Clear, guys? अरे भाई हरिकेश, delta E is nothing but what? Delta E is energy provided by motor in cycle time minus energy provided by punching time. Energy is power into T. Power is 3 kilowatt. Cycle time is 5 seconds. Punching time is 2 seconds. 9 kilonewton meter or 9 kilojoule. Okay. How we calculated the cycle time? How we calculated the cycle time? Because they have given 720 holes in 1 hour. So 1 hole in 5 seconds. So this is our cycle time. Clear, guys? Very good, Faninder. So I feel now everybody understood. So with this we have done it. Clear for everyone? So my dear, whenever we are talking about the types of flywheel, flywheel are of the 3 types. Rim type of flywheel. This is going to be like this. Complete mass is distributed outside. For this case, you will see the maximum velocity is given as, okay, first of all, when you will be finding out the force, it will be coming out to be rho v square. Okay. And when we are talking about the velocity, it would be having sigma by rho, where sigma is the permitted strength, permitted stress. Rho is the density of the flywheel material. So this is the restriction over the velocity. For this the derivation is done actually. So as a result you get the maximum velocity should always be less than equals to this. So these are depending on the material, both of them. So that is why whenever we are looking at this, we can say that velocity is less than equals to this. So we can write the velocity as r into omega. So my dear, if that is limited by some value of sigma by rho, I would like to say here that there is a restriction on omega. So this type of flywheel we cannot use beyond 1200 RPM. So for a modification, we come up with the flywheel with spokes. In the flywheel with spokes, we distributed the mass in such a way that velocity is restricted. V is less than equals to V max. But velocity is r into omega, which is less than equals to V max. So my dear, if you are going to take the mass towards the center by providing distributed masses, so when centroid will be coming down, r is reducing, you can increase the omega. So by providing flywheel with spokes, you can provide more omega. And similarly, when you go for the disc type of flywheel, it can be used for lakhs of RPM. And when we make the disc type of flywheel, we are making it in such way the thickness of this is reducing towards the center. Why? Because we have seen the stress is directly proportional to V square and stress is equals directly proportional to R omega square. So as radius will be more, stress will be more. So for more stress, more material, less stress, less material. Less stress, less material, more stress, more material. So I have given you all this detail. This is not required much for GATE. Till date there is no question on this from GATE. And if you want to see that in detail, I feel it is not required. But still if you want, you can tell me, I will go for it. But this is not required. You just remember this one formula. Otherwise this, when we are talking about, is important for engineering services, because in engineering services it is mentioned as design of flywheel. It is not important for GATE. Clear for everyone? If anybody have any doubt here, you can ask me, I will tell you. Otherwise the flywheel is over. Please tell me any doubt if you have. Harikesh, Savi, Ashray, Harsha, Falinder, Abhi. Clear? Forget about this. So this can be used for even lakhs of RPM. Savvy, actually whenever we are studying it as per the gate, we are assuming that there are no losses. Okay, so we are taking, actually you can see none of the place I have taken the losses. Okay, Ashray, that we will see. Actually in the gear, the major important thing is gear train, from which the numericals are coming. Gear is theory part, or you need to remember the formulas of path of contact, arc of contact. Those explanation we will not go, because otherwise gear alone is of 10 hours. I will just give you the formulas there. For gear train also we will see that. Okay. Dear, actually when we are talking about rim type, you know that this flywheel is going to be fitted over the crankshaft. So it doesn't mean that we would not be having the zero, we will be having zero mass in between. The point is, like you have the wheel of the cycle, don't you have the pins, thin pins which are connecting it with the shaft? Means majority of the part is at the outside. That is the meaning of this. Okay, fine. So guys, now we are going for the tea break. You tell me when we shall meet now after the tea break. After tea break we will go for Harikesh. Actually nowadays we are not using it. We are using actually this type of flywheel generally. Okay. I have given you just a example that the things are not like that. Ki for connection there are many ways. Okay. And also place to place the things will be different. Okay. Yes. Okay. So I feel 6:40 is there. Let us meet at 7:05 p.m. So we will be meeting at 7:05 p.m. and then we will be going for gears and gear trains. Fine guys. So just enjoy the break time and then we are meeting again, and wonderful motivation guys. Almost 8 hours are completed and still you are energetic. Wonderful. So we are meeting at 7:05. Okay, be ready after the break for gears. Now audio is coming, guys. Audio is coming. Fine, fine, fine. Okay. So guys, now we are going to start the topic gears and gear trains. Okay. So when we are talking about gear and gear trains, now we are talking about gear and gear trains. It is a very important topic. Gautam, refresh it. I feel voice is coming. Everyone is saying voice is coming. Okay. So when we are talking about gear and gear trains, first of all, my dear, I would like to tell you gear is meant for the power transmission. That everybody knows. Ki gears are meant for power transmission. Okay. So when we are talking about that, initially we were having two cylindrical discs 1 and 2. And when we were having two cylindrical discs 1 and 2, you can see if this disc is rotating with an angular velocity of omega. And when this is rotating with angular velocity of omega, r1 is the radius. Then my dear, this is the point of contact, and point of contact is given by Q in this entire chapter. So when yes. Let me check whether voice is coming or not. Yes. Voice is coming, guys. This is spam only, caustic. Okay. So when we are talking about velocity of Q, this O1 is the center of this device. You can write velocity of Q O1 is nothing but O1 Q into omega 1. So we can write it as R1 omega 1. Similarly, when you will be writing the point on the cylindrical disc, velocity will be coming out to be R2 omega 2. And if there is no slip, there is no sliding, then my dear, you can write R1 omega 1 is equals to R2 omega 2. So my dear, whenever omega 1 by omega 2 ratio is going to be R2 by R1, you know radius of disc is always a constant. So this ratio is going to be constant. So my dear, whenever we are going to get the ratio of angular speed as a constant, then my dear, such drives are said to be positive drives. If speed ratio is coming out to be positive, speed ratio is coming out to be constant, we call it as positive drive. And if speed ratio is coming out to be variable, we call it as negative drives. So positive drives meant that speed ratio will be constant. Yes, Akshay, same to you. And negative drive means that speed ratio will not be constant. Some people are thinking about the example, then belt drive, rope drive and chain drive are the example of negative drives. And gear drive is the example of positive drive. So whenever we are talking about positive drive or gear, actually in the positive drives or gears, slipping is not possible. Slip is not there. Sliding is there. Slip is not there. What is the difference of slip and slide? So my dear, right now here, if the sliding will be there, you know sliding will be happening in this direction. And as they are rotating with omega like this is the direction of velocity, this is the direction of power supply also. So in this direction, any sliding is said to be slip. But whenever we are going to provide the teeth onto the same, you know that now sliding will be present like this. So direction of power transmission is this, sliding is here. So in the direction of power transmission, if sliding is there, that is said to be slip. In the perpendicular to that is not said to be slip. So if you talk about this, yes, this if sliding is present like this, it is said to be slip. But if sliding is present like this, which is not in the direction of power transmission, then we call it only sliding, not slip. So in the gears also sliding is present, but in the gear slip is not present. So you can say sliding in the direction of power transmission, we call it as slip. So in the gears, slip is not present, sliding is present. Okay. So when the slip is not present, then omega ratio is coming out to be constant. There are some applications like automobiles, we are having differential. Then we are having clock. In differential of automobile and clock, we cannot have the variable omega ratio. If we will be having the variable omega ratio, the tires will be in our hand and clock will not tell you the correct time. That is why in both the application we cannot have the constant omega ratio. And if we cannot have the constant omega ratio in both the cases, we will be calling them, those applications will not be possible if we are not using the gears. So that is why gears are required where constant omega ratio is there. Gears are also known for more manufacturing cost. Manufacturing to material cost is highest in case of gears. Manufacturing to material, okay, is highest in case of gears. Now my dear, when we are going for the classification of gear, the first classification is with both the axes parallel. So if we are going to have both the axes of the gears are parallel to each other, we are having a generating line. If you rotate this generating line by 360 degree, you will be getting one gear. Rotate here by 360 degree, you will be getting two gear. And my dear, this type of gears are the gears coming under the category of both axes parallel. Now if you are also providing the teeth parallel to this axis, then my dear, we call them as simple spur gear. They are the very first type of gear. We call them as the simple spur gear. So we would be having one gear like this, other gear like this. And these are the teeth parallel to the axis of shaft, like this. The problem with these gear are having contact like this. Complete surface contacted were there, noisy operation, and as complete surface is coming in contact, it was looking like a slap. So if you are going for 30 RPM even, and let us say 30 teeth are there on a gear, then one revolution means 30 teeth. 30 into 30 means 900. So in 1 minute, 900 slaps will be there. So very high value of impact stresses come into picture. And because of impact stresses, these gears are good in slow or very slow speed application. Because of the impact stresses, they cannot be used for medium, high or very high speed application. They can use only for very, very low speed applications. That is the problem with the spur gears. Okay, that is the problem with the spur gears. So this is how they look like. Okay. Now my dear, when we found this, we tried to improve upon them by going for the helical gears. So what we have done, we have the teeth like this. We have given the teeth some angle like this or this. So this is said to be left hand helix. This is said to be right hand helix. So now we were having the teeth like this is one gear, this is another gear. So we have provided here the teeth like that, here the teeth like that. This is the axis of the shaft, this is another axis of the shaft. When you are going to rotate like this, okay. Now my dear, here what will happen when we are having this type of gear, helical gears. Now my dear, what is going to happen? Actually this time the engagement is becoming gradual like this. One teeth is left hand helix, other is right hand helix. So this time the engagement is happening like this. Previously it was this, now it is this. So first we were having sudden engagement, now we are having gradual engagement. So because of this gradual engagement, my dear, this time impact stresses are not present. And that is because of gradual engagement, there is no impact stress. So helical gears can be used for medium to slow to medium to high speed application. My dear, these gears are going to give us good results in 98% of the application. And 1% of application can be done by spur gear also. And spur gear is going to fail in 99% of the application. You can use the spur gears in the case of clocks, watches and all. And previously we could use it in the case of like bikes, first gear, reverse gear, but nowadays we are using helical gears only. So 98% applications are satisfied by helical gears. Helical gears are the wonderful thing. They are said to be the king of the you can say group, because they are going to use in majority of the application. Okay. So my dear, when we are talking about helical gears, I told you the reason behind that. But my dear, helical gear could not be used in one application. What is that? When we are having spur gears, the transmission of force from one gear to the other gear was happening like that. So all the forces were coming into the radial direction. You know, these are present on a shaft. Shaft is present on a bearing, and bearings are generally good in radial loads. So they can very easily bear the radial load. So life of bearing was very high in case of spur gear. But bearing is a cheap component, gear is very costly. So here gears were failing fast, bearing was having more life. But bearing is coming for 100 rupees, gears are coming for 10,000 rupees. So we don't want more life for bearing, we want more life for gear. That is why we went for helical gear. When we went for the helical gear, this time you can see they are like this. So force will be coming like this, which would be having an axial component also and radial component also. Because of this axial component, this time the life of bearing would be reducing. But there is no problem, because bearings, when we are using this type of bearing, when we are using axial force, when we are talking about, is coming to the bearing, because of which the life of bearing will reduce. Previously bearings were having a life of 5 years, now it may reduce to 1 year. Previously gears were having a life of 2 months, now they will be having for 20 years. So we are happy with that, because we want more life with the gears. We are happy for this. And then my dear, we moved to one more application where we wanted racing car and racing bike. So when we are talking about the racing car and racing bike, my dear, in racing car and bike we were requiring very high speeds. So because of very high speeds, this time bearings were getting failed in 10-15 kilometers. That is not acceptable. Because if there is a race of 22 kilometers, at least we should not change bearing in that race. So that is why we wanted some improvement over that. So to cancel the axial thrust, we provided the herringbone or double helical gear. Here on one gear itself, we provided left hand helix and right hand helix both. When we provided left hand helix and right hand helix both, the advantage of that was, if force is coming here like this, then their horizontal component will cancel each other. So once again there is no axial thrust and only radial force will be coming. So they are the best type of gears, because here no impact stress, because helical teeth are there, and also no axial thrust, because they are cancel out. But still we are using them in 1% application, because they are very, very costly gears, because 2 cuttings of teeth are happening here. I told you manufacturing cost of gear is quite high, because the machine is very costly which is cutting the gears. That is why we need to take care of that. Okay. Then my dear, if you are having the axis of shaft intersecting with each other, for that we will be requiring the bevel gear. And if we are having the bevel gear in such a way that this is one axis, this is another axis, and let us say we are having this generating line in such a way that both the gears we are getting as similar, means they are having same size. Okay, my dear, then this set is said to be mid-tray gear. Mid-tray gear we are going to get when they are of same size, so they will be rotating with the same speed. Okay, so like we have seen the spur gear, helical gear, herringbone gear, the same way bevel gear is also classified, because we are also having the helical bevel gear. So helical bevel gears are looking like that. So helical bevel gears are used in majority of the application, because normal bevel gears are once again having the same problem of impact stresses. So helical bevel are used. Even double helical bevel are there in the picture, but we are not using them much. Okay. So this is about the bevel gears. Okay. Then my dear, when we are talking about mid-tray gear, we have covered. The third classification is the spiral gear. My dear, here if you will see, the teeth are made curved. In the spiral gear, we are making the teeth curved. In the previous cases, the teeth were not curved. In the previous cases, Teeth were straight and inclined. Here you can see the teeth are coming curved. And this is the third classification, when axes are neither parallel nor intersecting. Let us say one axis of gear is this, other axis of gear is this. They are neither parallel nor intersecting, but they are in kind of different planes. Okay, just consider this. This is actually the surface of, this is the surface of hyperboloid. This is the hyperboloid. Okay, from this hyperboloid, if you are cutting it from here, then you are going to get this gear. We call this gear as hypoid gear. Okay, here teeth are made with the curvature, and we are also calling these curves as the skew lines. Okay, so this is the application we are going to use whenever the axes of the shafts are neither parallel nor intersecting. Like let us say one shaft is this, other shaft is this. Then we would be having the gears with both the axes neither parallel nor intersecting. Gears would be like this. Is it clear for everyone? Please tell me. Fine guys, fine guys. Now we are coming out like this is the example of spiral gear. You can see that. Okay, so you can see one axis is like this, other axis is like this. Both axes are neither intersecting nor parallel. Then we are going to have worm and worm wheel gear. They are the best example of this category. You can see the axis of one gear is like this, other gear is like this. You can say this is the worm and this is the worm wheel axis. Okay, so when we are having worm and worm wheel like this is worm, this is worm wheel. So this is also coming under the same category. My dear, when we are talking about worm and worm wheel, these are the special gears. Why special gears? Because whenever we are talking about worm and worm wheel, if we are having a single set of gears where we are talking about one pinion and one gear, then my dear, it cannot give you the speed ratio more than 10 to 20 at the max. If you want more than 10 speed ratio, we are always preferring the gear trains. If we want more speed ratio than this, we are looking for the gear trains. Okay, but my dear, worm and worm wheel is the alone set of gears which can give you this speed ratio more than 40 normally, and even we can go up to 200, 300, 400, 700, 1900 like that. So very high speed ratios are possible with a set of gears, which otherwise is possible only with the help of gear trains. So that is the wonderful advantage. Okay, and that's why sometimes we call them as reduction gear. Why reduction gear? Because my dear, worm is the driver, worm wheel is the driven. Here it is fixed. You cannot change the driver and driven. Always worm will be driving the worm wheel. If you are going to drive the worm with the help of worm wheel, the things are going to be in the opposite way. So always worm will be driving the worm wheel. Worm will be driving the worm wheel always. Okay. So guys, you can see almost 9 hours are completed for this class, and still we are having that level of energy. Teacher and student both are energetic. Yes. So just like and share the session for that. So my dear, always worm will be driver, worm wheel will be driven. And if you will try to make worm wheel as driver, then my dear, what you will find? You will see worm wheel will not be able to rotate the worm even though the teeth will be broken. The reason is, in the reverse direction, static friction is very, very high because self-locking condition is there. It is same like if you are going to have to play the guitar, you would be knowing in the guitar there are some wires, and those wires can be loosened and tightened by the keys. If you will just rotate the keys, those wire will be tightened or getting either tightening, or it would be getting softer, or it would be getting loosened. But my dear, if you will try to take the wire out, try to loosen the wire with hand, you cannot rotate key whatever you do. Because in the reverse direction, like screw jack, it is going to pick the car, but car cannot apply the force to pick you. Why? Because in the reverse direction, static friction is infinite. That you have seen how we can do in the engineering mechanics. Okay. So my dear, this is how the things are going to happen. So self-locking condition, worm is driver, worm wheel is driven, and high speed ratio. These are the identification of this type of gear. With this classification is over. Second classification is, this is the external gearing, and my dear, we can have the internal gearing as well. So we are going to have this as internal gear. So we have seen external and internal gears, we have seen mitre gear. This is the rack and pinion. When one gear is becoming straight, we would be saying this as rack and pinion. Okay, fine. Now my dear, we are going for the gear terminology. When we are talking about gear terminology, you can see this. I will be making the gears like this. First of all, I would like to tell you that you can see there is the outer circle going on. There is the outer circle going on. And we are going to say this circle, the name as addendum circle. This circle is known as addendum circle. Okay. And this circle is known as dedendum circle. Then my dear, there is a circle which is imaginary, but along that circle we are always having the pure rolling motion. We call this circle as pitch circle. Okay. My dear, there is one more circle, we call it as clearance circle. And this clearance circle is coming because whenever a gear teeth is cutting the profile, whenever a cutting tool is cutting the profile of gear, that cutting tool would be requiring some space for the motion. That is why some clearance is coming, we call it as clearance circle. My dear, pitch circle is the hypothetical circle, but every dimension अक्षय आज सुबह मैंने पढ़ाया है विटवर्थ क्विक रिटर्न मोशन मैकेनिज्म. ठीक है, अभी इस समय तो इसके ऊपर नहीं जा सकते क्योंकि मैंने पढ़ा दिया है. एक बार आप देख लेना, उसके बाद अगर आपको प्रॉब्लम हो तो आप मेरे को व्हाट्सएप पे कनेक्ट हो जाना, देन वी विल सेपरेटली कनेक्ट ऑन दैट. ओके, क्योंकि फर्स्ट चैप्टर में बता चुका हूं. अब दोबारा उसमें जाऊंगा तो बाकी सब लोग घूम जाएंगे कि सर सुबह हो तो गया, आपने शायद लेट ज्वाइन किया है. एक बार देख लेना, उसके बाद भी दिक्कत हो तो पूछ लेना. So whenever we are talking about this clearance, when you would be measuring the distance of addendum circle from the pitch circle, then this we call as addendum. And if we are going to find out the distance of pitch circle from this dedendum circle, we call it as dedendum. I would also like to tell you one more thing, that this dedendum circle is also known as root circle. But some people are having a misconception that this circle is said to be the base circle. So I would like to tell you that base circle is not the terminology of gear. Base circle is the terminology of involute profile. So until we are going to say that this gear is involute, we cannot talk about the base circle. So my dear, when we are having this addendum, dedendum, this is said to be the clearance. You can see all the dimensions majorly are measured from where? From the pitch circle. Pitch circle is the circle along which gears are always having the pure rolling motion. Yes, when we are talking about the thickness of the gear, here it is minimum, here it is maximum, you can see. But my dear, if someone will ask you what is the thickness of teeth, then my dear, we will be measuring it along the pitch circle. This is said to be the tooth thickness, and this is said to be the tooth space. In this space, the teeth of other gear will be coming. So my dear, you can see the distance from here to here. This we call it as circular pitch. This we call it as circular pitch. So we can say circular pitch is tooth thickness plus tooth space. Tooth thickness plus tooth space. Is it clear for everyone? It is going to be tooth thickness plus tooth space. This is said to be the circular pitch. And my dear, I would like to say, as tooth thickness of one gear is going into tooth space of other, and tooth thickness of this gear is going to tooth space of other. So that is why for two mating gears, circular pitches are always equal. So circular pitch of one gear is always equal to circular pitch of other. So we can say, what is circular pitch actually? Circular pitch can also be written as the distance. Like if I say pi d is the circumference of pitch circle divided by number of teeth. So pi d by z is the circular pitch. So if pi d by z is the circular pitch, yes, very good guys. So we can write pi d1 by z1, pi d2 by z2. You are saying circular pitches are equal, pi will get cancelled out. So d1 by z1 is said to be module 1, d2 by z2 is said to be module 2. So we are defining a term module which is d by number of teeth. Okay, so you can say for two mating gear, modules are always equal. D is the diameter of pitch circle, Z is the number of teeth. Is it clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Okay, so we are saying module of two gears will be equal. Module of two gears will always be equal. Now my dear, there is one more term that is said to be diametral pitch, which is defined as the number of teeth divided by d. So you can say, if that is the case, what is circular pitch into diametral pitch? It will be coming out to be pi. I also would like to say, in the diametral pitch, d is given in inches. Okay, and in circular pitch, when we define pi d by t, pi d by z, d is in mm. Module is also defined always in mm. Module is also defined in mm. Okay, module is equal for two mating gear and it is defined always in mm. Like if someone says module is 5, it is understood it is 5 mm. Okay, everybody got it? So my dear, module is the ratio of diameter of pitch circle divided by number of teeth. Okay, now my dear, generally the tooth space is kept more than tooth thickness, and the gap between them is said to be backlash. Why? Because whenever gears are mating with each other, I already told you sliding is present in the gear. Because of sliding, heat is generated, and because of heat, teeth is heated. Because of heat, they get expanded. So there are chances that teeth will be getting stuck into the space. So that's why we are keeping the tooth space to be more by tooth thickness by 5-7 mm. So that if expansion happen because of heat, they should not stuck between each other. Jamming should not be there. Okay, this is about the gear terminology. Now my dear, I would like to tell you, whenever we are talking about two gears, those two gears, pitch circles are always in contact. So if we are talking about two gears, this is the pitch circle of gear 1, this is the pitch circle of gear 2. Both are in contact always, and the point of contact of both the pitch circle is denoted by P. Okay, my dear, here a large number of derivations are coming which are based on trigonometry. One is related to law of gearing, other is related to path of contact, then arc of contact. We will not go for any of the derivation here. Otherwise, gear itself is a 12 hours topic. Okay, but for gate we require only results. So I will tell you the results only. Okay, and the same is the pattern of marathon for anywhere. If you will see marathon, we can discuss only that. Okay, when we are talking about this, you know that as I am saying, this is one pitch circle, as is another pitch circle. Two gears are always connected in such a way that pitch circles are in contact. and if their pitch circles are in contact, my dear, this would be the center, this would be the center. So my dear, you can say this is the line joining the centers, and this is the common tangent to both the pitch circle, and this point where they are contacting is said to be pitch point. So my dear, this is common tangent, okay, this is pitch point, this is line joining the centers, okay. Now my dear, when we are going to have one gear teeth is connected like this with the other gear teeth. So my dear, whenever we are talking about two gear teeth are connected like this with each other, we are having some point of contact. If this gear is rotating like this, then obviously this is transferring the power to this like that. So for that it is going to provide some force at the point of contact Q, and this Q is acting along a line which is said to be the line of action. This is the line of force along which the force is transferring from one gear to the other, and it has been observed that this line is perpendicular to both the involute gear profile. When it is found perpendicular to both the involute gear profile, then my dear, we are going to say that this is perpendicular to involute profile, that's fine. And this line of action, when we are going for law of gearing, which is going to say there should not be any slip, omega ratio should be constant. When we derive the law of gearing, from that we get a condition that this line of action is always passing through the pitch point. So if this line of action is always passing through the pitch point, I am making it like this. We are also calling it as common normal as it is perpendicular to both the involute profile, so it is said to be common normal. Here students are getting confused. Sir, if this is common normal, previous one is common tangent, they should be perpendicular to each other. But in reality, they are having an angle of phi between each other. So when common tangent and common normal, we are saying the angle between them is phi. The reason is common tangent is tangent to pitch circle, and common normal is normal to the gear teeth involute profile. So they are tangent and normal to different things. That's why they are not at 90 degree to each other. So they are at an angle of phi. That phi is said to be the pressure angle. Okay, and you can see this is force which is transferring. It is having two components. One will be F cos phi. This is going to help to rotate the gear. This will be F sin phi, which will be going to the shaft or bearing. So for us this force is very important. And you know, as phi will be increasing, F cos phi will be decreasing. So we are always saying that pressure angle should be limited to some value. Okay, it should not be beyond 20 to 25 degree, because more the value of pressure angle, lesser will be the force, difficult will be the rotation of the gears. Okay, that is the beauty of this. Okay, I feel everybody understood this. Now my dear, we already have defined the circular pitch as pi d by z. Z is the number of teeth. Okay, now my dear, backlash also we have defined. So whenever we are talking about law of gearing, as we are not going for derivation, but we have seen that this line of action is always passing through this fixed point P. And you also know this line of action was plotted at a point of contact Q. Is it clear? Yes. So I would like to tell you, when we are going for this line of action, we can derive this thing whatever I have said to you, and when you will be finding out, I am showing you 1-2 more points which will be helping us a lot. When we are talking about this gear like this, so in the full course we can derive all these things, but here we just need to go for the results. So we are having one more derivation which is telling us, like, point of contact will be moving from this point. Point of contact will be moving from this point and will move till this, because initially it will be starting like this, going like that. So point of contact will be starting this, then this, then this, then this, then this. If I ask you how many points of contact are there? If I ask you how many point of contacts are there? If I ask you how many point of contacts are there? How many point of contact are there between two gear teeths? Infinite point of contact are there. So my dear, if Q is moving like that, infinite points are there. And at infinite points, we can have infinite line of action. But when we are having these infinite line of actions, they are always passing through a fixed point P, which is said to be the pitch point. Then according to that, this here is passing from pitch point. So we can have a line of action going like this, going like this, going like this. Likewise, infinite possibilities are there. So according to that, we can feel that pressure angle may be variable, which would be changing with the point of contact. But my dear, when we are going to define a term that is said to be nothing but involute profile, then when we define the involute profile, here what we found, what is involute? If we are having a fixed circle, this fixed circle is said to be the base circle, and on this fixed circle, let us say we are having a straight line, and this straight line, we are going to have the motion of this straight line on this circle in such a way that the motion is pure rolling motion. In that case, if this line is here like that, after some time line will be here, after some time line will be here, after some time line will be here, then my dear, if you are going to see locus of any point, let us say you are talking about this point, this point will be reaching here, then here, then here, then this profile we call it as involute. And I am telling you, in this entire nature universe, there are only two curves. There are only two curves which follows the law of gearing. And one profile is involute, other is cycloidal. So these two profiles are given by mathematics, which follows the law of gearing. So when we are talking about this, you can see this line is perpendicular to involute, perpendicular to involute, perpendicular to involute, perpendicular to involute. And the same line is tangent to the base circle. From here we got that tangent to the base circle, tangent to the base circle is perpendicular to the involute. But we already know perpendicular to involute is nothing but the line of action. Line of action is perpendicular to both the involute. Yes. Hello Dikshit. So if that is the case, my dear, can we say tangent to base circle is the line of action? So line of action should be tangent to base circle. And my dear, if we are having two gears, let us say one gear pitch circle is this, other gear pitch circle is this. We are having at pitch point common tangent like this, and we are having base circle for both the gears like this. This is base circle for one, base circle for two. You know that we were saying more than one line of actions are possible. We were saying maybe one line of action is going like this, maybe one line of action is going like this, maybe other line of action is going like this, maybe one line of action is going like this. But now we know line of action should always be tangent to the base circle, and you will find there will be only one line which would be tangent to both the pitch circle. You can see this blue line. I am making this with red color to make it distinguish. Only this red line is the line which is tangent to both the base circles. That is why if only one possibility, we would be saying that only one line of action is possible. So pressure angle is constant in the involute gear. Whatever I have told you in last 5 minutes, that in the classes we derive it for 3 to 4 hours. But this is marathon, we are revising the things. We need not to go to the derivation. So what I have said here is This angle is the phi, which is said to be the pressure angle. So this pressure angle is going to be constant, because in reality what we understood? In reality we understood that it should be perpendicular to the involute, parallel and tangent to the base circle. So that is possible only with one line, and that is why pressure angle is going to be a constant. But my dear, you know that we are having infinite points. From infinite points we have infinite line of action. But we get to know these infinite line of action, it becomes actually one line of action, because there is only one line which is going to pass from the pitch point, which is perpendicular to involute and parallel to all both the base circles. It is possible only if all infinite points are lying on this line, which is very clearly shown by the animation, this one. You can see this is the line of action, and this line of action, when we are talking about, every point of contact is passing from that, because gears are moving also, na? You can see on every gear how the point of contact is moving. Just concentrate on one gear. You can see this gear, you can see this point of contact is moving like that. So only this one line is the line of action. The point of contact is moving, but point of contact is moving with the gear also, na? Teeth is also moving, na? So teeth is moving in such a way that point of contact will move along this line. Is it clear or not? Can you feel it or not? Bolo bhai. So we cannot go for the derivation of this. If you understood this, then also it is good. If you don't understand this, no problem. For the gate you need to remember the formula for this only. Okay? But yes, if you understand, that will give you a wonderful feel of mechanical engineering. Clear? And my dear, when this point of contact is moving along this straight line, it is going to follow some path. And that is why we need to find out what is the path of contact. So when you are going to find out the path of contact, for that we get some formula that I will be showing you. Yes, the formula for path of contact, whenever we are talking about, it would be nothing but Nm. What is Nm? I am showing it to you. It is starting from here and ending at here. So this is the path of contact. And my dear, this path of contact, great. If we are having this path of contact, I will show you one more figure. Let us say this is the pitch circle of 1, pitch circle of 2nd, or let us make the figure on the given figure only. We are having this to be the pitch circle of 1, pitch circle of 2. Let us have here the base circle of 1, here the base circle of 2. And you can see this line of action will be tangent to both the base circle, which is making an angle of phi. Okay, now my dear, you would be having something called as addendum circle. So addendum circle of 1 is coming like this, and addendum circle of 2nd will be coming like this. It will be above pitch circle only. So my dear, this will be the point where the contact will start, because contact of gear will be starting from addendum and it will be going till, you know, the 2nd gear. 2nd gear will be going till this point. So it will be going till the addendum of 2nd. So from addendum of 1st to the addendum of 2nd is the total path which will be followed by the point. So you can see this is the total path of contact. And out of this total path of contact, it is divided into two parts, and we call the very first part as path of approach, and this is path of recess. Path of approach, path of recess. Is it clear? And if you see the formula for that, it is mentioned here. You can say this is path of approach, let us say here the name given is KPL. So we are saying this is nothing but KP. Here RA is the addendum circle radius of gear. This is the pitch circle radius of gear. Phi is the pressure angle. This small r is representing the pinion. So capital R representing the gear and small r is representing the pinion. So you can see the formula. KP is giving you the path of approach. PL is giving you the path of recess. And when you will be adding them, KL, KP plus PL, this will give you the path of contact. Okay, you can have direct question from these formulas. Okay, so these derivation, this is not the time to go. If you have done it, you would have felt my words very easily. Is it clear for everyone? Now my dear, when we have this path of contact, we can have another formula for arc of contact. In arc of contact, we just need to divide it by cos phi. Arc of approach, divide path of approach by cos phi. Divide arc of recess by cos phi. Path of recess by cos phi. So the same formula, this is Kp by cos phi. This is PL by cos phi. This is KL by cos phi. Okay. Then my dear, contact ratio is defined as arc of contact by circular pitch. Arc of contact, we have already seen circular pitch is nothing but pi d by t. Oh sorry, pi d by z. This is the circular pitch. This is the contact ratio. Always remember, contact ratio whenever it is coming out to be 1.21, people are thinking it in a very wrong way. They feel that between one pair there is complete engagement. And between second pair engagement is 21%. This is wrong, because engagement can never be in percentage. Whenever you are having your engagement or marriage, you write in the Facebook engaged with him or her. You never write 50% engaged with him or her, because engagement either is there or it is not there. Either it is 100% or 0%. Engagement can never be in percentage like 50%, 20%. No. Engagement can never be in percentage. Either engagement is there or engagement is not there. So when we are saying 1.21, what do you mean by that? Ki one pair is in contact for 100% of the time, but second pair of teeth is in contact for 21% of the total engagement period. That is the meaning of 1.21. Everybody understood? Please tell me that. Everybody understood? Please tell me that. Everybody understood? Please tell me that. Shall we move ahead? Are we ready, guys? Till this point everybody understood? Then we will move further. Yes. Very good. Moving further. Now my dear, we are moving to the wonderful topic of interference. When we are talking about interference, if we are having a gear like this, you know that in this gear, when we are making the clearance circle, this part is non-involute. And this part is involute. And and we are having another gear, it will also have the same issue. And by chance, if involute part of one gear is coming in contact with the non-involute part of other gear, then my dear, this part is under problem. Because involute are going to be mate with each other. Non-involute and involute connection is not feasible. It is like whenever two persons getting married, they are not of same nature and they are having everyday fight, and someday one of them will do something bad with other. So the point is, whenever we are having involute, non-involute connection, then my dear, this teeth part will be taking the material of this out, and this gear after some time you would be having like this. After some time this part will be removed. So why this part will be removed? Because of this sharpness of the teeth. This will be removing this part, and that phenomena is said to be undercutting. This is happening because of interference. What is interference? When involute and non-involute connection is present, this is nothing but the interference, and as a result undercutting of gear will happen. Clear for everyone? As a result undercutting of gear will happen, which will be making the gears weaker, from the base, which is definitely not acceptable for us. So my dear, gears are very costly devices. They are coming at a very big cost. So as gears are very costly, so my dear, if someone is purchasing the gear, he is not purchasing for 1 year or 2 years, he is purchasing for lifetime. Gears have a life of more than 100 years. Okay, we need to overcome not from undercut, we need to overcome from interference, because undercutting is just the result of interference. It is like if you are getting lesser marks, you need to not avoid the lesser marks for that you shall not leave the giving of exam. No, you are getting lesser marks because you are not studying properly. So you need to work on your studies. Marks will automatically get improved. So you need to avoid interference. Undercutting will automatically be resolved. Undercutting is not a problem. Problem is involute, non-involute connection. Is it clear? Because undercutting is just the result of that, na? So if we are going to have involute, non-involute connection, they are not made for each other. The point is that. So they will cut each other. So initially you are feeling that this gear will get undercut. After some time this involute part will cut this part also. So both the gears will get cut with each other. So that phenomena is said to be interference, which is resulting into the undercutting, and we don't want this to happen. So if you don't want this to happen, you need to not reduce interference. We need to eliminate interference. So until a design engineer gives a guarantee that interference will not be there, manufacturer will not start manufacturing of gears. So gears manufacturing is done only when once there is a guarantee that interference will not be there. So there are various methods to eliminate the interference. What are those? Let us see one by one. So my dear, the very first method to reduce the interferences, why we are having a fear of interference, that interference will do the undercut. We want to avoid involute, non-involute connection. What if we ourselves provide the gears with undercutting? Then there will be no interference. We have already done what interference is going to do. But that is not the permanent result, or that is not the permanent इलाज. Permanent इलाज को क्या बोलेंगे? Treatment. That is not the permanent solution. This is good for low power transmission because you yourself is making the gear weak. So these gear will not have interference because you have removed the non-involute part. Now this will not be coming in contact. Now you can see when the gears are coming in contact with each other, non-involute part is not there in connection with involute part. Are you getting it? So involute and non-involute part will not come in contact of each other. So in that case you can go with these gear in low power transmission, like when we are going to use it in the clocks and watches. Yes, these gears can be used, undercut gears. They are the king of low power transmission. But my dear, they cannot be used for the high power transmission. So that is why this is not the permanent solution, this is a temporary solution for low power transmission. But yes, for low power transmission they are good, they are utilized actually. Then my dear, the second way is increasing the pressure angle. You know that when we were having the involute profile, you know that involute profile you were getting by the pure rolling motion of a line over this fixed circle known as base circle. So when this line was moving here, moving here, moving here, then my dear, you know the movement of this point that was giving you involute profile. So involute profile was coming by tangent to the base circle. So involute profile is present always outside the base circle. It will never go inside the base circle. So if involute profile will never go inside the base circle, my dear, if you are going to have this as a pitch circle of gear 1, this as a pitch circle of gear 2. My dear, if you are going to have, this is the base circle, this is the base circle. You know that common tangent is this and common normal is this. This is the pressure angle phi. My dear, you know that if you are making a gear like this, if here is the base circle, above base circle only involute is present. Involute can be above base circle only. Below base circle there is non-involute. That we know. So if you are going to increase the phi, it means you are going to reduce the base circle radius. If you will reduce the base circle radius like that, then obviously phi will increase. When you are going to reduce the base circle radius, no doubt involute part will increase, non-involute part will reduce. That is a good step. But I already told you that the tangential force is F cos phi. If the phi will be increasing beyond a range, then this force will not be enough to run the gear. That is why we cannot go with the high value of pressure angle. Shreya, sir, I always become blank when I see question on the interference question. What does it mean? I told you na, dear, interference, if it is present, it is involute, non-involute correction. So my dear, if you want to have avoid of interference, if interference is a kind of abuse for the gear, which if present in gear, gear will die automatically. So we need to eliminate the interference from the gear. That's what I am teaching you. So for eliminating, the first way was to provide the undercut. Second way is if you are increasing the pressure angle, base circle is reducing and non-involute is converting into involute. So if non-involute will become involute, the problem will be automatically removed. But the problem, my dear, is the force bearing pressure is not a problem, Raja, because in that case you will be having the bearing life to be suffer. Bearing is very cheap device. There is no problem with that. But the problem is that you will not be able to rotate the gears. Ft is less. And if gear will not be rotating, will you keep the gears in the showcase? So that is why to eliminate interference, we cannot remove the purpose of gears. That is the point. Is it clear for everyone? Is it clear for everyone? Everybody understood? Clear, guys? So my dear, that is why we cannot have the permanent solution with this also. This also is limited to some extent. Third is by stubbing of teeth. What do you mean by stubbing of teeth? एक वर्ड है फसाद की जड़ को ही खत्म कर दो. What is the problem? The problem is when this gear is entering into the non-involute part. The reason behind that is its big addendum. If I would be removing some part of addendum, the gear size will reduce. And if gear size will reduce, it will not enter in the non-involute part of the other gear. Like if I have another gear like this, I have reduced the size of the gear. Now the gear is touching only up to this. So this non-involute part is not having any connection of this. So this is a good one. If you are going to stub the teeth, you are going to reduce the addendum. It is a good one. There is no problem. But the problem is when we are reducing the addendum circle radius. When addendum circle radius is getting reduced, it has no effect on the pressure angle. Pressure angle is not going to change because of that, you know that. Am I correct or not? Please tell me. Am I correct or not? Please tell me. Just give me a minute, guys. Just give me a minute. Okay. So guys, now you tell me, when we are going for stubbing of teeth, stubbing means cutting some part of addendum. When I am going to cut some part of addendum, no doubt addendum circle radius will decrease. But here, will phi remain constant? Yes. I would like to tell you the base circle radius is given as pitch circle radius into cos phi. So when phi is constant, obviously RB is also going to be constant. So there is no problem with RB also. But you know, whenever we were having the formula for path of contact, in path of contact formula we were having RA. So when RA will be reducing, the path of contact will reduce. When path of contact will be reducing, the arc of contact will reduce. When arc of contact will be reducing, the contact ratio will be reduced. And contact ratio should be more, because if contact ratio will be going below 1, gears will leave the contact, lose the contact. So we cannot go with contact ratio less than 1. So once again, if this cannot be less than 1, this is once again a restriction. That is why this method may not be enough to eliminate the interference. All these methods, whether undercutting, increasing phi, stubbing of tooth, they are good methods, but they are reducing the interference. They are not completely eliminating the interference. So we wanted something which will be completely reducing the interference. For that, first of all, after involute, this method came after 8 to 10 years of involute. And after that 8 to 10 years, we get the final solution, which was increasing the number of teeth. Because if we are having this as, let us say, the periphery, if we are going to have one teeth like this, if we are increasing the number of teeth, then definitely the teeth size will automatically reduce. We are further increasing the number of teeth, the teeth size will automatically reduce. So when you are increasing the number of teeth, obviously my dear, when we are increasing the number of teeth, Here also the addendum circle is reducing. Phi is constant and base circle radius is constant. So because of RA reduce, here also path of contact will reduce. Here also arc of contact will reduce. But my dear, when we see the contact ratio, it is arc of contact by circular pitch. As you are increasing the number of teeth, what is circular pitch? It is pi d by z. So here if arc of contact will reduce, circular pitch when z is increasing, it is also getting reduced. And overall contact ratio is found to be increased. And when overall contact ratio is increasing, then my dear, this method alone is enough to eliminate the interference. So this method alone is enough to eliminate the interference. That's why this method is the most preferable method to eliminate interference. But my dear, if the number of teeth would be more cost will be involved. And we cannot spend more cost because economy also matters. So that is why we are using all the methods. Slightly undercut, slightly increased pressure angle, slightly stubbing, and then whatever is left, we go with the increasing number of teeth. So we are going to use the combination of all to avoid the interference. Okay, so we are going for combination of all to avoid the interference, and when we are going to find out the minimum number of teeth to avoid the interference formula, let me see here it is there or not. Okay. So guys, as we are aware, where is the space here? So as we are aware, as the number of teeth would be increasing, the interference would be reducing. But my dear, if we can avoid the interference with the 20 teeth, why we will be going for 22 teeth? Because more number of teeth means more cost. So if we can avoid the interference with the 20 teeth, we will never be going for 22 teeth. So we wanted the result for minimum number of teeth to avoid the interference. So when we are going to find out the minimum number of teeth to avoid the interference for pinion, we can derive the formula for that. And I feel everybody would be remembering that formula. It is coming out to be 2 times AP divided by what is the formula? Square root of 1 plus g plus 2, yes, sine square phi minus 1. This is the minimum number of teeth formula for pinion to avoid the interference. Here AP is said to be the fractional addendum. Why fractional addendum? Because you are using the stub tooth. So that is why, because of stub tooth, some part of addendum is removed. So what is fractional addendum? If you know the module M into AP, that is kept equals to addendum. Module into fractional addendum is addendum. From here fractional addendum will be coming out to be addendum by module. This is the formula for fractional addendum. And when we are going to find out this minimum number of teeth for gear, you would be having fractional addendum of gear divided by square root of 1 plus 1 by g into 1 by g plus 2 sine square phi minus 1. And my dear, here g is the gear ratio. Gear ratio is number of teeth in the gear to the number of teeth in the pinion. G is the gear ratio. Always more than 1. It can never be less than 1. Clear for everyone? So we have found out for pinion also, for gear also, and if you want to find out for rack and pinion arrangement, then my dear, the minimum number of teeth for rack is coming out to be what? It is coming out to be 2 times of AR by sine square phi. Is it clear for everyone? Yes, tell me guys. Tell me guys. So guys, I feel you guys will also be having an idea that tome is not going to be completed. The way we are going with, the speed we are going with, it cannot complete today. So it is not my fault. I am teaching you each and everything. Wherever you are asking the doubt, I am going with that. Shreya, AR is the fractional addendum. This AP, AG, AR. They are the fractional addendum of pinion, gear and rack. Okay. TG is the, okay, I am writing in different notation because here we are using number of teeth by Z. So I would be writing it ZZ by ZP. It is fine? Yes. So actually there are two subjects. One is tome, other is production. These two subjects I have never till date able to complete in one day. Always some topics are left. So now I would like to ask you, because anyhow we cannot complete it today. So would you like to have other topics with vibrations? If you will say yes, I will take other topics with vibration, yes. If you will say no, I will not take other topics with vibration, no. So would you like to have other topics with vibration? So what we are left with is cam, governor, gyroscope, balancing, vibrations. This is requiring 3 to 4 hours. They are requiring 1.5 and 1. Okay, around 7 to 8 hours work is there. Okay. Everybody, if I will take, you guys will come ना, for it is not like कि मैं session रख दूँ फिर लोग नहीं आए, मैं फिर 1 घंटे में बंद कर दूंगा उसको, ठीक है? Is it fine? Everybody is okay with that? Acharya, Ashray, tomorrow I cannot take because tomorrow already machine design is there, na? So tomorrow already machine design is there. Okay, I will see. If possible, tomorrow in place of machine design, we will go for the rest of tome. We will see that. I will make the plan accordingly. We will tell you. Clear for everyone? Clear for everyone? Yes. Fine. So I will talk to the team. If that is the plan, then tomorrow 6 PM session we will start from here only, and we will complete the tome in that, and then machine design we would be having someday, some other day. Clear for everyone? Clear for everyone? Fine. So today we are leaving here only because we have completed the gears. Now we are left with the gear trains. So gear trains I will be starting after that only because 9 PM I have paid course class. So anyhow we cannot complete it in next 30 minutes. So thanks for your love and support, guys. I'm really very happy to see your support. And this is my promise, if you guys will continue coming like that, I would be going for more and more, and till last day I will give you something which will be helping you in the exam. You already know from 21st to 31st we already have a plan of maths and FT. I am also planning a wonderful quiz of mathematics on 26th of January. Be ready for that as well. Okay, so goodbye guys for this particular session. We will be meeting tomorrow again and we will go for the pending topics. And tomorrow we are meeting anyhow at 6 PM. Tomorrow's timing is 6 PM. Don't forget that. Okay. Thanks, Harikesh. So tomorrow we are meeting at 6 PM anyhow. This is the time to meet tomorrow. Be ready. Mark it in the calendar. Enjoy in the morning whatever you want to do. 6 PM is the time to meet tomorrow. Okay. I would be putting this PPT into the group. Fine. So goodbye guys for this particular session. Thanks for joining. We are meeting tomorrow 6 p.m. and also Monday, Tuesday, Wednesday you would be having the practice session of Tom, MD and also the production. Aniket, this is just the love and support of yours. जब आप लोग आते हैं इतनी एनर्जी के साथ बैठते हैं 10 घंटे तो टीचर तो अपने आप एनर्जेटिक हो जाता है. Casting PPT, I already told you, Save is not saved with annotation. I will share you that PPT, but it will not be having annotations. Okay? Fine. So goodbye guys for this session.